Madeira? Madeira? Isto está carregado? Ok. 1, 2, 1, 2, 1, 2. 3, 4. E. C, E. 1, 2, som. C, E. 2, 2, 2, 3, 4. 1, 2, 2, 3, 4, 5, 6 e C, E. 1, 2, 1, 2, 1, 2, 3, 4. C, E. 1, 2, 1, 2, 1, 2, E. 6, E. 1, 2, 1, 2, 2, 2, 3, 4. E, A. C, E. E. Está com uma cara. Os 4 calma. C, E. C, E. E. Este som. E. E, A, C, E, 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 C, E, C, E, 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 C, E, 1, 2, 2, 2, ok. Dois, dois. E. C, E.
Good morning. Good morning, everyone. Please take your seats so we can start. I hope you enjoyed yesterday the program and you had a good sleep, so you're ready for our fantastic program for today. So we are going to start the day as we also did yesterday. So yesterday we talked about, so we had Brenda, the parent who had a child with RSV, and to raise awareness for how it is to have a child with RSV. But today we are going to start with the story of older adults who had RSV. So we had a couple who really wanted to come, but they weren't able to come, and you will see why, because they are not feeling too well. But we have, together with Anne Falsey and Ed Walsh, we made some nice interviews, and we made a nice movie, and we are going to start with that, and then we will have the first session. So let's start the movie.
So, I understand that recently you were in the hospital with respiratory syncytial virus. So, can you tell us a little bit about your background, medical history, any underlying medical conditions that you have?
I do have some COPD, but beyond that, no particular issues.
All right. And does it tend to bother you, or are you fairly active?
I am fairly active.
Okay. And I see you're wearing oxygen now. Had you been wearing oxygen prior to this illness?
No, when I went into the hospital with the RSV, they prescribed oxygen, and it has continued as I've come home. I just woke up unable to breathe. Got on a albuterol mist, and that quieted it down some, but I said, take me to the hospital. So I went into general by ambulance, and they did their thing for 3 days. The RSV was the worst.
Okay.
I mean, it closed me right up as far as breathing.
Mm-hmm. And how's your strength and your just general?
Oh, I don't think there's any question that I'm weaker. I definitely have lost weight. I'm probably down 7-8 pounds since the onset of this.
My RSV event started about 3 days before Christmas, where I felt tired. I was coughing to the point where I had Christmas Eve 2 events during the day where I was coughing so badly that it was spasmodic to the point where I just couldn't breathe. And once I stopped coughing, I was good, but it was a croupy cough. And by Christmas Day, I was extremely short of breath. I checked my O2 sat and it was 88 on room air. And I just decided that was it. Christmas Day or not, I had to go to urgent care.
3 weeks ago, I met you in the emergency room when you were diagnosed with RSV. Had you ever heard of that virus before?
Never, no.
Okay. So when we met in the emergency room, what was the primary reason you were there? What was wrong?
I was having a problem breathing, okay, which was very scary. Okay? When you can't breathe, believe me, it's scary.
You were in the hospital, I think, about 2 to 3 weeks.
Yes, you're correct.
So it took that long for you to start feeling better enough?
Yeah.
Yeah. If the doctors were to come up with a vaccine that could prevent this infection, would you think it worthwhile to take that?
Oh, yes.
Yeah.
100%.
It started on Sunday afternoon and it acted like a sinus drainage. And so I didn't think anything of it. And then on Monday, I started being shortness of breath. And so I went to the doctor on Tuesday and she gave me albuterol. That didn't seem to work. And Thursday night, I went to the emergency room in Rockport. They sent me to Strong and I was there for 6 days. And
That's where I met you.
yes,
So I noticed that you said you were on albuterol. Were you wheezing?
yes, terribly.
Do you have any underlying lung problems, asthma or emphysema?
No,
Okay, so this is something pretty different for you.
yes, it was.
Now I see these lovely looking little kids here. These are your great-grandchildren?
Yes,
And had they been sick as well?
yes. The week before I had this, they had ear infections, all three of them.
No.
They had their runny noses, their cough, along with the ear infections, and we think they might have had the RSV and we didn't know it.
Yeah, probably. It's
And-
all around.
Yep,
So you were in the hospital for 6 days. How long did it take you to recover once you got home?
2 weeks.
Okay.
I was tired, I was weak, and all I seem to want to do is sleep.
Yeah. Are you feeling all better now?
Yes, much better.
I'm so glad to hear that. So tell me about how your illness started. What happened?
I coughed a lot. And every time I coughed, I peed myself a little.
Oh dear.
So I remember putting up with that for like a day, maybe 2 days.
Uh-huh.
I just used pads.
Okay.
But I don't recall anything. I really don't.
Let me ask you this. Were you coughing so much that you weren't eating or drinking well?
Right.
Yeah, okay. And then you came back very confused, and that's when your sodium was very low.
Very
So
much.
How long were you in the hospital, roughly? A couple of weeks?
A good week,
Yeah,
maybe a little bit more than a week. Yeah.
okay. Has it taken you a while to recover when you got home?
I'm still not quite there, to be honest with you.
Okay.
I made a list of some of the things that I've really noticed is that I have anxiety, but it's actually been increased.
Okay.
My energy level is really low. My interest in things is really low. My confidence level is low.
Had you ever heard of RSV or respiratory syncytial virus?
Just before I probably contacted it, to be honest with you. We had probably chatted about it with friends because a couple of our friends worked in the medical field as well. So just in conversation, what's on the news sort of thing. Yeah. So I really didn't know anything.
Yeah.
But I was aware of RSV and, you don't want to get it.
Yeah,
Okay?
no, you do not.
I do not want to get it again.
So I think that would be my final question for you. Part of the reason we want to increase awareness is the major vaccine makers have all now completed pretty successful vaccine trials where it looks to be about 75 to 80% effective to prevent this infection and illness. And so would that be something, if somebody offered it to you in the future, you would be interested to receive?
Yes, I would.
have seen this, I don't know, 20, 30 times now, and every time I get emotional again. It's really important to raise also awareness for the older adults in RSV. So we will, also thanks to our RSV patient network, we will keep doing this. So if you know anyone who wants to collaborate with us to share their story, just connect them with us. It's time, so we start with the first session. Thank you. Dan and Joyce.
Okay, good morning. I think we've got a really exciting session planned with hitting on a number of topics that are going to be really important as the new interventions get rolled out in the next couple of years, sort of focusing on both the sort of classical surveillance aspects as well as sort of how we sort of integrate information about genomics of the virus on a global scale into our monitoring of the interventions. Yeah, we've got 4 great speakers lined up, and I'll hand it over to Joyce to introduce the first speaker.
Morning, everyone, again. So thank you, Dan. I'm the chair of this session with my co-chair. So I'll go straight to invite the first speaker in this session, who is Anne-Fleur Lengejit from the University of Medical Center Utrecht, Netherlands. So she's going to present on RSV evolution, the INFORM study. Welcome, Anne.
I'm only 30 years old, but I think I have to wear my glasses too, or it's my own, my own slides. So good morning, everyone. My name is Anne-Fleur Langendijk, and on behalf of the INFORM study group, I'm going to present about the INFORM study today. First presentation of the day, how exciting. I'm really happy to be here. I would like to thank the organizers for the invitation and the opportunity to share what I've learned about RSV evolution in the past years. This is my disclosure. So, my personal goal is to better understand the global evolution of RSV. And some people in the audience may know that I've been studying the evolution of RSV for quite some time now, and that I'm passionate about trees, both phylogenetic trees that are used in molecular epidemiology and real trees. And here you can see some of the trees that I have photographed during previous RSV conferences and my own vacations. And this includes the biggest tree of Ghana, that you can see here. And also some trees in Asheville during the RSV symposium in 2018. And it turned out that the Uber driver that drove us up the mountain for our little hike, that he almost lost his son due to RSV. And that made me realize the importance of our work and of this conference. I must warn you, this presentation also contains several phylogenetic trees. So my presentation consists of 3 parts. First, I will talk about the temporal and spatial diversity of RSV. Second, I will share about molecular epidemiology in RSV literature. And third, I will present new exciting data on the conservation of RSV-F and the nirsevimab binding sites. So let's start with the temporal and spatial diversity of RSV. This phylogenetic tree from NextTrain shows the epidemiological history of RSV through the time. And the timeline on the x-axis runs from the 70s until now. The different colors demonstrate different countries, and each dot represents a patient sample. So what do we see here? We see that most of the dots cluster together, indicating that there is less diversity within countries compared to the diversity on a global level. If we, for example, take a look at Vietnam in reds, we see that they've almost been at the same spot since 2008 for different seasons. So let's move on to the available literature on molecular epidemiology. To give an overall impression of RSV genomics in literature, we summarized the genotypes per continent from 2050 to 2020 in a recent systematic review. And here we show that Ontario 1 and Buenos Aires 9 were the most reported genotypes for RSV A and B. In our systematic review, we showed that while we obtained sequences from all continents, most sequences were derived from China, with 12%, followed by Kenya, 11%, and the USA, 9%. 22% of all sequences derived from low and middle income countries. And of all whole genome sequences, only 4% derived from low and middle income countries. So sampling effort is crucial in low and middle income countries to timely detect development of resistance. And this is, of course, also the case for countries with high burden and high population. So to timely detect development of resistance to RSV monoclonal antibodies, vaccines, therapeutics. And in this, global whole genome surveillance studies are required to ultimately understand the mechanisms underlying RSV global circulation patterns. So this figure shows the temporal distribution of global RSV sequences. And although the INFORM study has contributed to samples in the most recent years, we still see that data from 2050 to 2090 are lacking for multiple countries, especially in South America and Africa. Recent data are rare. So why molecular epidemiology? Why is this so important? Well, with the recent EMA approval of nirsevimab, monitoring susceptibility becomes increasingly important. As recently illustrated by the emergence of a subtavimab neutralization-resistant RSV-B variant, molecular surveillance programs are needed to monitor the emergence of polymorphisms, conferring reduced neutralization potency, to ensure enduring monoclonal antibody effectiveness between successive RSV seasons. So just to fresh up your memories about the INFORM study, I would like to share our study aims. The primary aim of the INFORM study is to investigate the molecular epidemiology of RSV isolates from a global population of children. Our secondary aim is to provide a repository for whole genome sequences. This is a brief summary of our study methods. So the INFORM RSV study is a global clinical study, currently conducted in 19 hospitals in 17 countries all over the world. We cover all continents. The INFORM RSV study started in 2017, so has been ongoing for 6 years, and we're still going strong. We recruit hospitalized RSV-positive children under the age of 5. Each site collects 50 to 100 samples during every RSV season, and these samples are shipped to the Netherlands, to the UMC Utrecht, where they're being sequenced. We perform whole genome sequencing using NextSeq 500. And afterwards, we perform consensus genome by de novo sequence assembly. We have published our sequencing methods, so if you're interested, please read our method paper. So now I would like to move forward with a really exciting part about the conservedness of RSV-F. So here we show the phylogenetic tree for both the F and the G gene for RSV-A at the left and RSV-B at the right. Each dot represents a patient, and the different colors correlate with the different inform countries. This is only data from our first inform season, so that's why only 8 countries are included in this phylogenetic tree. But the thing I would like to demonstrate here is that RSV is less diverse. RSV-F is less diverse than RSV-G. And you can see that because RSV-F has less branches than RSV-G. So recently, we assessed the geotemporal prevalence of RSV-A and B and the nirsevimab binding sites conversation between 2015 and 2021 using over 5,700 F protein sequences from 3 prospective RSV studies. These are 3 molecular surveillance studies: Outsmart RSV, conducted in the USA, Inform RSV, and also a pilot South African study. So our data show a total of 5,735 F sequences derived from those 3 prospective molecular epidemiology studies from 2015 to 2021. And both RSV-A and RSV-B positive samples were obtained from a total of 17 countries across both northern and southern hemispheres. RSV-A and B co-circulated globally, with RSV-A predominant during 2015, 2018, and 2020, and RSV-B predominant during 2016, 2017, and 2018 in both hemispheres. So RSV-F is highly conserved. The nirsevimab binding site has been highly conserved, over 99% at all positions of RSV-A-F, and in 22 out of 25 positions of RSV-B. And this was because of demutations in the subtevimab binding sites. The palivizumab binding sites displayed a similar high degree of conservation. So Shannon entropy is a measurement of amino acid diversity. And our Shannon entropy analysis illustrated that amino acid variability was predominantly concentrated in the non-extracellular regions of the RSV-A-F protein. We also performed historical analysis, and here I show you the phylogenetic analysis of historical RSV-F, SARS-CoV-2 spike, and influenza sequences. And these phylogenetic analyses reveal that RSV-A and RSV-B-F possess lower genetic diversity than other class 1 viral proteins. So RSV-F turned out to be historically conserved as well. We did not only demonstrate this in our own analysis, but also based on historical sequences. So this graph derives from historical analysis with a comparison of RSV to SARS-CoV-2 and influenza. And this high degree of RSV-F sequence conservation was reflected in lower amino acids residue variability to both RSV-A and RSV-B in comparison to other viruses. So we also performed this Shannon entropy analysis on the historical sequences. Shannon entropy analysis revealed a high degree of nirsevimab binding sense conservation from 1952 to 2021. So to conclude, first, RSV continues to evolve. And that's why ongoing surveillance of circulating strains is necessary to detect molecular changes over time and their impact on susceptibility to nirsevimab neutralization, and also potentially other monoclonal antibodies in development. Second, genomic data, preferably whole genome sequences, are needed to study RSV evolution worldwide. And third, our recent findings demonstrate a high degree of conservation within the nirsevimab binding sites from 1956 to 2021. Well, of course, I'm the only visible part of the INFIRM study today, but without the team, this study would not have been possible. So first, I would like to thank our local investigators. I would like to thank the team at Julius Clinical, AstraZeneca, KU Leuven, and the UMC Utrecht. And I would like to give special thanks to Robert-Jan Lebbink for the impressive sequencing work. I would like to thank you for your attention, and I would be happy to take any questions.
Yeah, it's time for questions, and we'll take only 3 questions, and then we move to the next speaker.
Hello, my name is Octavio Ramilo and I work at St. Jude Children's Hospital. Thank you for your nice update on the INFIRM study. It's nice to see this continue to evolve. Now, I was very intrigued when you look at the evolution of the F protein over time, but you only look at the nirsevimab site, right? Binding site. I was wondering if that longitudinal analysis will pick up the history of subtamimab, that those RSVBs that have the mutation that were resistant to that monoclonal. Do you have the type of analysis that you are doing, are you able to see that?
Yeah, that's a really good question. Indeed, we also picked up the mutations in the subtamimab binding sites.
You would?
Yeah.
Okay.
Yeah.
And are you able to see when they came from? Because I was wondering, that occurred without any intervention, right? We don't, okay, personally, my bias is that everything we are seeing is natural evolution because there is not enough pressure on any way of any vaccines or monoclonals. That's my bias, right? So that's what I was wondering, if using that longitudinal evolution since 56 to now, you were able to figure out where those RSVBs were more appear or something like that, if you were able to track that down, or you will be able to do it with your current data banks.
Yeah, that's actually a very good question. Also in our systematic review, we were able to pick up the specific years for the subtamimab mutations to arise. And you're right, it happened like spontaneously without any pressure. So I think it's still hard to tell where it came from.
I know that the data is very biased, is what you get, right, from where the samples are available and information. Do you have a sense if in certain parts of the world the variations occur more faster or not, or the northern or the southern hemisphere on RSV-A or B? Do you have a general sense how that is happening, or is it still too early to be able to tell that?
I think it would be really interesting to look at subtamimab mutations in various countries. And we have tried to look into that for our systematic review. It's only a problem that we lack a lot of data from most of the countries of the world. And the temporal, especially the temporal data, for most studies, we only have data from 1 or 2 years. So we don't have data from big molecular surveillance projects on this. So I think it would be really hard to tell.
Do you think that most of the strains are for children or from adults?
From children.
Right, because that would be another good comparison as we hold the new vaccines coming up. Thank you.
You're right,
I think this is a very important project. Thank you.
Thank you so much.
could you sort of comment a little bit on, just given the diversity that you're seeing in the samples, sort of what level of intensity of surveillance you might need going forward to monitor potential emergence of variants as nirsevimab rolls out in different parts of the world? What would sort of an optimal sampling scheme look like going forward in the next few years?
Yeah, that's also a very good question, especially now during the rollout of nirsevimab. I would like to highlight that it's so important to continue molecular surveillance. And I would argue that whole genome sequencing is really important in this, not to only sequence F and G as well, but there is so much more information in the other genes. And also for genotyping, we would argue that whole genome sequences are better than just genotyping based on the G protein. So I would say that like molecular surveillance studies that cover as many countries as possible, cover continents, that we should continue with that to pick up any resistance, possible resistance in the future. Because that's, of course, the problem what happened with Septemvimab. We were just too late with picking up these resistant strains. If there would have been any molecular surveillance ongoing, we would have been able to pick it up at an earlier stage. So I think this is a big lesson for all of us. And I hope this highlights why molecular epidemiology is so important.
Yeah, thank you so much, Dan, for that interesting presentation and very informative. We'll now invite the next speaker, Pedro. So he's going to present on the monoclonal antibodies for respiratory syncytial virus, the evolving epitope landscape. Welcome.
Good morning. It's a pleasure to be here, and actually thank you for setting my talk. So you did a lot of my introduction. With that, let me go ahead and begin. And this is my disclosure statement. And these are the areas that I would like to cover in 15 minutes, which is very difficult to cover deeply. But overall, we'll just mention some of the promising monoclonal antibodies that are there. We'll talk a little bit about the viral genome and its sequence variability, all focus on the F protein. We'll talk a little bit about the major monoclonal antibodies and the sites that they target and the relevance of that. The known mutations that are already occurring, and how that may impact the future, and a perspective. This y'all know very well, and if you think about vaccines, most of the vaccines focus on the F protein. And as Anne stated, the F protein is very well conserved between the A and B viruses. Monoclonal antibodies, likewise, most of the monoclonals will also focus on the F protein at different target sites. So palivizumab will be for antigenic site 2, nirsevimab will be for antigenic site 0, and the Merck monoclonal antibody will be for site 4. Doesn't matter. You tell me afterwards. So nirsevimab, we know that Synergis or palivizumab is currently licensed, but nirsevimab will be really the most likely the first long-acting monoclonal antibody that will be available in the U.S., and it has already been approved in Europe. And it is for all infants, both healthy and preterm during their first RSV season, and also for other high-risk infants during the second RSV season. So a concern that I have, and I'll pose this question at this time, I don't need an answer, I just need just so that you all will be aware. A concern that I have as a pediatric infectious disease person is when we consider the widespread use of therapeutic agents, will they lead to the development of treatment-emergent viruses. And if you think about antivirals, that's always a concern, in particular when we treat infants where mutations are higher or immunocompromised individuals. And so that's a concern. So the question that I have, if we use these long-acting monoclonal antibodies for all the population of infants under a year of age, will that lead to emergent resistance or emergent mutants at the population level? Not at the patient level, but at the population level. And will such mutations thereby make the monoclonal antibody ineffective? And so that's a concern, a question that I have for y'all. So by this time, I think y'all are all expert in molecular virology and on the fusion protein, that it can exist in many forms, but there are at least two major forms that we're well aware of. The pre-fusion form, which is the active form that is required for fusion, and that contains some unique antigenic sites. And then the post-fusion form, which is the stable form, but it's not the active form. And there are some antigenic sites that are shared between the pre-fusion and post-fusion form. If we think about palivizumab, it targets site 2, which is found both in the pre-fusion and post-fusion form. If we think about nirsevimab, that is primarily a pre-fusion monoclonal or a monoclonal antibody directed to a pre-fusion site. There is cetuximab, which you all know the story well, and that is also a monoclonal antibody that was directed to a pre-fusion site, site 5. And then there is Merck monoclonal antibody that is directed to site 4, that is also found in the pre-fusion and post-fusion form. Actually, before I go further, I just want to set up the next slide, and that is to remind individuals that there's a P27 site that is split, that is cut off, and it forms the fusion protein into an active form, and you have the F2 unit, subunit, and the F1 subunit. Most of the antigenic sites are going to be found in the F1 subunits, and there are some, in particular those that are part of the pre-fusion site or pre-fusion form, are going to be found also in the F2 subunit. Why do I say that? I'll show you why in a second. This is data that we had published a few years ago. And I want to set up the slide because it's a little bit complicated. But this is the major domains on the fusion protein. And if you look at the gray columns up here, it's looking at the different antigenic sites. And what we did here was compare the vaccine strain, A2, to what we were able to download from GenBank and from our own depository on RSVA. And overall, you can see that if you look at what we call synonymous changes, so nucleotide changes along the fusion protein that does not cause a change in the amino acid, so it's conserved. And you can see that for the most part, the A viruses along the F1 subunit are very well conserved. There are a few sites that appear to change, and in this case, it's the P27. If we look at the B viruses, and this is in comparison to an A2 strain, we see a little bit different story where there are many different nucleotide changes that do not result in an amino acid change. So it's still very well conserved. But now you start to see somewhat more changes that are non-synonymous, in particular in your pre-fusion antigenic sites. Well, now moving a little bit further forward, this is unpublished data. This is something that we've recently been looking at. And what we're now doing is looking at A2 versus all the recent RSV Ontario strains that one can download from GenBank and say what's happening with the Ontario, because that's the genotype that is currently circulating. And we can see the same type of picture, that there are many synonymous changes that occurred. But if we start to look at the non-synonymous changes, where the new amino acids are changing, they're in the F2 subunit. And they are oftentimes in the pre-fusion site for site 0. If we do the same analysis, but now look at the prototypic RSVB 18537, isolated back in the early 1960s, and compare it to the Buenos Aires isolates, again from GenBank, and there are over 1,000 of those sequences here, we see a slightly different story. From a big picture, you will see that it's mostly in the F1 subunit where non-synonymous changes are occurring. And where are the non-synonymous changes occurring? Primarily in the pre-fusion antigenic sites, site 5 and site 0. Those sites that are relatively well shared between the pre-fusion and post-fusion form are conserved. You'll know this story very well, but I put it here to tell you that this was not caused by immune pressure from the monoclonal antibody. This is what we call a community emergent mutant that basically resulted in the failure of this very excellent monoclonal antibody, because the RSVB isolates during that time transitioned from 1 to 2% resistance to 100% resistant in a very short time. The monoclonal antibody, if you look at the cumulative incident rate, this is the placebo, these are the treated individuals, beautiful. But for the RSVB, it was a different story. Nirsevimab, as y'all are well aware, has excellent efficacy against RSVA and RSVB isolates at this time. And this is just a reminder to show you that it's working very well. And most likely by this coming year, 2023-24, it will be licensed in the US for use. So this is something that Anne was talking about as well, and that is, can we look at variability to try to predict what's going to happen in the future? And so the F protein is very well conserved, without a question. But I believe there are some hot spots in the F protein that we have to be worried about, and we have to be looking for. And so what we did was an entropy analysis to ask the question, what are the hot spots on the F protein? And we looked at the top 5% where there was greater variability. So what do we mean by entropy? If you have an amino acid that's 100% conserved, your entropy level is 0. There's very little movement there. But if you have an amino acid where there's significant variability among the different amino acid possibilities, then your entropy level is much higher. And those are areas that one has to watch out for. So this is a little synopsis of a table that highlights, if we look at palivizumab, targets antigenic site 2, it's licensed. What are some of the known mutations that have occurred either in vitro or has been identified during breakthrough infections? And there are a number of them. And then one looks at what are the high entropy positions for the RSVA isolates and RSVB isolates. And they have amino acid position at 276. That is at the far end of antigenic site 2. We haven't seen natural mutations to the 276 position, but that's a hot spot for antigenic site 2. If we look at the Regeneron, Sotrovimab, the target site is site 5. We know that it failed because mutations spontaneously occurred at these two amino acid positions on the F protein. If we look at the high entropy positions for site 5, we don't see any for the RSVA isolates. But what we do see is those very same 2 amino acid changes were hotspots for site 5. And there's, well, here you see it. What do we know for nirsevimab? Target site 0, it's been approved. It will likely be approved by the FDA for the use in the United States. There are known mutations that has caused resistance to site 0 monoclonal antibodies. They're a little bit different between RSVA and RSVB isolates. 201S is one to worry about, and this is one of the high entropy levels. I will just also bring your attention to 206 and 209. In a subsequent slide, I will show you why. For the MK1654 antibody monoclonal, target site 4, these are some of the known mutation sites, and we only have one high entropy level at position 463. So why does that matter? This is Anne's data. This is from the INFORM study, the first year, where there were 8 sites, 8 countries that were involved. And as she stated, they were all from children under 5 years of age, and the majority were under a year of age. What is interesting is these are the known mutation sites on the different antigenic regions that were identified. And if you look closely, there is B, 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 this is site 5, B, B, and A, this is site 0. And then for site 4, there are 2 A's and 1 B's. My comment is you will see more variability in the RSVB isolates that are occurring than in the RSVA. And that is something that we need to follow closely as we start to use monoclonal antibodies, maybe potentially for all infants under a year of age. Excuse me. This will be the last data slide, just to say that this is another study that looked at a variety of different populations of infants from different countries. They sequenced RSV isolates, both from A and B, and they were looking for minor allelic changes. And guess what? Same story comes out. It is the RSVB where there is a greater number of minor allelic frequencies that are occurring. Why does that matter? Because one of those may develop a better fitness. And we need to watch out for the antigenic sites, because if there's a better fit virus, it will replace all the others, just like we saw with septimumab resistance. So from a perspective, this is the same calling that Anne raised, and that is we really need very good global surveillance. We have established a pretty good baseline of what the sequences look like in the last, let's say, decade, but more recently in the last 5 years. And we need to implement this globally to look forward as to what's happening over time and to be able to look at the geographic spread of mutants as different countries implement different types of policies for the prevention of RSV. Will treatment emergent resistant likely emerge at higher frequencies in infants and immunocompromised individuals when they're treated? If one looks at historically, the answer has always been yes. For other viruses, respiratory viruses, influenza is a good example of that with antiviral drugs. What will be the impact of monoclonal antibodies with regards to RSV epidemiology? Will we see replacement of viruses, of other viruses coming in with it during that season? Or will the monoclonal antibody provide what I would say sufficient, not protection, but there will be sufficient susceptibility in the population that will allow for the normal epidemiology of RSV to continue. So this is going to be, I think, very exciting times from an epidemiologic purpose as to what happens with RSV both in terms of sequences and in terms of whether there will be replacement by other viruses with time. I think it's very important that monoclonal antibodies target critical areas on the F protein so that the virus is less fit and unlikely to replace other isolates if mutations are to occur. And then lastly, with these long-term monoclonal antibodies, what is the impact? And so far, there's been very limited impact of antibodies targeting the antibody itself, the monoclonal. Will it shorten its half-life and make infants, some of them, not more susceptible, but a shorter duration of protection compared to 150 days, which is expected with these long-acting monoclonals? With that, thank you, obrigado, muchas gracias. That's about it for my language.
Thank you, Pedro. So we'll take 2 questions. At the end of this session, we have an interactive session with all the speakers. So those who will not get an opportunity, you can ask your question during that time. Thank you.
Good morning. Kina Swanson, Pfizer. Very nice presentation. And I just want to second the call for expanding genomic surveillance, especially with the expansion of sequencing for SARS-CoV-2. If we can leverage some of those capabilities for RSV, that would be wonderful. My question is really around the RSV-B and why it seems to be so much more prone to mutations compared to RSV-A. And can you speculate whether you think there's some subtleties in differences of virus-host interactions with RSV-B compared to RSV-A, or more with replication machinery?
That's a good question, and I don't know, I don't have an answer. And so I hope some molecular virologists out here will be able to provide a better answer. But what I can tell you is right off the bat, there are very subtle differences in its replication cycle, looking at RSV-A versus RSV-B. And its impact, we don't know. Wanderson, who is here, who's a graduate student, so I'm going to be telling you all, he has a poster out here, is looking at the P27 region. And the P27 region is what needs to be fully cleaved to make a difference in having a fully functional F protein. There are clear differences between RSV-B and RSV-A isolates in the efficiency of B27 cleavage. What does that mean in the biology? I do not know at this time.
Hi, Pedro. Great talk. Aurelio Bonavia from the Gates MRI. I understand why we're focusing on the F is the vaccines, the monoclonals are targeting F, and it's very clear, the data. But if we're worrying about something going in a resistance imparted by the monoclonal antibody or the vaccine and circulating in a better way, we should also be sequencing the rest of the proteins, because the fitness could be a double mutation with a non-structural or even a structural protein. So I think the sequencing needs to be expanded from F even to G, because G helps binding and also replication.
Agree 100%. I mean, the central conserved region of the G protein may be also a very important target. And I know that cost for a single monoclonal will be high, but I think in future generations, when we think about monoclonals, we may need a combination, a cocktail, to try to avoid resistance from basically wiping out the efficacy of such a monoclonal antibody.
Tony, that was a great talk. I would love to have 2 hours to ask you a question, but they will not let me do it. But I'm going back to Kina's question. B and A, the difference is in G, right? That defines RSV-A and G. And we are talking about F. So do you think there is any other part of the sequence of the virus that contributed to this difference that we are seeing in variability on A and B?
So the answer is yes. I mean, when one does whole genome sequencing, you will see other variabilities. And in fact, if you do phylogenetic trees, you oftentimes will look and see very similar type of trees depending on which gene you're focusing on. I think another one that's important for us to look at is the polymerase. We have very little, I say, not good data, but we don't think so much about polymerase until you think about antivirals. But I think the polymerase also plays an important role in what we may be seeing, the difference between A and B as well.
And before this, the chair, the experience on the coronavirus monoclonals that also prolonged duration and their emergence of resistance, do you think that the fact that we are so excited with the prolonged half-life monoclonal and they will linger, that will make them more susceptible to induce resistance?
So I think that is a concern, and that is a question that is raised here. And again, I think this is the importance of having good epidemiology to be able to track as things happen. Think about what happened with Subtavumab. If we had not had epidemiology to demonstrate that these mutations arise de novo, we might have thought that they were caused by the monoclonal itself, but that was not the case. And so I think it's important to be able to kind of have good molecular virology in place to be able to see what happens as different modes of prevention come in.
Thank you so much.
Hi. Thank you. Thank you very much for the talk. I found it very interesting. My name is Victoria Jenkins, and I work at Bavarian Nordic. Your focus of the presentation, quite rightly so, is looking at monoclonals and the impact of these mutations on maybe the binding of these. I wondered if you've considered also with the widespread uses of potential pre-F vaccines, whether you think that any of these mutations might impact the ability of these vaccines to be efficacious over the long term.
So I have biases. We all have biases, right? So I've studied vaccines almost all of my life. And so I like vaccines from the perspective that you're able to induce really a polyclonal response. And so if one site mutates, there are still other antigenic sites that are susceptible to antibodies that will make that virus ineffective. So your question is very good, and I don't have an answer other than to say we need to see what happens in the future as we change the immune pressure imposed on the virus. Will we have more rapid molecular evolution of the virus due to changing immune pressure? Will we have particular sites that are more likely to change? I think we will have to wait. I think we will see some of that. How it will impact future therapies, I'm not sure.
Thank you.
All right. Thank you very much. And our next speaker is Dr. Sidi Hervé from WHO. He's going to talk about RSV surveillance and new country level data.
So morning. Really appreciate the opportunity to share some of our experiences and some early outcomes from this ongoing WHO RSV surveillance project that we've undertaken since 2015. Just one disclosure, I'm not a virologist, neither am I a molecular biologist, so keep that in mind. So nevertheless, I outlined my talk to give a quick overview on the RSV surveillance strategy that we've promoted since 2015. Give some early flavor of the data that's emerging out of this project, and end my talk with some thoughts on plans for RSV surveillance going forward. Where do I have the...
Pedro, did you take the pointer?
Aha.
Here's, oh, yeah.
Oh, okay, so sorry. So this map, colored by the 6 WHO regions, shows the two main data sources for RSV surveillance. We have the 25 countries which are part of this project across all 6 regions, and I've shown them in a darker shade of the same color. We have 7 from the Afro region, 4 from the PAHO or the Americas, 6 from the EMRO region, 2 from Europe, and 3 each from the CRO and the Wipro region. The second data source is around 22 countries, which I've shown on the map with the oblique lines, that report RSV surveillance results in their national surveillance bulletins, which are available on their on their websites. Most of these countries are from Americas and from Europe, and a few of them do overlap with the countries that participate in our project. But we also have a third data source, and that's primarily from the PAHO region, which as part of the SARI ILI surveillance, they also test for a panel of respiratory viruses and report this data to the FluNet platform of WHO. So based on these 3 data sources, we summarize the RSV activity in our influenza biweekly assessments that's published on the WHO website. The reason I show this slide is also to point out to the major data gaps that are there, especially in the regions other than Europe and the Americas. So to give a quick overview, on the upstream part, we piloted a strategy in 2016 in 14 countries to try to leverage existing capacities of GISRIS, the Global Influenza Surveillance and Response System, for RSV, with the objective, of course, like most surveillance systems, to better understand the seasonality, the burden, the risk factors, the high-risk groups. But more importantly, while doing so, try to establish laboratory and surveillance standards for RSV, assess the performance of a broader ARI case definition, what we call the extended SARI case definition, which does not mandate the criteria of fever for screening and testing for RSV. And of course, with the overall goal to try to build evidence that would inform guidelines for both vaccine introduction and immunization when these products do become available. So this strategy was then sort of revised and expanded in 2019 to 25 countries. From 14, we jumped to 25 countries in phase 2 of this project. And the differences were that we included RSV typing, not just RSV detection, but also RSV sequencing. But more importantly, we made a call to focus on children less than 2 years of age, as compared to the pilot phase where we were testing for RSV across all age groups. So the ask was relatively straightforward. We asked ministries of health to commit and to take ownership of RSV surveillance with a standardized protocol, participate in the WHO RSV QA, the external quality assessment programs, do year-round testing of at least 400 children less than 2 years of age using the broader extended SARI case definition. Also report case-based data to the WHO platform, not the FluNet platform, but the RSV data platform on InFluMart. And we're also looking at targeting a total of 1,000 positive specimens for sequencing, and of course then upload the sequence data to GISAID. From the WHO side, the support was primarily technical, providing technical guidance, standardized protocols, RT-PCR kits, primer probes through the international reagent resource, and of course ad hoc need-based support for ancillary reagents, laboratory reagents, and shipment of specimens to the RSV reference laboratories as necessary. So we've had 3 EQAs so far. The last one was in 2022. And I'll just maybe quickly mention a couple of things about the last EQA. So for the first time, we expanded the EQA to even non-project laboratories. So not just the 25 participating countries, but beyond. So the panel consisted of 12, the EQA consisted of 12 panels, 9 contemporary viruses, both A and B, with a range of CD values, 1 historical virus and 2 negative controls. So the panel was sent out to 83 laboratories, 73 returned results, by almost 88% return results. Overall performance was good, with 98% of the RSV detection and 88% of RSV subtypes being correctly reported. Performance was better, which we assessed on a score of 24, maximum score of 24, in project laboratories compared to laboratories from non-project countries. A sample with high CT values was more likely to be associated with an incorrect false negative result, and incorrect results at the same time, whether false positive, false negative, or wrong subtype, could not be consistently associated with either the extraction method or the amplification platform or the primer probes that were used. So let me now jump straight into the data. But before I do that, I would like to put the data in context. Note that we all know that there were significant disruptions in RSV surveillance, both RSV and influenza surveillance in the phase 2 of the project, 2019 onwards. And countries had to suspend existing surveillance for varying periods throughout 2020, 2021 due to the COVID-19 pandemic. We all know that. In fact, quite a few of our new countries which joined in phase 2, Lebanon, Philippines, Nepal, for example, had to defer their initiation of the RSV surveillance. But despite these challenges, 21 of the 25 countries conducted surveillance during the pandemic, but with just about 9 countries able to test the required number of sample size of 400 per year and report results to the WHO data platform. The average number of weeks under RSV surveillance was around 21 weeks in 2020, and it kept on gradually increasing to 27 and now 33 in 2022, sorry. So overall, in the 3.5 years of phase 2, 2019 to 2022, we were targeting for almost 36,000 tests to be done, but we could achieve about 28,000 specimens tested in children. And again, these are children under 2 years of age. So the table gives the WHO region-wise breakup of specimens, but note that in some of the regions, and I take Africa for the Afro region, for example, a lot of the samples come from South Africa. So there's definitely a lot of variability in the quantum of data that's available by country in these regions. The age distribution is as desired, and we had asked for an equal sort of proportionate sampling for the 4 age groups that we're looking at, 0 to 3 months, 3 to 6 months, 6 to 12 months, and 12 to 24 months. So that was there. Interestingly, the proportion of data that comes from ICUs also ranged between 7 to 20 years across the years. So this map shows the RSV percent positives, and what I've done is I've averaged over the reporting weeks for the different years during the pandemic. And those are the colors based on the intensity of the level of RSV percent positivity. The pie graphs show the distribution of RSV type or if it's untyped. So in 2020, overall, we had a mean RSV percent positivity, which was around 14% amongst the 16 countries that reported. RSV activity was high, and we can make out from the different colors in the graphs. In 2020, it was high in Madagascar, moderate in Australia, Russia, South Africa. But overall, in 2020, RSV-A seemed to be more common, 35% compared to RSV-B, which was around 9%. But noting that 55% of the specimens in 2020 were untyped. In 2021, the RSV percent positivity was higher at 26%, with high activity. Again, you can refer to the map in Australia, Qatar, Uganda, Chile. RSV-A continued to be more common as compared to B, again noting that almost 50% of the specimens were untyped. In 2022, the percent positivity continued to remain high, with high activity again in Australia, Philippines. But this time we see RSV-B being more common, 36% compared to RSV-A, which was around 23%, again with the caveat that 50%, almost 43% of them, of the specimens were untyped. This is a little messy graph slide, but I just tried to group the project countries into the northern hemisphere, northern temperate, that's the left panel, the tropics, which is the middle panel, and the southern temperate, the right panel. So it shows the trends, the RSV activity trends for the different years. I've averaged, the pink line is the average trend pre-COVID, and we have different color lines for 2020, 2021, and 2022. Again, the caveat is the data is quite sparse, but overall it seems to indicate near zero activity in 2020, a partial sort of resurgence with atypical seasonal patterns in 2021 and 2022. This slide shows the median start week, the top panel, the median peak week, the middle panel, and the median length in weeks, the bottom panel, for the years 2017 to 2022, but I've excluded intentionally the years 2020 and 2021 when the patterns were, everything was, the dynamics had changed. The reason I've done this only for those countries that had enough data which allowed us to calculate these parameters. So it would be interesting, as it was mentioned yesterday also, to see how 2023 and subsequent years pan out and how seasonality compares with the pre-COVID years. I think we've seen different variants of this graph. Dan also showed yesterday similar sort of graphs looking at seasonality patterns. I've taken one such country example from a project, the left panel, to illustrate typical RSV seasonal activity pre-COVID and how it was impacted by COVID and the possible return or resurgence of RSV activity to pre-COVID levels and patterns. The graph on the right side, I think it's a little more interesting because we have influenza, and this is data source from FluNet. We have influenza on the top, RSV and other respiratory viruses in the bottom panel on the right side. What's interesting is that RSV seems to have resurged much earlier as compared to influenza. It's come back in 2021, while influenza took quite some time for it to come back. One can always speculate on the reasons behind this. As I mentioned earlier, we also asked countries to share clinical data, case-based data, and just an early look at the data. It's to look at some of the predictors. As expected, I'm just referring to the univariate odds ratios here. The risk for RSV is highest in the very young infants, 0 to 3 months and 3 to 6 months, even as compared to infants more than 6 months, 6 to 12 and 12 to 24, as expected. Fever, interestingly, again, is less likely to manifest with RSV in very young infants. And hence, again, I think it makes a case for using a broader case definition that does not mandate fever as a criteria. Also interesting is the need for respiratory support, which was higher for RSV across all age groups. Switching to genomic data, and I'm on a bit slippery ground here now. So we have a total of 30,000 plus sequences in GSID, majority of them FSG gene, of which just about 5,600 are whole genome sequences. But if you look at the more contemporary sequences, the number of whole genome sequences comes down to just around 2,500, and I've taken the cutoff as 2019 onwards. This is all from data from GSID. But interestingly, the majority of these sequences, the whole genome sequences, almost 3 out of 4 of them, of the 1,900 plus sequences, contemporary whole genome sequences that are there, are contributed by laboratories that are participating in this, from these 25 project countries. The graph on the right panel just shows the 15 top contributors for the whole genome sequences, again the contemporary sequences, many of them from the WHO RSV reference laboratories or project countries. So this is work in progress. That's the sort of caveat. But some preliminary insights into the phylogenetic diversity of RSV. Now this tree is for RSV-A and includes about 115 representative sequences taken from our 11 project countries. And the country of origin and the years are marked in different colors. So to try to summarize this, so all viruses in this, collected during this fall within the genotype 2.3.5 or the Ontario 1 lineage genotype, except the 3 sequences that we used in the root. We have about 10 clades in this tree. But take the example of Brazil, and I've marked it green here with the green arrows. We see Brazil sequences from Brazil's in different clades in the same year, in 2021, possibly an example of co-circulation or diversity of RSV strains in the same year. On the other hand, we have sequences from different years, 2019, 2020, and I point to the example of Philippines in orange and Russia in magenta color in the same clade, indicating probably local endurance of the virus over the different seasons. This tree is for RSV-B, includes 95 representative sequences from 10 project countries. To note that all the viruses in the tree fall within the BA9 genotype. Take the example of Côte d'Ivoire, marked by the brown bronze arrows. Again, an example of diversity where viruses in the same year, 2017, fall in different clades, GB505A and GB504A. On the other hand, again, sequences from Mongolia, the violet arrows, from different years fall within the same clade, indicating local endurance. We also have the example of Brazil and Argentina on the top of the tree. Argentina is in blue, Brazil is in green, where they all fall in the same clade. And again, it's interesting to note that all these viruses come from Buenos Aires and the bordering neighboring states of Brazil. So the geographic proximity is there. So this analysis is really exploratory, not designed to verify any of these hypotheses. And again, to note that the findings could possibly be biased by the sampling strategies, how the sequences were selected, the sample size itself, the geographic distribution, amongst other things. But at the end of the day, I think as Maria Zambon puts it, I think these genetic differences are possibly quite small, but the importance, I think, would depend on how these differences play out phenotypically in terms of severity, in terms of how they impact any of the products. So my last slide, just some thoughts on where we go from here vis-a-vis RSV surveillance. I think without doubt, I think it's important to build on the gains that we made with countries, especially low middle income countries, in building surveillance capacities for RSV, not only with the purpose of monitoring RSV in the post-pandemic period, post-COVID-19 pandemic period, but also building that baseline evidence for countries to make that decisions on vaccine introduction and immunization. We also are now in the process of integrating more and more pathogens into our global influenza surveillance and what we call the GISRIS Plus. And countries, we would definitely encourage countries to sort of take a building block approach and integrate not just SARS-CoV-2, but also RSV and potentially other respiratory viruses of pandemic and epidemic potential as part of the GISRIS Plus strategy. But at the same time, we need to make sure that our GISRIS Plus strategy is also aligned with the other strategies that are sort of high-level strategies that are being discussed and probably would get rolled out in the next year, 2 years or so, whether it's the global genomic surveillance strategy with this pathogen agnostic. We need to make sure it's aligned with the HEPA, the Health Emergency Preparedness and Response. So trying to piggyback the attention on pandemic preparedness and try to sort of use that opportunity to get RSV along with this in these efforts. So the plan is to try to go from a project to a program mode. When this will happen will, I guess, depend a lot on the resources and the interests that countries, but that's the general direction we would like to take, where we try to integrate RSV as part of a broader respiratory pathogen surveillance globally. Just the very last slide to acknowledge the many stakeholders in this endeavor, starting from the national influenza centers, the national public health laboratories, the epidemiology bureaus in the ministries of health, and of course the technical support that comes from the RSV reference laboratories, the individual experts, the WHO advisory group. Some of them are present here, and GISAID has been a valuable partner for us, and of course my colleagues across all 3 levels of WHO, but not the least also thanks to the investment made by the Gates Foundation since 2015. Thank you.
Thank you. And I think we're a little bit behind schedule, so I think we're going to have to move right to the next speaker, and we might have you back up for the discussion in a few minutes. So our last speaker for this session is Brian Nyawanda from KEMRI, who's going to talk about country-level estimation of RSV disease burden in Kenya and South Africa.
Good morning, everyone. My name is Brian Nyawanda. I work with the Kenya Medical Research Institute. And I want to talk about country-level estimation of RSV burden in Kenya and South Africa. A lot has been done globally, and it is estimated that we have about 33 million RSV-associated ALRI cases globally. And we have about 3.6 million hospitalizations and about 100,000 deaths annually. So this is important, but then it's important to contextualize this to policymakers at country levels. So we have these disclosures. These findings are those of the authors and do not necessarily represent the position of KEMRI, CDC, or the NICD in South Africa, and we declare no conflicts of interest. So to RSV surveillance in Kenya, KEMRI KEMRI and CDC have been conducting RSV surveillance in Kenya, in Western Kenya, specifically in Siaya. Siaya is in Western Kenya, somewhere there. And KEMRI Wellcome Trust have also been conducting RSV surveillance in the coastal part of Kenya. And we have the KEMRI Kilifi part down at the coast somewhere there since 2002. We also have influenza sentinel sites, which KEMRI and CDC have been collecting data from and samples from since 2007, and they are starred as shown in this particular map. So we also wanted to estimate RSV-associated ARI, and here we used population-based surveillance data. And KEMRI and CDC, again, have been conducting this population-based surveillance somewhere in Western Kenya, somewhere there, and in Nairobi, which is there as shown. In South Africa, the NICD have been conducting surveillance since 2009 in the green parts as indicated in this particular map. So we have the Western Cape in Cape Town, and these other sites as shown. From 2012, they added outpatient surveillance, and they've been testing all the samples at the NICD in Johannesburg. For healthcare utilization data, they've been conducting HUS to estimate the non-medically attended cases. So the objective of our work was mainly to estimate the outpatient burden and the non-medically attended RSV-associated burden. We also wanted to estimate the hospitalized and non-hospitalized severe acute respiratory illness that is attributed to RSV. And also we wanted to know the in-hospital and out-of-hospital deaths that are associated with RSV at the country level. It was also very important to estimate this by age groups, so we were looking at children under 5, but we were really interested in knowing from birth, from month 0 to month 59, what the burden was actually. So what were our data sources? So the first important data source is the surveillance hospitals that we work in, and the population that we study, the population that we follow up. The next important source of data is a sentinel surveillance sites, where in most countries, as you know, flu set up this kind of surveillance. We also need health utilization surveys data for us to be able to estimate the non-medically attended cases. Then we also need some literature review to understand the risk factors for SARI and ARI. For us to be able to estimate the prevalence of these risk factors, DHS data was very important for us to understand the prevalence by different regions. As you are aware, the DHS data is powered to estimate the regional prevalence of some of the risk factors. And these risk factors include overcrowding, include malnutrition, non-exclusive breastfeeding. We have passive smoking, and also HIV. For us to be able to estimate the actual numbers, we need the population census data as well. How do we estimate these rates? So the first step is to estimate the incidence in the base region. So what is the base region? The base region is where we conduct the surveillance, the first hospital where we conduct the surveillance. So we estimate the incidence of SARI or ARI in that particular region based on the data sources that I had indicated, that is the hospital and also the population there. And we do this by fine age groups as I had stated. Now, since most of these surveillance, as I mentioned, are for influenza, we know that there is a bias of fever. So this needs to be corrected, and I think for South Africa, that is what happened. There was an adjustment to take care of the proportion that is, attributed to fever. The next step is to estimate the adjustment factor. So this adjustment factor is based on the prevalence and the relative risk of the risk factors, which, as I mentioned, we get the prevalence from the DHS data, whereas we get the relative risk data from literature, and this will depend on the region where you work. The next step is to estimate the regional incidence, and here we majorly just multiply the adjustment factor by the regional, by the base incidence, sorry. Then the next step is to estimate non-medically attended disease, and here we use the health utilization survey data to get the proportion of people who don't go to the hospital. Then the next step is to estimate the burden that is associated to or attributed to RSV. And here we use the Sentinel surveillance data to get the proportion of specimen that were positive for RSV. And this proportion, we apply this to the incidence of SARI or ARI in all the regions. And then the last step is to estimate the number of cases from the number of cases that are associated with the RSV, that is the severe cases and the non-severe cases, the medically attended and non-medically attended cases. And this we use the census data to obtain. We also interested in estimating mortality, and here the first step was to, it was not easy to get the deaths, so we used the CFR, the case fatality rate, and this we simply now multiplied with the incidence that is attributed to RSV in each region. For us to get the out-of-hospital deaths, we again reviewed literature to find the ratio of in to out-of-hospital deaths. And here, Lee et al. Published last year in The Lancet was very useful, and we were able to obtain that ratio, which we applied to our in-hospital deaths in step 7, for us to be able to obtain the out-of-hospital deaths. For us to get the number of deaths, we just now multiplied that rate with the population data. So to some of our results, in Kenya, we estimated that majority of medically attended ARI was occurring in month 4 and 5, and this was also seen in the non-medically attended ARI. And as we can see, the rate was almost the same for medically attended ARI and non-medically attended ARI. But when you look at hospitalization, majority of the hospitalized cases were occurring, that is down here, were occurring in the first 6 months of life. And when we adjust for healthcare utilization for us to obtain the non-hospitalized cases, we see that we have at least 3 times more cases which are not hospitalized. In the case of South Africa, we observed, again, most of the cases were happening in the first 6 months of life, but then we see another resurgence in the second year of life there. That is for medically attended ARI. But then when we look at the non-medically attended ARI, in South Africa, we see that this was like 2 to 3 times more compared to medically attended ARI. Looking at hospitalization, similar to the case in Kenya, we see that the majority of cases were happening in the first 6 months of life. And when we look at non-hospitalized cases, this was comparable to the hospitalized cases. And looking at deaths in the two countries, now here we just applied the ICFR, so we saw that it's important to just highlight the CFRs. And we see that for South Africa, there is a drop from the first 6 months of life as we head towards 5 years of life. But for Kenya, the highest CFR was in the 6 to 11 month age category. So what are the implications? Sorry. When we look at the number of cases by regions and by counties, this is very important for countries where health is decentralized, to counties or to regions. We were able to estimate the number of cases by regions, and this is for ARI. And nationally, we estimate about 1.2 million cases in Kenya. And when we look at non-medically attended cases, we estimate about 1.3 million cases annually. Again, for the severe disease, the map is almost similar to what we see in the ARI cases. But then the highest rate was in Nakuru County, which is somewhere there. And looking at the numbers, we see about 21,000 hospitalized SARI in Kenya annually, and about 3 times more of these are not hospitalized. And we see between 2,000 to 3,500 deaths. We estimated 2,000 to 3,500 deaths in Kenya annually for RSV. This slide simply now summarizes what we observed. We observed that the highest burden of RSV is in the first 6 months of life, and this highlights the necessity of prevention through maternal immunization or through monoclonal antibodies, which can be delivered at birth or soon after. Overall, we have about 2.6 million cases in Kenya annually, and about 85,000 of these are severe, and we see about 1,500 deaths. The burden, as I've shown, differs by regions, and if countries were to prioritize regions, it will be important to have the burden by regions as well. One limitation of this method is that it does not capture all geographical differences that may exist. So when interpreting this data, or if you use similar methods, then this needs to be considered. And lastly, I would like to acknowledge the people that we've worked with at CDC, Cambry Wellcome Trust, NICD, University of Warwick, BMGF, PATH, and LSHTM. Thank you so much.
We have some time for questions.
Hi.
Meredith Rickmorrow, CDC. Excellent presentation. I wondered if you had any hypotheses about why you continue to see a higher case fatality ratio in children who are 6 to 11 months and older compared to the less than 5 months in Kenya, and if you've done any additional analyses on that.
Yes. This we majorly attribute to late healthcare seeking in that particular age group. Yeah.
Thank you. My name is Mohsen, Professor of the Health Science Metric in University of Washington. I think the crucial number that you used in your calculation was CFR, case fatality rate, because based on the case fatality rate, you came from the incidence to the mortality. My question is that how did you calculate case fatality In other words, case fatality was for the fatality in the hospitalized kids or in the hospitalized and non-hospitalized. That non-hospitalized was outpatient and subclinical, or because your case fatality rate was very high based on everything that we have. Then I suspect that your case fatality was based on the clinical, especially hospital incidents. Is it correct?
That's correct.
Okay.
Our CFR was estimated from the hospitalized cases.
Okay, then I think that your number for the deaths overestimated, because if your case fatality is based on the hospitalized kid, when you multiply it in the incidence, that incidence is non-hospital and hospital, automatically your deaths shows high. Is it correct?
For the hospitalized, for the in-hospital CFR, we only apply that to the hospitalized cases. But for us to estimate the out-of-hospital deaths, we apply the in to out-of-hospital deaths ratio.
Okay, then this case fatality rate was from hospital?
From hospital only.
Okay, then you included severe cases?
Yes, for severe cases.
Thank you.
Thank you.
Harish Nair from University of Edinburgh. So, nice presentation, Brian. I was wondering whether you had any chance to look at geographical variations in incidence over time, because you've been able to estimate by counties, for example, for Kenya. And so is there any geographical variation in incidence over time? So do you see that the incidence in certain years, in certain counties is higher compared to the others? And also whether you see any difference between counties in the peak age for RSV hospitalizations. I think, with very granular data that you've got, I think it would be very interesting to sort of see whether we are seeing certain patterns that are emerging, which would help inform immunization policies. I think that would be important thing. And a comment, I think if you're using the word SARI by its very nature, the way the case definition works is it's in hospitalized kids. So then I think when you say non-hospitalized SARI, it's sort of counterintuitive. So you may want to use something like severe non-hospitalized, but calling it SARI, then it sort of gives, it would not be the most appropriate way to say this, but it's more pedantic.
Thank you very much for those comments. So to start with the first one about the regional estimates by time, we have a different publication about this by 3 regions of Kenya. So it shows clearly the seasonal patterns by the 3 different regions. That we did not include in this presentation, but it is available. To the second one, about the use of SARI. So we just use the term SARI, but our case definition for SARI is actually cough or difficulty in breathing. So
then I think you shouldn't call it SARI, because when you say SARI, it's the WHO's case definition of SARI, which is only applicable to sentinel sites, which are hospitals. So if you say SARI for outpatient clinics, I think the problem is that there's a diverse audience here. I can understand what you're meaning to say, but there's a diverse audience, and then people start interpreting it in certain different ways. Just a suggestion.
Thank you. Well noted.
All right, so we have a few minutes for the end of the session, so we'll thank Brian again, and then maybe invite the other speakers up just for a brief general discussion. So could all the speakers, you could stay on stage, and I don't know if Ana Flor and Pedro and Hervé can just come up for a few minutes. So we have some time for general questions, and I might just sort of start just having Anna Florence City up here. I mean, so we heard about sort of two sort of large genomic efforts from WHO and from Inform. I wonder if you could both sort of comment on how those efforts relate to each other, if there are any efforts to try to sort of combine together, data and harmonize data between the two systems.
I mean, as far as WHO is concerned, one of the sort of conditions is for whatever sequencing gets done needs to get uploaded into a public accessible database like GISAID. So all the sequences that we have, we try to get them out on the public platform. Same for Inform. So I guess we are talking of the same data set, I guess.
We also cover different countries.
Okay, we can go to Maria.
Hi everyone. My name is Maria Sundrum. I'm from Marshfield Clinic in Wisconsin. I have a question about epidemiological surveillance systems. My first love is influenza, and I know that many of the influenza surveillance systems that we might be using for RSV might not be perfectly tailored to RSV. I'm curious to know your thoughts on information about, for example, the length of time from symptom onset to specimen collection, if that type of information is valuable, if it's available by region or by age group, and what other epidemiological gaps do we have in surveillance for RSV that we could start to try to fill?
So I'm not sure whether I got your question correctly. You're talking of influenza systems, surveillance systems not being the best for RSV. Well, as part of this initiative, what we've tried to do is, yes, I mean, we all agree that surveillance has definitely, it's not research. So there are definitely some gaps out there. But what we also seen that for RSV, the efforts that we made was trying to target that age group which historically had been underrepresented in influenza surveillance, the very young age group. So we had countries initiating new sites in pediatric wards in pediatric hospitals. Now, regarding I think you had a comment on the duration between onset and well, in a typical surveillance at a global level or even at a regional level, we don't collect that sort of information. We just collect aggregated numbers. But as part of this RSV surveillance, we made that effort to try to get all these dates. So we have that information, and but we can always look into it and see how well it compares in terms of whichever parameter you take.
So I think we just have time for probably two more questions. So maybe here, and then I think that's Grant McKenzie in the back, if I can.
Thanks. Beate Kampmann, London School and Charité Berlin. I've got a question for Pedro, which might be a completely bonkers idea, but you had me worried with the escape thoughts around the monoclonals. What if we rotated the different products that are out there between years in the absence of polyclonals? Would that be a way to maybe limit the damage from these escapes that you're anticipating?
That's a good proposition, but I don't know. I truly don't know. I think we're really in for kind of like a roller coaster as we get new vaccines and monoclonals and antivirals as to how it's going to shake up the new epidemiology for RSV. And if I just kind of may make a point, we've talked a lot about infants. I think the epidemiology, the surveillance, also needs to be done for older adults. We may see some differences there.
All right, and then I think we just have time for one more question at the back microphone there.
Thank you, Grant McKenzie, MRC Unit, The Gambia. I've got a question for Brian. regarding estimation of non-medically attended cases and recall bias. Often we've found it really difficult because if you go to someone's compound and ask them, has your child had a cough or difficulty breathing in the last month? It's very tempting for someone to say yes. So I'm wondering whether you've had any attempt to try and validate that, going to compounds where you know that cases have occurred or where you know that no one's been unwell, and validating your questionnaire approach.
Yeah, thank you for that question. Actually, we did a health utilization survey, and we were looking at the previous 2 weeks. So if you had any symptoms in the previous 2 weeks, and this was published last week in BMC Public Health, the health utilization in Kenya and its implication on respiratory disease estimation. So it was within the last 2 weeks.
All right. And I think we need to end it there, so maybe we can have further discussion at the coffee hour, but let's thank all of our speakers again for a great session. Yes, interesting session.
Thank you for co-chairing with me.
Yeah, thank you. That was nice. And I think it went well. We kept on time. Yeah, I think we started a little early, so we had to give us a little extra 10
just well, it's a 4-bedroom home on a golf course. Yeah. So it's oh my God, yeah, no, it's fabulous.
So, do you ever stay at the Pineapple Hotel
No.
in the Seattle? Every time we go for a Gates meeting, they put
So
us up.
because I'm going so much, I decided I have to choose a hotel group now because I get status.
Yeah.
So I've chosen Marriott. So there are lots of Marriotts I tend to stay. Okay, I think we should, or we can give it one more minute, but I think we should just about start. Oh, so that's not us. This is, yeah, no, you're right, 15 minutes, yeah. Okay. So welcome back, everybody. I'm Keith Klugman. I head up the pneumonia programs at the Bill and Melinda Gates Foundation, and I will be co-chairing this session with Shejuti Shaha, who is a clinician and microbiologist at the Child Health Research Foundation in Dhaka in Bangladesh. So obviously we are biased, but this is the session that you have all been waiting for. After more than 50 years of living with RSV and many, many years of frustration related to poor outcomes in attempts to make RSV vaccines, finally, we are on the cusp, as you all know, of an extraordinary number of vaccines available to protect both the elderly and potentially young infants through maternal immunization. So in this session, we will be talking primarily, I believe, about vaccines, but not only. It's of course also monoclonal antibodies. So between those two modalities, we can discuss how they would fit together, how they may compete together, but certainly it's wonderfully exciting that we're in a position that we had to choose from a number of competing presentations to have presentations about future vaccines that are soon to arrive. So with that, I'll introduce the first two speakers, and then Shejuti will introduce the next three. So it's, and I especially wanted to introduce the first presenter because we go back a long way. So it's my pleasure to invite Rhonda Gunn from Ben Gurion University to talk to us about the MELODY trial.
Okay, good morning. I will present this work on behalf of the entire group that you see here. And we're talking about safety and efficacy of nirsevimab for the prevention of medically attended RSV lower respiratory tract infection in all infants enrolled in the phase 3 MELODY. This is my disclosures, and I'll start now. Nirsevimab is an extended half-life human IgG1 monoclonal antibody to the pre-fusion RS-F protein. It was approved in the UAE and Great Britain for the prevention of RS-virus lower respiratory tract disease in neonates and in infants during the first RS-virus season. The phase 3 MELODY trial assessed nirsevimab efficacy in infants that were 35 weeks and older, gestational age and older, over 150 days post-dose. When COVID-19 interrupted enrollment, efficacy against medical attended RS-virus LRTI at that point was assessed on 1,490 infants and was 74.5%, with 95% confidence interval of about 50 to 87. The trial was underpowered to determine efficacy against more severe forms of RS virus LRTI. The objective in the current study was to determine the safety of nirsevimab and its efficacy against 1, medically attended RS virus LRTI, 2, hospitalization for RSV LRTI, and 3, very severe RSV LRTI in the full enrollment cohort, which is now 3,012 children. These were the endpoints that were assessed. The primary endpoint was medically attended RS virus LRTI, which is consistent of PCR-confirmed RS virus, plus signs indicative of low respiratory tract infection, plus at least one clinical sign of disease severity, which is listed here. The secondary endpoint was hospitalization for RS virus LRTI, which is medically attended RS virus LRTI requiring admittance to the hospital. And the exploratory endpoint was very severe RS virus LRTI, hospitalization requiring supplemental O2 or IV fluid. The study was a randomized double-blind study, 2-to-1, nirsevimab versus placebo. The nirsevimab children received either 50 milligrams if they were less than 5 kilos, or 100 milligrams if they were 5 kilos or more. This study was quite balanced between the primary cohort and the one that was enrolled after the pause, and between Northern Hemisphere and Southern Hemisphere. In terms of demographics, again, this was quite balanced. As you can see here, 88% of the children were healthy, term of 37 and above, so almost the great majority were full term, and less than 10% were over 6 months of age. Participants were representative of the global population of infants at risk for RS virus, and they were ethnically diverse population. This is the efficacy of the 3 endpoints. So the medically attended RS virus LRTI, the efficacy was 76.4 for the whole group, with a confidence interval of 62.3 and 84.2. The medically attended RS virus LRTI with hospitalization was 76.8, 49.4 to 89.4, and the medically attended RS virus LRTI very severe was 78.6, 48.8 to 91. So very similar efficacies for all 3 outcomes with relatively narrow confidence intervals. So you remember the 76.4 for the medically attended RS virus LRTI. Now, if you start to break it by different subgroups, you can see that the efficacy was very much around this line of 76.4, so there were not outliers in subgroup analysis. We also wanted to see whether the primary cohort and the post cohort were similar in terms of how the vaccine did. So you can see here that there were of those who were enrolled in the primary cohort, 5% had disease in the placebo and 1.2 in the nirsevimab. In the post cohort, it's 5.7 versus 1.2. So really no difference in terms of the efficacy between those 2 periods. And if you go for subtype A or subtype B, you can see again that there was no difference in terms of the effect of the vaccine, either between subtype A and subtype B, or between each one of the subtypes, between primary cohort and post-cohort. So this was actually quite constant, quite consistent with the periods and with the subtypes of RS virus. In terms of the efficacy for the 150 days, this is a little bit difficult to look at, so we just took the 10%, or the upper 10%, so you just see the same graph, but a little bit bigger. You can see the gap between the vaccine and the placebo, so there is no evidence of waning efficacy against medically attended RS virus LRTI over the 150 days period in the ITT population analysis. We also wanted to look at what happens to all-cause LRTI. As you know, RS virus is an important component of the overall LRTI. So the three endpoints in the upper part you already saw before. Now you can see that all-cause LRTI had an efficacy of 38.2 with a confidence interval of 23.7 to 50, and all-cause LRTI with hospitalization was 38.9, 6.3 to 60. So this is very important because it does tell you that the efficacy against all LRTI is about half to that of RS virus. So it does tell you that RS virus, on one hand, RS virus is the main component there in the all-cause, or main single component in the all-cause LRTI, but also it tells you that you can prevent almost 40% of hospitalization for LRTI potentially with nirsevimab. In terms of number needed to treat, to prevent one all-cause MA LRTI, this is 53 children, and 57 days of hospitalization were averted for every 1,000 infants treated. In terms of safety, there were no safety concerns here. The safety events were balanced between treatment groups. Adverse events related to treatment were reported in 1.3% of nirsevimab and 1.5% in placebo recipients. There were 4 deaths in the nirsevimab versus 0 in the placebo, but they were considered unrelated to the treatment. 1 suspected undiagnosed metabolic disease, 2 acute gastroenteritis, and 1 skull fracture due to automobile accident. So in conclusion, a single dose of nirsevimab administered prior to the RS virus season to healthy late preterm and term infants, 3,012 children, was well tolerated and provided efficacy against medically attended RS virus LRTI 76.4%, hospitalization with medically attended RSV LRTI 76.8%, very severe RS virus LRTI 78.6%, all-cause LRTI 38.2%, hospitalization with all-cause LRTI 38.9%. Nirsevimab provided protection against both RS virus A and B. Results were consistent with the MELODY primary analysis and pooled analysis of data from MELODY and phase 2b studies that were published. Nirsevimab demonstrated the potential to reduce the burden of LRTI caused by RS virus in healthy infants experiencing the first RS virus season. Thank you. I want to just acknowledge the authors, the participants, the families, and all these people that are listed here that took important part of this work.
So thanks, Ron, and this is open for discussion. I'll maybe just ask the first mean question. So fantastic presentation. The one observation that was perhaps not expected is that certainly with the Pfizer vaccine given to maternal immunization, there was a difference between protection against medically attended versus more severe. And you could argue that perhaps you would expect the breakthrough cases to be less severe if they've had the monoclonal, but there was no difference there. What are your thoughts about this?
You know, usually when you give a vaccine, like Rota or many others, you get a gradient. The milder your disease, the lower is your efficacy, or the less higher is your efficacy, and the more severe disease is. But I'm biased. So my answer is not the group's answer, okay? I don't think RS virus often causes infection alone. It's a trigger for bacterial viral infection. And I think that once you get an RS virus infection, it's much more than RS virus alone. And this is why you actually get diseases or effectiveness that is very, very similar. There may be other factors that make you more severe. We heard a little bit about genetics, about other predisposition, even if you're not officially predisposed.
So we've got 3 questions. We'll take Ruth. You get to start first.
So Ron, following on what you just said, the all-cause LRTI is about half of the efficacy of RSV specific. So is that just a fancy way of saying that half of all LRTI was RSV, or are you saying something beyond that in this study?
Well, we only, you know, when you see a result in one direction from A to B, that's what you can say. You can think that it may go also from B to A, but you did not prove it when you only tested A to B. So we tested the effect of the vaccine, and the effect of the vaccine reduced half of the lower respiratory infection. It doesn't mean, and we tested those who came to the physician, those who were hospitalized, and those who were severe. We did not test all those who don't come to physicians, etc. So I'm not sure that it's necessarily the other way. But we did show in this study that if you reduced RS virus by 75%, you reduced ALTR by half.
And that's because half of all LRTI was RSV.
Well, probably more than half, because the vaccine's only 75% protective.
Yeah. At least the ones with the outcomes we tested.
Ron, Peter Openshaw. Yeah. So I remember back in the initial trials of palivizumab, in the cases where there was breakthrough, despite being in the active limb, there was usually a reason, like the dose had been delayed or it been started too late. In the cases of breakthrough here, was there a clear reason, if you looked at the cases that showed breakthrough?
I think we had quite a bit of discussions whether late cases when the antibodies start to fall, whether too early before the antibody can rise. We could not actually see in this anything that we could show or explain by kinetics.
Ron, very, very nice data presentation. Pedro Piedra from Baylor College of Medicine. Along the same lines, were the breakthrough infections more related with the density of the outbreak, or was it more towards the end of the outbreak?
Well, when you look at the placebo, you look that there were more cases in the first few months and less cases later on, which you call appropriately the end of the outbreak or whatever. So obviously there were less cases, but even in that part, there were more cases of in the placebo than in the vaccine. I personally cannot tell you if there were as many in comparison to the placebo, as that's your question. What I'm told by the statisticians that did the study, this is not my study, this is a big group study with a company, that when they look at what they call log-log test, there was no reduced efficacy towards the end.
Okay, thank you.
So thanks. Padmini, last question.
Yeah, thanks, Ron. This is Padmini Srikantai from the Gates Foundation.
I noticed that there was a different efficacy in those under 5 kilos and those over 5 kilos, 63% for the under 5 and 84% in your plot. And there's a dosing difference of 50 milligrams and 100 milligrams for those two. Can you comment on that? And also, did you see more of the breakthrough cases in those infants who had gotten 50 versus 100?
So maybe the company would like to add with this, but we had a lot of discussions on those, looked at the graphs and the kinetics, etc. We could not relate this to the actual levels. So you imply if you get lower dose, you get lower levels, you may get lower protection. That was not related to that. And in fact, the confidence intervals were such that they were overlapping, so you cannot say anything more than that. And those who were less than 5 kilos often were actually a smaller number. So all this together, we could not conclude that we couldn't find any way to explain, except at the moment, to suggest that this is just because of this issue of confidence interval. But I think real life will tell us much more.
Good. Thank you very much. Thanks, Ron. And we'll go on to the second presentation. I'd like to invite Niranjan Kanesa-Tassan, Chief Medical Officer of Icosavax, to tell us about their candidate vaccine.
Thank you. I want to thank the Resvinet organizers for the opportunity to present our talk, our recent data from our phase 1/1b clinical trial evaluating the safety and immunogenicity of our monovalent RSV virus-like particle, VLP particle, termed IVX-121 in healthy adults. Our virus-like particles, or VLPs, are based on a two-component self-assembling computationally designed platform technology. It consists of a component A, which is antigen-specific, which is composed of trimeric viral fusion proteins, shown here for RSV. That is based on the dsCAV1 stabilized pre-fusion F protein. We have other component A's, notably for human metapneumovirus, which is based also on stabilized pre-fusion F, as well as for SARS and flu. These component A's are docked with a common central core, component B, and then spontaneously assembled into the VLP shown here. And in the case of today, I'll be talking about IVX-121, which is our VLP that displays 20 copies of trimeric viral fusion protein on its surface. So the study design of our phase 1/1b trial is shown here. It was composed in two parts, first in human, in young adults, 18 to 45 years of age. We enrolled 90 subjects in total. Subjects were randomized, Subjects were randomized to receive dosage levels of either 25, 75, or 250 micrograms of total VLP with or without alum adjuvant, aluminum hydroxide, 500 micrograms per mil, or to placebo. Following successful completion of part 1, we progressed to part 2, which is the older adult subjects, ages 60 to 75 years of age, and we enrolled 130 subjects here. Those subjects received one dose of the same 6 investigational formulations or placebo. The assessments are shown below. In terms of overall safety, you can see here that there were no vaccine-related serious adverse events, no grade 4 adverse events of significant interest, or adverse events leading to study withdrawal. The unsolicited severe unsolicited adverse events were considered all vaccine unrelated. Looking now at solicited adverse events, these are presenting here the local adverse events within 7 days of the single dosing. You can see in the left panel here the young adult data, mostly mild to moderate responses to vaccination. no severe adverse events noted. And then in the right panel, you'll see similarly for older adults, again, mild to moderate local reactogenicity and comparable to patterns. With regard to solicited systemic adverse events occurring within 7 days, you can see here that the young adults showed mostly mild to moderate systemic adverse events. There was one severe adverse event that was chills occurring on the first day following vaccination, lasted less than 24 hours. The older adults showed, again, mild to moderate systemic adverse events. I neglected to mention their frequencies were lower, as we saw with local reactogenicity, and actually in the case of tolerability were similar to placebo recipients. Moving now to immunogenicity, what I'm showing here is RSV-A neutralizing antibody responses at day 28 following vaccination. And what's portrayed here is geometric mean titers in international units per mil. Those were obtained in a live virus neutralizing antibody assay utilizing the WHO international standard sera. On the left panel here, you can see the young adult subjects from responses from baseline to 1 month following vaccination. What is notable here is responses were evident from the 25 microgram dosage level all the way through to 250 micrograms, 10-fold difference in range, but with similar responses throughout the dose range. Geometric mean fold rises range from 7 to 10-fold from baseline. On the right panel, I'm showing the older adult subjects. Again, from baseline to day 28, the geometric mean titers were comparable to those observed in young adults. And again, you saw a relatively flat dose curve. There was no effect of dosage level. In terms of RSV-B titers, the neutralizing antibody titers were in a similar range with a geometric mean titer up to 6,000 international units per mil in older adults. Now moving to consideration of the presence of adjuvant. So in the middle of each panel here, you'll see the alum adjuvanted formulations that match the unadjuvanted formulations that I showed. And what's apparent here is that the inclusion of alum adjuvant failed to really improve the magnitude of responses. As you can see here, geometric mean fold rises were suppressed in both the young adult and the older adult populations, and in some cases significantly so. Now moving to adding in the day 180 responses. So again, this is returning back to the unadjuvanted formulations. The dark blue, in my view, is day 180. And the main point here from the geometric mean titers is that they did not fall from very much from day 28 in either the young adult or older adult populations. And you can see the fold rises range from 5 to 8 in young adults and 3 to 5-fold from baseline in older adults. When you look at the range of geometric mean titer at day 180, they were maintained at 64 to 90% relative to the day 28 geometric mean titers. Comparing the days 0, 28, and 180 geometric mean titers for RSV-A and B in older adults at the unadjuvanted formulations, you can see here that there was a range, as I mentioned earlier, 64 to 98% for RSV-A. And in terms of RSV-B, the geometric mean titers at day 180 showed greater variability at 40 to 53% relative to day 28 GMTs, but maintained above baseline. We also measured pre-fusion F binding, IgG total IgG responses to the RSV pre-F antigen. Here expressed the geometric mean titer expressed in enzyme units per mil, and it followed a similar pattern to the RSV-A and B neutralizing antibody responses. Shown on the left are the young adult responses, and you can see that there's a rise following vaccination at day 28 that persisted out to day 180 in both the young adults and comparable responses in older adults. And here, the pre-fusion F binding IgG ELISA titers at day 180 remain within 71% or more of the day 28 titers for the unadjuvanted dosing groups. We conducted some exploratory cell-mediated immune assessments in about 20% of all subjects. I'm showing that data here. What's shown here is the gamma interferon secreting T cells expressed as spot-forming cells per million peripheral blood mononuclear cells as determined by LE spot. And what you see is portrayed as a median value with the 25th and 75th percentile values, box and whiskers. And you can see that with young adults, you saw a rise following 1 week following vaccination, so a relatively early time point. We're looking to see if we could induce early responses at this time. There was no dose effect. The responses of gamma interferon secreting cells was diminished in older adults, but seemed to be improved somewhat by alum adjuvant. We also did a similar LE spot for B cells that were RSV pre-F specific. And again, the data is expressed as spot-forming cells per million peripheral blood mononuclear cells. And here, I think the effect was clear in young adults where at day 0, they were relatively low committed B cells, and then there was a clear expansion of IgG secreting RSV pre-F specific cells by 1 week following vaccination. Responses were, again, greater in young adults, but you could see that they were present in older adults as well, and alum adjuvant in this case appeared to have limited effect. So moving to the conclusions, we believe IVX-121 showed favorable safety and immunogenicity in adults even at low dosage levels that were sustained for at least 6 months post-vaccination. We observed mild to moderate reactogenicity and tolerability in adults that's consistent in our mind with protein subunit vaccines. Long-term safety up to 180 days post-vaccination, single dose, reveals no vaccine-related safety signals. And looking at immunogenicity, revealed substantial and durable induction of neutralizing antibodies to both RSV-A and RSV-B. Geometric mean titers were comparable in the two populations we studied of young and older adults with no dosage level effect and no adjuvant effect with inclusion of alum adjuvant. And these RSV-A geometric mean titers at day 180 persisted at 64 to 98% of the day 28 values. In the other data I showed, prefusion F binding IgG was sustained for 6 months similarly post-vaccination across both cohorts, independent of dosage or adjuvant. And there is some preliminary evidence of T and B cell-mediated immune responses induced after vaccination. From here, we're doing two things. We're going to follow this cohort of older adults out to 12 months to see persistence of antibody titer as well as safety. And we have selected the 75 microgram dosage level unadjuvanted of IVX-121 to be combined with the HMPV VLP that I mentioned earlier in our IVX-A12 bivalent RSV HMPV combination vaccine that is currently in phase 1 trials and with data expected in mid-2023. And recently, I'm pleased to announce we received Fast Track designation for this compound. Happy to take questions.
Thanks, Niranjan. So this is open for questions. I have a couple. So from the Gates Foundation, we're very sensitive to price, and it seems to me that you could potentially have a dose-sparing opportunity here. Certainly in the young adults, the 75 looked somewhat even better in neutralizing responses, not so evident in the T-cell responses. So the first question is there an opportunity to even look at lower doses? And related to that, it was fascinating that there seemed actually to be a suppression of antibody responses with the alum. So that was, in fact, I'm going to 3 questions. The third one is there a standardized assay that you could compare your responses to those of your competitors? In other words, using this structure with 20 different epitopes, are you generating higher levels of neutralizing antibody than just the plain prefusion F?
Okay, let me try and break those down. So the first one was in regard to dose sparing. And we don't believe this is a key feature for us. The main reason we look at the dosage levels is we believe it favors combination vaccines. So seeing effect at lower dosage levels is a positive, and tolerability up to the highest dosage level speaks to potential. We selected the 75 microgram dose intentionally because we have so far done our studies in healthy adults, and we imagine that it might take additional dosage of antigen to go into the population with comorbidities or even frail elderly. So that's really where we landed. We didn't really want to push the envelope going down in dose. With regards to the alum adjuvant, we don't actually have the full mechanism, but we believe that the VLPs don't, the expression we use, play well with alum. We believe it might be a physical-chemical interaction because absorption happens rather rapidly, and we believe it may actually have some distortion potentially of the antigen on the surface. So we don't plan to advance alum adjuvant. The third one was the hardest one.
It was a standardized assay, new to assay, and whether you think that your responses are higher than the straight protein.
I don't know that we can say that because there's an absence of standardized assays. The best we can say is we believe we're at best comparable with responses that others may have observed.
One question.
That was a fantastic result. I'm intrigued how many antigens you can put there, right? Because you mentioned combination vaccines and you are trying to make an HMPV RSV vaccine, right? Because that's first question, if when you put more antigens, you still keep the same immunogenicity. And the other thing, it was fascinating when you show us the T-cell response and also the spots for B cells. It looks like the antibody on the elderly were really good, but then the B cell were not so good, the spots, right? I mean, you suggest that as we get older, our B cells will work, but our T cells won't. Can you comment on those mechanisms? Because your data is beautiful to look at that.
Thank you. So the first is interesting. We were pleased to see balanced responses for RSV A and B. Of course, with the IVX-A12 phase 1 interim analysis, we'll be looking for the continuation of that. Plus, of course, now we'll be also measuring neutralizing antibody responses to HMPV-A and HMPV-B. So I think that, stay tuned, that remains to be determined whether combination has any effect. And indeed, one of the things we're evaluating is a potential for interference. We don't believe it will exist, but we'll look at it. The second was regarding the T and B cell responses. So I actually defer a little bit. I think the B cell responses in some ways were encouraging because they tie into the neutralizing antibody responses. But I do agree with you that the responses may indeed be diminished in older adults. We see this as kind of a parallel benefit, and that's understood for CMI, even for RSV in natural history studies, appears to be diminished responses to the RSV peptides or antigens, and we think we may be observing something like that.
If Keith may allow me one, can I advocate, this platform looks very provocative. You know, if you look at the older infants and young children, we don't have any platform going now, except all the live attenuated work that Ruth and where's my friend? But you are doing that, except the live attenuated platform. So do you think this platform would be a good strategy for younger children?
So I can give you a half answer. I'm a pediatric infectious disease physician. Nothing would please me more. I think it's, we will have to develop the clinical database in adults, and then we will see how we proceed. But it's an intriguing comment.
I think it's a potential there. Sorry, I need to advocate for my age groups.
So thank you very much, and it's my pleasure now to hand over to Shay Juti to take over.
It is my pleasure to now call Eleanor Wilson, who's a medical director of clinical development of Moderna. And Eleanor is going to speak about safety and efficacy of an mRNA-based vaccine in adults over 60 years of age.
Thank you so much. Hi, my name is Eleanor Wilson, and it is my honor here to represent the Moderna RSV team. Thank you very much for the opportunity to share our data with you. So I'm going to present on the safety and efficacy of the mRNA 1345, an mRNA-based vaccine against respiratory syncytial virus in adults aged 60 years and older. I'm going to try to figure out this pointer. Okay, here's our disclosure. The Moderna team is employed by Moderna, and those are our conflicts of interest. If you scan this QR code, you'll also find an infographic, plain language summary of the data I'm about to present. So 1345 is an mRNA-based RSV vaccine. It encodes for a stabilized prefusion F glycoprotein, which we've heard a lot about the past couple of days, but elicits a superior neutralizing antibody response in comparison to the post-F form of the F protein. You can see that the F protein antibodies cross-react against both RSV-A and RSV-B, and our phase 1 data showed that 1345 is well tolerated and boosts antibody levels through 6 months, justifying moving forward into a phase 2-3 trial. So let me tell you about our phase 2-3 trial. The study is ongoing. This is actually a typo. It's a randomized, double-blind, placebo-controlled, case-driven study in adults aged 60 years and older. Over 35,000 participants have been randomized from 22 countries and received either one dose of our mRNA vaccine or placebo. Healthy participants were included, as well as participants who had more than one or more stable chronic medical diagnoses. Here you can see our study schema with injection on day 1, and then participants were followed out to 2 years for safety and efficacy. As I said, this is a case-driven study, and so we collected cases of symptomatic lower respiratory disease throughout the 2 years. Primary efficacy endpoint was vaccine efficacy of our vaccine to prevent a first episode of RSV lower respiratory tract disease with either 2 or more or 3 or more symptoms of lower respiratory tract disease between 14 days following the injection out to 12 months for that initial vaccine efficacy assessment. And sorry, I wanted to say here too, you can see that our 22 sites are shown in the map on the right, comprising both northern and southern hemisphere sites. All right, this is our case definition. So we had 2 co-primary endpoint definitions for our lower respiratory tract disease. Participants could be diagnosed with RSV lower respiratory tract disease if they had an RT-PCR confirmed case of RSV plus either radiologic evidence of pneumonia or newer worsening of 2 or more or 3 or more of the following lower respiratory tract symptoms: shortness of breath, cough and or fever counting as one symptom, wheezing, rales, rhonchi, or an abnormal pulmonary exam, sputum production, tachypnea, hypoxemia, or pleuritic chest pain. Our demographics and baseline characteristics are shown here. You can see that the 2 groups are well matched in terms of randomization, but we were able to enrich for populations of interest, those particularly at risk for severe lower respiratory tract disease, including individuals over the age of 70 and over 80, with more than 35% of our participants over the age of 70. You can also see that we were able to enrich for comorbidities of interest, which include underlying baseline comorbidities that predispose participants to a higher risk of severe RSV. So CHF, COPD, other chronic respiratory diseases, diabetes, advanced liver or kidney disease. You can also see that reflecting our enrollment in 22 countries, you can see that we were able to enrich for non-white participants with more than 35% in that demographic. Our safety was one of our primary endpoints, and so here I'm sharing the overview of our solicited adverse reactions. You can see that while, as we would expect, the vaccine was more reactogenic than placebo, overall, solicited adverse events were mild. So while, and in general, mostly grade 1 and transient. So grade 3 or higher grade events were very rare, 3.2% of the vaccine arm compared to 1.7% of the placebo arm. In terms of systemic adverse reactions, similarly, they were low rates of reporting more severe events, with only 4% in the vaccine arm and 2.9% in the placebo arm. And I would like to discuss the individual reactions here. So you can see a graphical depiction of the solicited local adverse reactions, again, mostly driven by injection site pain, shown here grade 1 in the light gray, really predominating those reports. And again, these were relatively transient. Here we can see the solicited systemic adverse reactions. Again, to orient you, grade 1 is shown in light gray, and you can see that while arthralgias, fatigue, headache, and myalgias were reported slightly more frequently in the vaccine than in the placebo, they were low rates overall. All right. In terms of efficacy, so our vaccine, our mRNA vaccine, was able to prevent or demonstrate an efficacy against RSV-associated lower respiratory tract disease with 2 or more symptoms with 83.7% efficacy. When you look at the more narrow definition of RSV lower respiratory tract disease with 3 or more symptoms, our efficacy was consistently above 80 at about 82.4%. This efficacy was maintained across subgroup analyses, including looking at individuals in the higher age groups. So when you see individuals broken out by age 60 to 69 or 70 to 79, for both 2 or more or 3 or more symptoms of lower respiratory tract disease, you can see that the vaccine efficacy is preserved and consistent across all groups. You can only see decades age 60 to 69 or 70 to 79 here because while we were able to enroll over 2,000 participants over the age of 80, we did not observe any cases to date of lower respiratory tract disease in those participants. In terms of looking at efficacy in individuals with and without underlying comorbidities of interest, you can see similarly that our vaccine efficacy was conserved and consistently high across groups with and without those comorbidities. So in conclusion, the Moderna mRNA RSV vaccine was well tolerated and had an acceptable safety profile. Solicited adverse reactions were mostly grade 1 or 2 in severity and were mild. A single dose of our vaccine is efficacious in preventing RSV-associated lower respiratory tract disease with 2 or more or 3 or more symptoms in adults age 60 or greater within the 14 days to 12 months following injection. Our vaccine efficacy was consistently high across all age groups and in participants with pre-existing comorbidities. And our phase 3 trial is, as I said, ongoing, with additional supportive analyses planned through 24 months to assess for durability. This is our forward-looking statement. Thank you so much for your attention.
Thank you, Eleanor. Thank you so much for that very clear and short presentation. When I was looking at the 22 countries, I also saw my country in there, Bangladesh.
Yes.
And that makes me want to ask you the question, did you look at efficacy by country, or did you have the power to look at that? And are there plans of continuing these trials in these countries?
Yes, so absolutely. Bangladesh was included in our study. And you can see we attempted to balance it throughout the world in both northern and southern hemispheres. I think absolutely looking by country or by region is absolutely within our plan. We're continuing to accrue these cases as they go forward, and so I hope to have more data for you in the future. But yes, something to definitely look at.
Thank you. I have one more question, but before that, I'll go to you. There are 2
Thank
questions.
you very much. It's great to see Grant McKenzie from the Gambia. I noticed the event rate was very low. So can you describe the degree of activity or activeness of follow-up of the participants and how active was it, I guess?
In terms of following up and reporting symptoms of lower respiratory disease or, sorry.
Yeah, and how many tests did people get?
Oh, I don't know the exact number of tests off the top of my head, but we tried to do both active and passive surveillance. When participants were contacted for study follow-up, we solicited symptoms of lower respiratory disease to assess for that. Participants also were able to proactively reach out if they developed symptoms of lower respiratory tract disease, and they had an e-diary where they were consistently prompted to report at consistent intervals whether they had developed lower respiratory tract disease. We conducted a multiplex PCR to assess not only for RSV, but other infections, and so we were able to assess for lower respiratory tract disease due to either RSV or other all-cause lower respiratory tract disease. That data is forthcoming.
Sounds relatively active. Yeah.
Thank you.
Next question, please.
I'd like to comment, beautiful data. So it's very nice to see that things are coming around. My question to you has to do with safety. Mm-hmm. And I didn't hear about whether there were any adverse event of special interest in particular in individuals with autoimmune disease, whether you may see any acute exacerbations or not?
It's an excellent question. And as I highlighted, safety is one of our primary endpoints. It was one of our main concerns in really assessing this population, especially a population at risk of more severe disease. We were very proactive in collecting the underlying comorbidities to really assess how things might change over time. We did assess for adverse events of special interest, looking at several different definitions and assessing that those will be in subsequent analyses, but our data has been evaluated by an unblinded DSMB who reported no signals, no safety signals.
Thank you.
Thank you.
Hi, Vivek Shade, Novavax. A nice presentation. 3 really quick questions. I don't think I saw data for A versus B, if you could comment on that. 2 is I'm wondering why you said you enrolled about 2,000 over 80, 2,000 participants over 80. I'm wondering why you think you didn't capture any disease there. And can't remember the third question, so go ahead.
Well, I might need you to remind me about the first 2 as I work my way through. So to your first question about subtypes and RSV-A versus RSV-B, because this is a case-driven analysis, this case number report allowed us to conduct our interim analysis and assess for vaccine efficacy, but cases are ongoing, and so we will continue to accrue that data, and once we're able to make to really make a conclusion about efficacy, then we'll report that data, and hopefully that will be forthcoming. As I said, subsequent analyses are planned, so we don't have that information yet, but we're working on it. And then your second question was about, participants over 80 and that we didn't observe cases in that. I think it's sort of the same answer, is that cases are ongoing, we are continuing to accrue them, and we will continue to look at that population. I don't know why we didn't see them, but, you know.
Okay, third question I remember. So degrees of severity, between your greater than 2 and greater than 3, the others who have reported data in the same population have seen gradients of disease. Do you think it's because of your case definition or something else? Why didn't you see sort of gradation there?
Why they were why the vaccine efficacy was consistent between the 2 definitions.
Yeah, there was some quite stark, discernible gradation in the others who reported data.
Yeah. I don't know why our data is different from others. I think I can speak to our data and say that when we were assessing this case definition, we were looking at these symptoms of lower respiratory disease and compiled this case definition to really be able to capture the full spectrum of disease. And so RSV, lower respiratory tract disease with 3 or more of these lower respiratory symptoms really should be a subset of the 2 or more symptoms definition, which is sort of a broader, more encompassing definition. And looking at this, just seeing that our vaccine had sort of consistent efficacy between these 2 definitions gives us reassurance that we're really preventing disease. But as we look at these symptoms and as we expect more data, hopefully we'll be able to make more conclusions about the different disease prevalence.
We have time for 2 more questions. So, Peter?
Steve?
I'm sorry, can you repeat that? Yes, thank you. I think it's on.
Is that better now? Yes. Were you able to relate protection to immunogenicity? And over the period of your 1-year follow-up, did you see much decline in the immune response?
So while we've reported immunogenicity from our phase 1 data, we're still collecting this information and looking forward to analyzing it and reporting on this population. So I don't have that for you yet, but I will.
Thank you.
Thank you.
Thanks. We'll go to our last question.
Okay. Hi, Buki Dokul. I'm from Sanofi. My question is a bit of a follow-up to the question that Grant asked earlier regarding case ascertainment. And the question is, did you have participants tested more than once in an illness episode? And at what point during the illness? And if you think that impacted, the cases?
Every effort was made to bring participants in as soon as possible after they reported symptoms. So the vast majority of swabs were collected within 5 days of the initial symptom report. And I'm sorry, I think there was a follow-up that I've forgotten. Am I fully answering your question?
Was it more than once?
Oh, more than once?
One test or more than once in an illness episode?
If participants had persistent symptoms after their initial test that lasted for, I believe, I would I don't want to speculate, but lasted after the initial, or if they had worsening of symptoms, they could return for a second swab, and we would retest them to be sure that we were capturing disease.
Sorry,
How
one
about
more.
you guys have coffee together?
Just one more quick question. Did you see efficacy against ARI?
I'm
or
sorry, say that
RSV
again?
ARI?
I'm sorry, say that one more time.
What was the efficacy against RSV ARI?
Again, cases are still accruing and being cleaned. I don't have that data yet to present, but look for it. We're working on it.
So coffee next meeting.
Yes, absolutely. Thank you very much. I appreciate it.
Now it's my pleasure to invite Martin Moore, who is going to talk about a live attenuated RSV vaccine in RSV-naive children.
Great. It's wonderful to be here, to be traveling again, and I'd like to thank the organizers for this opportunity to present our data. So, can't see with or without my glasses, but... Okay, great. So, one of the consequences of the observation of RSV vaccine-enhanced disease was that live attenuated vaccines became the predominant type tested in naive children because live attenuated vaccines have not been associated with enhancement. However, live attenuated vaccines have not kept up with the pace of development of maternal and elderly vaccines, predominantly because of the challenge of finding the right strain, balancing safety and potency. And that's really the problem that we're trying to solve at Mesa Vaccines. Why are we doing this? We and others think that onboarding active immunization is an important strategy for preventing RSV and disease in children, because passive antibody will wane, whether it's obtained naturally by maternal vaccination or by administration of prophylactic mAbs. Ruth Karen's group published this paper a couple years ago, and we really used this as a guidepost for our development. And so what they did was they combined data from 7 phase 1 studies of different RSV candidates and asked the question, following these children through the subsequent RSV season, were they protected? And if so, what correlated with that protection? And yes, administration of live attenuated RSV provided efficacy against RSV Mari and more severe RSV Malari. And that protection correlated with a 4-fold rise in serum neutralizing antibody. And their group uses a complement-enhanced neutralizing antibody assay, which we've subsequently adapted. And interestingly, they were not able to identify, or they did not identify, a specific titer that correlated with protection. And we think this makes sense for live attenuated because live attenuated vaccines generally stimulate broad immune responses, right? These are intranasal, so you're talking humoral, cellular, mucosal immunity, and using the 4-fold rise or seroconversion is likely capturing, this broad immune response as a protective response. And, maybe later larger studies will identify a titer or a more mechanistic correlate, but we find the 4-fold rise as, an intriguing working correlate of protection. So, balancing safety and potency. So what I've done here is I've listed a number of previous live attenuated vaccine strains in the reference for the phase 1 data. And I've color-coded the safety, blue, well-tolerated, yellow, possibly safe, like Medi-559, and then red is residual RSV pathogenicity. And on the right, each dot, laser pointer, probably this one? Yes. Here on the right, each dot is one of these strains in phase 1 results, okay? So you have the red strains, which had residual pathogenicity. They had a high percentage of 4-fold rise in serum antibody, and also a high percentage of subjects that were shedding vaccine virus. And you can see there's a pretty good correlation between seroresponse and vaccine shedding, where the more attenuated strains, like these blue strains, they were well tolerated, they had low shedding, but they were not immunogenic, right? The red strains were, in essence, too hot because of safety, and then the yellow strains had some aspect of, some safety signal that provided, caution about going to a larger study. For Medi-559, it was, a slight imbalance in LRI in the vaccine group. So this is the challenge, right? How do you find the strain that gives you comfort to go to a larger study? This is just a cartoon of the RSV genome here. And what I've done is I've color-coded the genes that are generally involved in replication in this kind of orange or peach color, okay? And traditionally, live attenuated vaccines, you're thinking, yellow fever, MMR, previous RSV strains, they're attenuated on viral growth or replication, and they have mutations in these replication genes. Now, RSV, like other viruses, also encodes genes called virulence genes, and these genes are not required for replication in cell culture, but they are required for optimal replication in the host. And virulence genes typically are involved in immune evasion or immune blockade. So what we hypothesize is that rather than go after the replication machinery, what if we attenuate on the virulence genes? Then if the RSV strain is not blocking these immune mechanisms, we may be able to achieve potency. And if we take away virulence, we may be able to achieve safety. So let's go about this in a different way. These are the details of the changes that we made to the RSV genome. These are now published. I'm not going to go through all of them. We've introduced hundreds of specific mutations across these individual RSV genes, essentially decreasing or eliminating the expression of the non-essential virulence genes and increasing the expression of the pre-F. So when I was back at Emory, we studied this in the cotton rat model, and what we found is that the vaccine strain shown in green was heavily attenuated, which was a good result. So we, in the nose or the lung of the cotton rat by plaque assay, we didn't detect any plaques of the vaccine strain at any time. And in a more sensitive primary human airway epithelial ALI culture system, you can see the vaccine strain in green just kind of smolders along here, never rising to the level of the input, and is gone by day 8. So this is a heavily attenuated strain of RSV. But despite that heavy attenuation in these preclinical models, we saw that the strain stimulated, whether it was IgA in the nose of the cotton rat or serum neutralizing antibody or interferon gamma in the mouse model, level markers of immunogenicity that were equivalent to the unattenuated parental strain called A2. So we had preclinically heavy attenuation, but retention of wild-type-like immunogenicity, and that gave us the courage to start the company and take this into the clinic. So here we are. We've done a phase 1 in 20 seropositive adults, 34 seropositive toddlers, and as you would expect for a nasal live attenuated, we didn't see immunogenicity in these seropositive populations. These are really small safety gating studies to get to the target population, which is sero-naive children, in this case 6 to 36 months of age. So this is what we've been doing, dose escalating 10 to the 3 up to 2 doses of 10 to the 6, which is what I'm going to show you, and we're currently dosing at 2 doses of 10 to the 7. I've never been so excited about a phase 1 safety table. This is the most exciting thing in my life, but I'm a very boring person. So what you can see is that solicited AEs after inoculation of the vaccine are like the placebo. There are no 2s and 3s. It's all mild, and that includes rhinorrhea, fever, and cough. So if you compare this to other previous live attenuated RSV candidates, this is exceedingly mild. And the shedding pretty much tracks with that. We didn't see much vaccine shedding from the nose. We measured by plaque assay and by qPCR. So in children given either 1 dose of 10 to the 6 on the left, or 2 doses of 10 to the 6, and looking at shedding after the first or the second dose, we only detected a few plaques in 1 subject, and we detected shedding by PCR in 3 subjects. We sequenced these and showed that there were no reversions in the many attenuating mutations that we introduced. So very little shedding. Now here's the serum neutralizing antibody result. Let me walk you through this. So these are the 12 naive children that were given 2 doses of 10 to the 6, and this is the baseline, day 29, and day 57. The green dots are 4-fold rises. The orange lines in subjects, when we went to the complement assay, when we went back and tested these, they were above the 1 to 40 cutoff, which we use to define seronegative. So in retrospect, they were seropositive when we enrolled them. So that was unfortunate. But if you only look at the subjects that were seronegative at baseline, of which there are 9 of them in the graph on the right, you can more clearly see the seroresponses. And that's 7 out of 9 having a 4-fold rise at day 57. And the mean titer is 798, and converting that to international units is about 828. But we focus more on the percent of 4-fold rise based on that Karen paper. So where does that put us? Well, if we plot these results on the graph that compares shedding and immunogenicity of previous live attenuateds, we're kind of off the balance beam, which I think is where we want to be. Our shedding is like CP52, which is one of the most attenuated strains I think studied. The safety was well tolerated like the blue strains, and the immunogenicity is somewhere between the yellow strains and the hot strains. We would like the 4-fold rise to be more in the 80 to 90% range, and that's why we're now pushing the dose to 10 to the 7, because here's an interesting thing. Those virulence genes, remember I said they're not required for replication in vitro, so that means our vaccine strain grows like wild-type RSV in the manufacturing cell line, so we can more easily push the dose. So that's what we're doing, and we're also preparing to do a study in younger infants aged 3 to 5 without screening, because we need to understand how the vaccine will perform in the face of maternal antibody before we go to phase 2. So with that information, dose, and exact age, we're ramping into this phase 2. And we're using this RSV backbone where we've fine-tuned the virulence of RSV really as a platform to express spike or HMPV-F, and we have a nasal COVID vaccine in phase 1 and working on HMPV as well. This is our team, and it's really a tight-knit group. Being in small biotech has been quite an adventure, and I'd really like to give a special thanks to Mike Watson, who was on our board and who was a great mentor to me. And I'll take questions. Thank you.
Thank you so much for that very good presentation. I already see a few questions, so we'll start with these two on my right.
Peter.
Is Peter open?
Yeah.
So, what about nasal responses? I mean, one of the big advantages might be that you had to have nasal IgA, so you're taking samples, you've measured those. I mean,
Yes.
Systemic responses wouldn't necessarily be expected, would they?
Yes, I have a slide I'll show you later, but in those children, we measured pre-F IgA only on day 29, and we saw about a 40% response rate. So we do see induction of nasal IgA. In the other studies in seropositive adults and toddlers, we were able to sample more intensively, and we had a higher response rate of IgA. I think because we were sampling earlier. Day 29 may be a little late, but yes, we are stimulating nasal IgA. Thank you.
Mari, thank you so much for this update on your vaccine. It's nice to see the progress. Now, I was trying to connect, since you touched NS1 to diminish the virulence and the growth on the epithelial cell was so limited, right? The data that you show us of the nasal shedding was viral, was culture, right?
Culture and PCR.
And PCR. So that's what I was trying, maybe I did not pay attention. So were you able to connect the level of shedding with the antibody response? What I was trying to see, because you didn't see any shedding, right, except in 2 guys. Do you think it's an issue of sensitivity? Because how do you think you are inducing the immunity unless there is a low level of replication?
That's a great question. So we think that the vaccine is replicating in the host because we do see very low levels of replication in those primary cells. We use the fluorescent tagged virus, and you can see it spreading, but the yield is very low. So the way I think it works is we've rendered this virus to be highly susceptible to type 1 interferon. It goes in, right? It gets shut down. And I think that's why it's really a 2-dose vaccine. Usually you think of a live as
one cycle.
one.
One cycle of.
But for us, it's not really the area under the curve of replication. It's the going in, setting up the immune response, and then coming in with a second dose. So in that sense, it's different.
No, I still think that it will be nice, as Peter suggested, to, as these new vaccines, like Ruth is looking at me, I think it will be really nice for the field to have a mucosal correlate, because I think it will allow the development faster. But so maybe you and Ruth can work on that.
I agree.
I'm going to go to Harish first. He came first.
So two short questions. One was the age group you're targeting, obviously, and you've got a product for HMPV. So the HMPV burden is again, higher in this older than 6-month-old children. Are you thinking in terms of having, in the end, a combo product, which will include both HMPV and RSV and possibly flu, because you got a live vaccine for flu as well. So, to try and sort of limit the number of doses that need to be given to children. And the second was, what happens in countries where you've got children with constantly snotty noses, so we've seen from polio, for example, there is from the non-polio enteroviruses, if they've got diarrhea, then the uptake of the oral polio vaccine is not as great as what you would see otherwise.
Right. So I'll take the second question. I mean, nasal administration is not without challenges, right? So if kids have sniffly noses at the time of administration, that may or may not impact us. We don't know. I think there's some experience with that with flu mist, so I would defer to the flu mist colleagues in the audience for that. And sorry, what was the first question? It was,
the combo vaccine.
Oh yeah, absolutely. That's been our vision, from the beginning, sort of, respiratory MMR. So, absolutely.
We are running out of time, but we will take these two questions. Super quick question, super quick answer. I'll start with you.
Actually, Ruth was here first.
Was Ruth here?
Oh, okay, all right. So thanks, Marty. It was a great presentation. A couple of questions. One is, do you know anything about durability of the immune response and/or response to natural infection, priming, anamnestic responses? And the second is, I missed it at the very end when you were talking about manufacture and how high you can go. I mean, there may be safety issues as well, but how much of this do you think you can give 10 to the 7th, you can manufacture that reliably? Can you make more than that? Do you think there are safety limits to that? So those two.
Sure. So the first question, I think, you have the best data on durability, and some of it is in that paper that I talked about at the beginning. And I hope that we don't have clinical durability. We certainly have it in small animals, and it's good, but clinically we don't know yet. And the second question is about CMC. Absolutely, we're currently using an intensified bioreactor system called Univercells, but it's adaptable to like the iCellus or microfiber, the microparticles, or even roller bottles. Any of those, we could manufacture enough vaccine at 10 to the 7 for the birth cohorts around the world. So we have Keith Wells as our, sorry, you said a short answer, so I'm just going to stop. Yes, we can do that.
So real quickly,
yes.
The epithelial cells is the first cell that will come in contact with the virus and initiate or orchestrate your immune response. So have you look at surrogates like cytokines to see how they're activated in your, let's say, human epithelial cells?
We've initiated these studies, but we don't have the data yet. We're particularly interested in whether in these type of systems we see an enhanced type 1 interferon response, for example. We did publish that our vaccine strain does not degrade STAT2, which is one of the NS mechanisms.
Thank you. Thank you so much.
Thank you.
It is now my pleasure to call Anusha Sinha to stage. Keith just introduced me to her and said, she used to be a superstar health economist. Then she moved on to the other side, which is also part of this healthy ecosystem. Thank you for your talk.
That was a really lovely introduction. Thank you. So my name's Anusha Sinha. I'm the lead of the clinical sciences team at MSD that's supporting the development of clisrovimab, our RSV neutralizing monoclonal antibody. And it's my pleasure to present our phase 1b/2a study on behalf of the study authors that you see listed here, some of whom are also in the audience. These are my disclosures. So it's been the theme of this meeting and doesn't really require much further elucidation, the significance and characteristics of RSV. It's a huge source of unmet medical need in our infants and our young children. And needless to say, a potent RSV neutralizing monoclonal antibody with an extended half-life, enabling a single preventative dose at the start of the RSV season, could potentially address this large unmet child health need. With that in mind, I'd like to highlight a few of the important characteristics of clisrovimab. I think the figure to the left is now familiar to everyone in the room. It's the crystal structure of the pre-fusion conformation of the RSV F protein, and it illustrates clisrovimab bound to site 4 on the F protein. What you see here in the blue tones is clisrovimab bound to 2 of its 3 sites on the trimeric F protein. As we've reviewed earlier this morning, site 4 is a highly conserved epitope, which is to say it has a very low rate of mutations detected within the binding site sequences. Clisrovimab has high potency against a wide range of RSV clinical isolates, and it's equipotent against both RSV A and B. It has 3 engineered mutations in the constant region, FC region, that result in increased recycling of the antibody and thus an extended half-life in the blood. So with that background, let's move on to the phase 1b/2a study design that we'll be discussing today. So what you see in the figure to the right here is a figure giving you the study design. It's a double-blind, placebo-controlled study with a dose escalation panel design. Once the highest dose of 100 milligrams is administered to preterm infants, the same dose is given to full-term infants in the last panel of the study, that is to say, panel E. Whoops, going the wrong way here, guys. Yeah, so important evaluations within the study include clisrovimab's PK, serum neutralizing activity, anti-drug antibodies, safety through at least 1 year of follow-up, and active RSV surveillance with collection of respiratory symptoms, healthcare visits, and nasal swabs for PCR testing of a panel of respiratory pathogen. So that's the design in summary. And today I'll be discussing the phase 1b/2a study results. Of note, clisrovimab is currently in phase 3 of its development. Today, we'll be reviewing the results of a planned interim analysis conducted last year in 2022 for results through day 150 for all participants. You see in the bottom part of this figure, or this bullet list, the objectives of the interim analysis. And that interim analysis focused on characterization of the PK of clisrovimab in both preterms and full terms, summarization of its SNA activity, prediction of efficacy of clisrovimab from day 1 to 150 using a published model, and finally, summarization of an exploratory efficacy analysis against RSV medically attended lower respiratory infection. So next, let's turn to the results. Here's a summary of the PK data for the different dose groups, 20 milligrams ranging up to 100 milligrams. In total, serum concentrations were collected from 111 preterm babies and 32 full-term babies. The figure on the left shows mean concentration versus time profiles for each dosing group through day 150. And you can see an approximately dose proportional increase in mean concentrations of clisrovimab. You can also see a gradual decay in PK over time for all dose groups. That's consistent with its extended half-life, and you see that both in the preterms, that's panels A through D, and full term, that's panel E, infants. Let's look at the PK data in a little more detail. So that's what you see in this table here. If you could first focus on the median team max, or time to peak concentration, you'll see that falls between 5 and 6 days. Next, if we focus on the column labeled C150, that's the geometric mean concentration at day 150. And that time point is of particular interest because day 150 gives you roughly the duration of an RSV season of approximately 5 months. Finally, let's focus on half-life. Clesrovimab demonstrated an extended half-life of approximately 42 days across all dose levels, as you can see in the final column of the table. Finally, let's focus on the results of the bottom row. And here you can see that this extended half-life was observed in full-term infants, that's panel E, in addition to the preterm infants in panels A through D. Turning to the serum neutralizing antibody activity, what you see in the figure to the left is SNA activity both prior to dosing and then at day 150 after dosing. The figure shows that the serum neutralizing antibody titers on the log2 scale for each dosing group at baseline and day 150 time points. Of note, you'll see on the gray plot the placebo group for 38 participants, and that's the placebo group summed across all 5 panels. It's important to note that the baseline samples were drawn prior to administration of clesrovimab, so any neutralization activity there is coming directly from the host, directly from the participant. Consistent with the neutralizing mechanism of clesrovimab, serum neutralizing antibody titers increased in a dose-dependent manner through day 150, and you'll see a 16 to 23-fold increase in SNA titers at day 150 compared to baseline. And this would be following the highest dose of 100 milligrams in panels D and E, respectively. Finally, my favorite slide. Incorporating the PK and SNA data that I just showed you, we employed a published qualified model that quantitatively relates SNA titers to risk of RSV lower respiratory infection. And that was done using data from the published literature in a model-based meta-analysis. This relationship was used as a means to predict the efficacy at different clesrovimab doses in simulated clinical trials. We simulated a clinical trial using a virtual population of infants to ensure that a single dose of clesrovimab can provide protection across all infant patient populations. The figure on the left shows that predicted efficacy for the prevention of RSV medically attended lower respiratory infection for a period of 5 months on the x-axis, and then the clesrovimab dose modeled on the y-axis. The red dot at the center of the violin represents the mean value from 1,000 simulations, and each vertical bar on either side of the red dot represents the 25th and 75th percentile. The curve that you see represents the distribution of results across the simulations. And what you can see from this violin plot is that efficacy is predicted to increase across the dose range we evaluated in this study, and then plateau at higher dose levels. Based on the findings that you see here, a single dose of 100 milligrams or greater would be predicted to provide at least 76% efficacy for the prevention of RSV medically attended lower respiratory infection. So please keep that in mind as we turn to the final results slide. And what you see here is a summary of an exploratory efficacy analysis from this phase 1b/2a study. Here are the results for incidence of RSV Mallory cases summarized in the table that you see here, and observed over the 150-day active surveillance period for the clesrovimab and placebo recipients placed side by side. Keep in mind the 4-to-1 ratio of clesrovimab to placebo. And you can see in this exploratory analysis that the observed efficacy to prevent RSV medically attended lower respiratory infection, MALRI, for all doses of clesrovimab, 20 to 100 milligrams, was 74.2%. When you limit that analysis to the 100 milligram dose, given to preterm infants in panel D and full-term infants in panel E, you see that the observed efficacy is 80.6%. Now, the overall sample size of this phase 1b/2a study was small, and the number of RSV MALRI cases was low, so the 95% confidence intervals are wide, as you would anticipate. Nonetheless, these results are consistent with the model-based predictions that I just shared one slide previous and are motivating for the phase 3 program, which is currently underway. So this is the last slide before lunch. To summarize, I've introduced you to the characteristics of clisrovimab, MSD's RSV neutralizing monoclonal antibody currently under phase 3 development. It binds to site 4 and has an extended half-life. We've showed you dose-dependent increases in serum neutralizing antibody titers through day 150. We saw a very nice and, to me, very interesting alignment of our modeling predictions for efficacy and the observed efficacy results seen in an exploratory analysis in this study. Finally, I want to highlight that that exploratory efficacy analysis has the limitations that you see in the final bullet point on this slide and that I've mentioned previously as well. With all of that said, I'd like to end this presentation and I guess this session before questions with a big thank you to our study participants and their families. It's no small matter to have a small baby under a year of age and bring them consistently to our study sites for all of the procedures that are required. So really, they're the heart and soul of this study. That's complemented by the hard work of our site investigators, some of whom are in the room with us, and of course, their study site staff. Thank you very much for your attention.
Thank you so much for that presentation. And I think I saw the maximum number of phones go up to take pictures. I already see questions, so I'll start with you.
Great presentation, thank you. You gave preterm infants placebo rather than palivizumab. Was this off-season enrollment, or how did you justify that? And what are you doing for the phase 3 trial?
That's a great point. So this was a panel enrollment. So active surveillance did take into account the seasonality that we were observing after enrollment, but enrollment occurred in a sequential panel nature and therefore could not be timed to the start of the RSV season. Also, this was our first infant study following an extensive adult phase 1 program, and that enabled us to give these healthy, non-palivizumab eligible infants placebo as well. Oh, and the phase 3 program. Yeah, so the phase 3 program consists of 2 much larger studies. One is a phase 2b/3 trial in healthy, non-palivizumab eligible infants, and the second is a palivizumab control trial in palivizumab eligible infants.
Grant McKenzie, the Gambia. I was wanting to ask, is it administered intramuscularly or subcutaneously? Because I'm thinking of malnourished children and their issues with muscle mass, but it also relates to very premature children who have very little muscle mass, very little subcutaneous tissue, and then also thinking about wider administration. Some healthcare workers are not that confident with subcutaneous compared to intramuscular administration.
Yeah, it's an excellent point. So Grant, correct me if I'm wrong, I think sub-Q route of administration is primarily used for our live attenuated viral vaccines. And so for this monoclonal antibody program, the phase 1 program focused on IM administration, and that's what's used in this 1b/2a study as well. It bears consideration the volume that needs to be administered in an IM route for malnourished infants as well as infants who might be quite premature. What I will say is that as a medical monitor for the phase 3 program, of course, we do have infants who are appropriate for enrollment in a clinical trial. So the extreme that you're talking about won't be in our studies. But we do have a lot of very preterm babies, and those babies, we have not in medical monitoring really seen issues with administration. That's just an observation from medical monitoring, not a result.
So, thanks to all speakers, and my question is nearly for all speakers about viral load. My point is you have 20 to 25 failures with any of the products. I wonder if it was possible to evaluate viral load in those receiving either monoclonal antibody or vaccines compared with placebo. And second, could it be estimated the duration of the disease?
I can start. So our assay for our efficacy endpoint is a PCR assay, and it's not a quantitative PCR assay. So we wouldn't have a measure of viral load included in the data that I've presented. In terms of duration of shedding, that also is not incorporated in our efficacy endpoints. Yeah, that's what I can say.
Thank you. I think for answer from the other speakers, you have to have lunch with them today. There's no other option.
Thank you.
I'll go to the last question.
Yeah, thank you for a great presentation. Erin Sparrow from WHO. I had a question about the PK data that you're looking at. And are you looking out beyond 150 days? And if you have looked at that PK data out beyond 150 days, have you applied your model to predict what the efficacy might be beyond 5 months? And the reason I ask this is because in some regions, the onset of the RSV season is variable. And so having a little bit more protection or knowing what that potential efficacy might be beyond 5 months could be beneficial.
It's an excellent point. We have not looked at PK data beyond 150 days. Our modeled half-life that you see here would enable us to use the model to make predictions beyond that 150-day point, but we haven't conducted those analyses. But your point's very well taken.
Thank you.
Thank you all for attending the most exciting session of this conference. Tomorrow is not going to be as exciting, other than my talk, of course. This was a brilliant session. As Keith already mentioned, there were many abstracts to choose from. We heard 5 different talks, 5 different products from 5 different companies. They were tested on 5 different age groups, and they're all in different stages. This is my first RSV meeting, but I cannot wait for the next meeting and hear where these products are. Thank you all again.
It was, yeah. I'm not sure, they asked us to choose. I did not choose this crowd, but they obviously made their own decisions. But that was good.
Can get the other one, but in general I would not need. I'll do like this usually. Okay.
It's here. So make sure when you click on the pointer, it to wait because there's a bit of a lag. So you click it and it appears. See it? So there's a bit of a lag. Oops. Now it's fine.
There you go. Easy enough.
Perfect.
And this way, since I have this, they can leave the mics way up here.
It's from Professor Pappy.
Great, there's all these tall people, and I'll be like,
You can step a little bit then on the left so we can see you.
So Ilsa says she's going to be, she may be a little bit over time. So. Other people can relax and we just have to chair the whole day, morning till afternoon.
Yeah, they should be like some gifts or compensation, right?
You've got a hot mic there.
Yeah, like I want a bottle of port. And they'll be like, but there's Gates Foundation sitting right beside you.
Are you Victoria? Oh, fantastic. Super. Nice to meet you too.
So nice to meet you.
Okay, great. I'm going to introduce you. Yeah, okay. Fantastic.
Good afternoon, everyone. Okay, so our chairing of the last session went so well, that apparently we won People's Choice Award. So we were invited back to continue chairing. I'm really hoping there will be some award after this, or some reward, like a bottle of port or something. I really hope. You'll work on it? Thank you, Leila. Yeah, I appreciate it. I will wait. So we are actually going to continue our session from before lunch, and we have 3 speakers this time. I will be introducing the first speaker, and my co-chair, Keith, will be introducing the next 2 speakers. So we are going to start with Ilsa, who has a beautiful last name that she's going to tell you all about, and she's from GSK.
Thank you. So my name is Ilse Djösar. So I would like to thank the organizers for giving me the opportunity to talk to you today and to present to you a safety signal that we have encountered during one of our phase 3 trials. I am a GSK employee and I hold shares within the company. So this slide gives you an overview of the events that brought us up to this point. So Resvinet 009 is a phase 3 vaccine efficacy trial that was initiated in November 2020. In February, mid-February, we were alerted by the IDMC that they have observed an imbalance in the proportion of preterm births in the RSV maternal group versus the placebo group, and they recommended us to hold the trial. So GSK immediately and voluntarily paused the enrollment and vaccination in the 009 trial, but also in 2 other trials that were ongoing at the time in pregnant women. At that time, in the 009 trial, we had about over 5,300 pregnant women enrolled, and about 3,400 infants were born. So still 1/3 of the mothers needed to deliver their babies. Upon careful review of the data, we also noted that there was an imbalance in the proportion of neonatal deaths in the RSV maternal group versus the placebo group. Now, as an explanation of the safety signals that we observed was not evident, we decided to stop the enrollment and vaccination on February 25th, 2022, and subsequently stop also the enrollment and vaccination in all trials in the RSV maternal program. We immediately started an investigation and trying to find out and better understand the safety of the data. And that investigation, the trial is still ongoing, that investigation is still ongoing. So today I'm sharing with you our findings to date. So 2 things before we move a little bit more into the details is that GSK did complete all the necessary steps prior to initiating that phase 3 trial. And that includes toxicology studies, preclinical studies, phase 1 and phase 2 studies, including a phase 2 study in pregnant women. And none of these earlier activities made us believe that there was a risk in pregnant women. And second, this was the only trial where we have observed an imbalance in preterm birth and neonatal deaths. So we have been having other trials in pregnant women, and we did not observe the same safety signal. And I don't know why that went out. Okay. All right, so RSV 009 study, what is it about? It's a vaccine efficacy phase 3 study. It's a double-blinded randomized control study. So the placebo that we used was saline. So pregnant women 18 to 49 years old were enrolled across 24 countries, and that both in the northern and the southern hemisphere. Half of the study population was enrolled in low middle income countries. So pregnant women were between 24 and 34 weeks of gestational age at the time of enrollment, and were enrolled according to a 2-to-1 randomization scheme. And that's important to remember when we start looking at some numbers later on in the presentation. So according to the 2-to-1 randomization scheme, they received either 1 dose of unadjuvanted RSV pre-F3 vaccine or placebo. Then women were followed up till 6 months post-delivery, and their infants till 1 year post-birth. The baseline characteristics were well balanced between two groups. The data I will show you is the data on the time point day 43. This is the time point where all infants have passed the 6 weeks post-delivery time point, and when all preterm birth cases were reported at that time and cleaned. They were also reviewed by an external adjudication committee, and we had 100% alignment. So let's take a look at the safety signal. So preterm births. So when we were first alerted by the IDMC in February 2022, there was a higher risk of preterm birth in the RSV maternal group compared to the placebo group. And the relative risk was 1.51 and was statistically significant. As I said, still 1/3 at that time of the mothers needed to deliver their babies. So since then, the identification of the safety signal, we have been on continuous basis collecting the data and analyzing the data. So we made monthly reports to really closely monitor how that safety signal would evolve, and also to keep our investigators and the regulators informed. On October 4th, 2022, so this is the day 43 time point I just alluded to, there is still a higher risk of preterm birth in the RSV maternal group compared to the placebo group, with a relative risk of 1.38. Now, I do want to point out here that we have the imbalance between the groups, but the overall preterm birth rates were relatively low in the trial and remain below background rates for most of the participating countries. So we also noted an imbalance in neonatal deaths. So there were 13 cases of neonatal death reported in the RSV maternal group versus 3 cases in the placebo group. Now, when you look at the second line here, there was no imbalance in neonatal deaths in babies that were born full term. So you have 6 cases in the RSV maternal group versus 3 cases in the placebo group. But remember the 2-to-1 randomization. So the relative risk is around 1. So that means that the imbalance in neonatal deaths that we have observed is actually driven by the neonatal deaths in babies that are born prematurely. We have 5 cases in babies of neonatal deaths in babies born between 28 and 37 weeks of gestational age. And 2 babies were born extreme preterm, so between 22 and 28 weeks of gestational age, where there were none in the placebo group. Now, upon careful evaluation of all the clinical information that we have on each neonatal death case, we concluded that the events leading to the death of the infants are those that are most commonly observed in premature babies and complications of being born prematurely, and that often are associated with poor outcomes and even fatal outcomes. So therefore, the neonatal death imbalance is considered to be a consequence of the preterm imbalance that we have seen in the trial, and is not considered to be an independent safety signal. So now I'm going to focus on the safety signal on preterm birth. So The database of on October 4th had a relative risk of 1.38. So then we analyzed according to the economic region. And interesting what you can see, if you look at the high economic countries, the relative risk is around 1. So there is no imbalance in the high income countries. However, so the imbalance is mainly driven by the imbalance you see in the low middle income countries with a relative risk of 1.57. So with a lower limit, which was above 1. Now, 2 points here is that the study was designed to ensure that all study sites across the 24 countries and the study participants had the same study procedures, the same equipment. Second, the categorization by economic region is not easy, and so it might not fully accurately reflect the full country status, such as, for instance, in the US, there might be sites that are located in locations in regions that are more closer to middle-income countries and high-income countries. Nevertheless, it's an interesting observation that actually the imbalance in preterm birth was greater in low middle-income countries than high-income countries. So we digged a little bit further into that, observation. What you can see on the top graph, we plotted the monthly preterm birth rates over the total births. So the bars you see on the graph are the total deliveries per month. The solid lines are the preterm birth rates. So the blue color represents the data from the RSV maternal group, the pink from the placebo. And what you can see is that the imbalance in preterm birth rates was consistently present between April and December 2021. After that, the difference was not so evident. And remember that we only stopped the trial in February 2022. By then, the difference was not so evident to see. Now, if you do again a split by economic region, you see, and so you have the low middle income countries and the high income countries, that the magnitude and the temporal clustering of the imbalance in preterm births between the groups was greater in the low middle income countries than in the high income countries, right? And that during that same period. And actually it peaks in the low middle income countries between August and December 2021. So what happened in these months that could have contributed or could explain the imbalance that we see? And then you immediately think about the COVID pandemic, COVID vaccinations that were recommended during that time, because we enrolled all year round, and we also enrolled during the COVID pandemic. So then we started to look at which additional vaccines these women have received during pregnancy. In our study, women could receive additional vaccines 2 weeks before the investigational vaccine or 2 weeks after. So the additional vaccines were given according to the standard of care, but also to the participants' choice. So what these women received, which vaccines they received, when they were received, and how many they received during pregnancy varies quite a bit from one participant to another. So when you look at the analysis here on the slide, when women had received no additional vaccine versus women who received additional vaccines. An important point to point out, and I'm going to mention it a couple of times because I really feel it's important, is that in both groups, you see a decrease of the preterm birth rates when these women received additional vaccines. So in the RSV pre-F3 group, you see the percentage goes from 9.33 to 5.68. In the placebo group, 7.84 to 3.70. So both have a decrease in preterm birth. However, the decrease was higher in the placebo group compared to the maternal group, which leads finally to a higher relative risk. So when these women received additional vaccines, you have a higher relative risk. So the imbalance has increased, but the absolute risk of preterm birth is decreased. We then looked again by economic region, right? And what you see again here is a similar pattern, both for the RSV group and the placebo group, but also for the both economic regions, you see a decrease in preterm birth rates with additional vaccines. And again, that decrease is higher in the placebo group than it is in the RSV maternal group, which leads again to higher relative risks. And the highest relative risk that we have observed here is in low middle income countries when women received additional vaccines. We have a relative risk there of 1.9. So then we plotted the preterm birth rates, so the monthly preterm birth rates, over the additional vaccines when they were given in time. And what you can see here, again, the blue represents the data for the RSV maternal group, and then this reddish color is the placebo group. You can see that the temporal clustering observed in preterm birth rate coincided with the months when most of these additional vaccines were given. And again, when we split by region, low, middle income, high income, you see that even correlated better and with the low middle income countries compared to the high income countries. We investigated a lot of other factors as well, and I don't have the time here to go into the details, but that gives you an idea of things that have been done, investigation that have been done. And none of these factors can explain the safety signal that we have observed, including SARS-CoV-2 infections. So the study showed an increased risk in preterm birth in the RSV maternal group compared to the placebo group. The imbalance in preterm birth, however, varies depending on where you look, low middle income countries, high income countries. When you look, there seems to be that temporal clustering from April to December 2021. And whether or not these women received additional vaccines during pregnancy, and again, this correlated with the temporal clustering in preterm birth. Now, the mechanism underlying the observations here has not been determined yet, but we clearly see a pattern emerging. As I said, our study is still ongoing. We're still continuing the investigation. But I hope that these findings will help us to better understand the safety data of the trial and could help also to improve an overall benefit-risk assessment in maternal immunization studies. Just some key learnings to close. There was a higher risk of preterm birth in the RSV maternal group versus the placebo group. The imbalance in preterm births was seen independent of a variety of factors that we assessed. The numerical imbalance in neonatal deaths was a consequence of the imbalance in preterm births and is not an independent safety signal. The imbalance in preterm births between the RSV maternal group and the placebo group was higher in low middle income countries. Administration of vaccines, and I'm going to point it out once more, decreased preterm birth rates in both groups, but it increased the imbalance between the groups. The imbalance in preterm birth between the groups was the highest in low middle income countries when additional vaccines were administered, and the temporal clustering of additional vaccines administered correlated with the clustering of preterm birth. I have to say that we have not seen, I said it in the beginning, we have not seen the safety signal in any of our other pregnant woman trial or in trials in non-pregnant women. We had no safety. This is the only trial that actually shows this safety signal. With that, I would like to thank everyone, but I really would like to thank the study investigators, the IDMC members, the study participants, and our team members. It has been a very challenging year for us, as you can imagine, and their relentless efforts and constructive collaboration were really key to ensure that we provide the best possible care to our patients and to our participants and their infants. So sincerely, thank you. Thank you.
Thank you, Ilsa, for this very, very detailed presentation. I know Keith already has a question.
So thanks. You know, you've made a compelling argument that there doesn't seem to be a temporal relationship with the administration of this vaccine, and then a complex relationship perhaps with the administration of other vaccines. But I want to ask a more overarching question. I don't know how many adverse events you were monitoring, but in your statistical analysis, is there not an argument you should be using some kind of Bonferroni or other adjustment to decide whether something's statistically significant? And I wonder what your statisticians say about that, and was that done?
You mean specifically on preterm births, or to see whether something correlates?
Well, you're following many, many disparate potential adverse events, and therefore if you have an adverse event, one specific one, shouldn't there be some correction for multiple events?
I'm not a statistician, for sure, but they have done multiple analyses, looked at multiple models, multi-adjustments have been done. They're even now also looking into very complex models and statistics to try to see whether we could find something. Up till now, nothing has actually, apart from what I just showed on the low middle income countries, is basically the only parameter that shows a difference between the groups and could be an indicator. But other than that, we have not found anything.
Thank you. Unfortunately, we have very little time for questions, so we will only take 2 questions. I'm going to take the first 2 questions right in front. I'm starting with you.
Okay, thank you. Christopher Gill, Boston University School of Public Health. So the thing that struck me most about your time series data was not that the event rate had gone up in the vaccinated group, but that the event rate had gone down in the placebo group, which biologically makes no sense. So it made me immediately wonder, like, is it possible that there was some break in the blinding of the placebos? That somehow they knew that this was the inactive control. So I'm wondering, one quick check on that was whether you saw the same effect across multiple countries. You say LMICs, plural, but was it in fact all LMICs? There were 10 in your study. How did the trends break down by country?
Right, by country. So the preterm birth rates are not that high. So per country, 24 countries, some of the countries have very little number of preterm births. So we can't really make firm conclusions on a country level basis, so we need to cluster them if you want to see something. But there are, in the low middle income countries, there are some of the countries that are the main drivers of these preterm births, which we looked into, but they don't by no means are statistically significant numbers. So there is variation. I was mentioning the US. The US, for instance, has a relative risk of 1.24, so it's an intermediate risk, although it is classified as a high-income country. So the categorization, as I said before, in LMIC, HIC is not perfect. We have tried to look into different other parameters that could potentially better match this economic category, but we haven't found any up till now. So it is not perfect, but there is a definite cluster of these countries where you see a higher risk of preterm birth.
We'll only take one more question. I'm really, really sorry. Do not kill me, but can we please ensure they all sit together for dinner tonight?
I will make myself available at the break. Yeah.
I'll defer to Octavio. My question was partially answered, and I'm interested in your.
I mean, this is no. You need to do. Oh. Okay. Thank you. First of all, thank you so much for presenting this. This only speaks highly of you and your team. We really appreciate that.
Thank you.
Second, I really feel that you touched something that is key. When we define economic groups by country is not appropriate, and I think it will be very important if you can study the income, maybe in each country. The reason is that you talk at the end about inflammatory responses, and I wonder if how you study that. There is a lot of work being done when you study social determinants of health. Pregnant women of low income in the US have increased inflammation, right? So it's not just psychological, we have a biological correlate. And I wonder if that could be a factor that correlates with your premature birth.
Yeah, it's a very, very good question and suggestion. I mean, we had to work with the samples that we had, because obviously we weren't planned with that, so we may not have the most accurate samples to do this. So for the inflammatory response, we looked at the day of vaccination, so the day the women enrolled, so day 0, and then we looked at day 31, because that was the first sample that we had post-vaccination. It may not fully reflect what the inflammation could have been, but we also looked obviously on time to event. So when these mothers delivered, there's no difference between the groups, and actually the mean time was around 50 days. So they did not deliver immediately after vaccination. So if there would have been a storm, an inflammatory storm, it did not trigger preterm birth. It is not ideal, but we have done what we could with the samples that we had, and there was. We could not identify even an inflammatory response that was there, and between the groups there was no difference.
Okay. So thanks, and I would now want to invite Victoria Jenkins from Bavarian Nordic, which is, of course, quite famous for their Mpox vaccine, but they're going to talk to us now about RSV.
Hello, my name is Victoria Jenkins, and I'm here to talk to you about the title of my talk, which is The Quest for a Respiratory Syncytial Virus Vaccine for Older Adults. So there's a bit of a switch now from maternal to older adults, and I appreciate the next talk is also maternal. And thinking beyond the F protein. Firstly, I want to start by thanking the organisers for allowing me to present this data with you all today. And this is my disclosure form. I work for Bavarian Nordic, as do all the authors of this presentation. Now, I wanted to start by saying this is a very exciting time for RSV vaccines for older adults. We have seen data now from 3 phase 3 studies with efficacy data, which is fantastic news. But there are still questions remaining, for example, the durability of these vaccines, and we eagerly anticipate this. And as we heard this morning, there are questions, what will happen if we have selection pressure potentially on the F protein? Will there be need for multi-component vaccines? And that's what I want to talk to you about today. So MVABN RSV is a bivalent vaccine targeting 5 RSV proteins. This is using a viral vector, so as you alluded to, it's based on the MVABN vaccine, which is licensed in the US as Jynneos and in Europe as Invamex for the protection against smallpox and Mpox. The advantage of using an MVA viral vector is it's a large DNA genome, which will tolerate large amounts of foreign DNA. And because of this, we've been able to insert 5 RSV proteins. And so these are the F protein, which we've heard a lot about. This is actually encoded in its native conformation, and we have data from antigen-presenting cells that this is expressed in both its pre- and post-F conformation. We also have the 2 G proteins from the 2 subtypes, so RSV-A and RSV-B, because this is highly variable between the 2 subtypes. And we also then have the 2 conserved internal proteins, M21 and N, and these are included because they're strong inducers of interferon gamma T-cell responses. So really this vaccine has been designed to produce a broad humoral and also T-cell response. So I wanted to give you a bit of a background about the product and why we chose a multi-component vaccine. So this is data from mice. And what you can see here in the first chart, hold on. Voila. So this is the first chart here, and this is looking at the T-cell responses in the spleen of mice detected by ELIS blot. And what you can see here is they're probed with the F, G, and M21 specific probes, and in the non-vaccinated mice, as you would expect, that you see no T-cell response. In the mice who've been previously exposed to RSV, what you see is a distributed response with the F, G, and M2 probes. And then we looked at a variety of constructs using MVABN, which had either the F protein, where you imagine then they get the responses to the F, either with the F and the G genes encoded, so you get stimulation with the F and G insert. But then interestingly, if you look at MVABN RSV, so this is the vaccine with the 5 inserts, what we see actually is that you get a similar ratio as to mice who've been exposed to RSV. So you get the similar ratio of F, G, and M2 responses, but actually the magnitude of the response is much larger. So if we then look at efficacy in these mice, okay, it's a mouse model, and here we're looking at mice who've been exposed to RSV, whether they were vaccinated first and then exposed to RSV, or if they've been pre-exposed to RSV previously. And here we look at the RSV viral load in the lungs. And if you look at the non-vaccinated mice, as you would expect, they have a higher viral load in the lungs than the mice who've been previously exposed to RSV. Then again, if we look at our variety of constructs using the MVABN with either G or F, what you see is a small decrease of the viral load in the lung of these mice. But then if we add F and G, you see an improved response or protection, so again, an improved decrease in viral load. But really, if you look at the MVABN RSV vaccine, this is where we see the greatest reduction in viral load in the lung of these mice, which is comparable to those who've been pre-exposed with RSV. So moving on to the phase 2 data, so this is clinical data in older adults who are aged over 55, equal to or over 55 years of age. This study was a phase 2 dose finding and schedule finding study in over 400 participants. But what I'm showing you here is a subset of the study. And so these participants are the ones who received a single injection at 5 times 10 to the 8 infectious units per 0.5 mils. And this is actually the concentration that has been carried forward in the future studies. So what we see on the left-hand chart is the humoral immune response, and this is in fold increase from the baseline titers. And what you see here is over a threefold increase in serum IgA from the ELISA. And if we look at neutralizing antibody titers measured by PRNT against RSV-A and RSV-B, these are about a 1.5-fold increase. If we look at the chart on the right-hand side, again, these are fold increases, and this is the interferon gamma response as measured by Ellis blot. What you can see firstly is that there is a broad immune response here. So we see a good immune response against all 5 inserts which are in the vaccine. And particularly if we pay attention to the internal proteins, the M2 and the N, what we see is over a 7-fold and 9-fold increase in the responses here. Now, actually, there was a follow-up part of this study where we could look at the immune responses at week 56. And if you want to read the paper, there is a booster element to this study. But if we just take the immune responses looking at durability, again, this is the T cell response, and now we're looking at the magnitude of the T cell response. What we can see is that the majority of them were above baseline at week 56, and the N and F2 pools remain 2-fold to 2.7-fold above baseline. So before we invested in a large phase 3 study, Bavarian Nordic took the decision to look at how well the potential efficacy of the vaccine, or how well the vaccine performed in a human challenge study. Now, this was described very nicely by Professor Openshaw yesterday, the concept of a human challenge study. But I do want to highlight that in this study, you do use an attenuated vaccine strain, so it really is only a model a model system. And here, differently to the target of the vaccine, is healthy adults were vaccinated, and these were aged 18 to 50 years of age. However, it is still an interesting model to get some insights into how well the vaccine could work. So the design of the study is that the participants were vaccinated at minus 28 days, so day 0 is actually the day of intranasal viral challenge with the RSV-A Memphis 37 strain. And then the participants are in quarantine, and this means that they fill out symptom cards, and you can look at the viral load in these participants. And they remain in quarantine for up to 12 days. And there was a follow-up part of this study where we did look at the immunogenicity in these participants. However, that's not shown on these graphs at the moment. So the primary endpoint of a human challenge study is usually the viral load and area under the curve. And that is what the top graph here is showing. So this is measured by qRT-PCR, and this is looking at the mean viral load over time in the nasal passage of the participants. And what you can see quite nicely here is in the blue line here, this is the vaccinated group, and the gray line are actually in the placebo group. And what you can see is the area under the curve is much smaller for the vaccinated group than it is for the placebo group. So we met the primary endpoint of this study, that it was the viral area under the curve was significantly lower in the vaccinated group than the placebo group. What we can also look at in this model is the symptom score. So the participants can fill out a symptom diary 3 times a day. And here, you can see the mean symptom scores over time, and quite nicely it matches the viral load. In the blue column here is the MVABN RSV vaccinated group, which is much lower than the placebo group, which you can see in gray. From this, we can get some indication of vaccine efficacy in this model system, and what we see is 79% efficacy in reducing symptomatic RSV as determined by RT-PCR, and we see 88.5% efficacy as determined by cell culture. We also looked at the immunogenicity of these participants. This is also looking at interferon gamma Ellis blood. And this is the geometric mean spot-forming units that you can see here. So what you can see, and I will start by talking about the top graph here. So this is really the F pool, but the story is the same for all the different ones, is that what you see initially is pre-vaccination, and then you see a peak response 7 days after vaccination. In the vaccinated group. So that is the red line here. What you then see upon viral challenge is you see either minimal or no increase in the immune response in the vaccinated group. However, in the placebo group, which is in blue, actually you see here that there is an immune response upon exposure to RSV. And these immune responses are above baseline at 6 months in both groups. However, what is quite interesting is particularly for the internal antigens, so the M21 and the N pool, which you can see at the bottom, is that the vaccinated group, the baseline values were greater than twofold above baseline, and these were actually higher than what you can see in the placebo group, who had only been exposed to the RSV. So if we move on to the safety, some safety data of the vaccine, this is looking at the incidence of solicited systemic and local adverse events. And this is actually pooled data from all completed studies with the vaccine. So this includes phase 1, phase 2, and also the human challenge trial data. In total, 424 participants have been exposed to MVA-BN RSV. And so far, no serious adverse events have been reported as related to the vaccine. All solicited and unsolicited adverse events were mild of nature and resolved without sequelae. And as expected, pain and erythema were the most common solicited adverse events. So to conclude, MVA-BN RSV is the only late-stage bivalent vaccine targeting 5 RSV proteins. We've seen high vaccine efficacy in healthy adult participants for symptomatic RSV infection in the human challenge trial study. No serious adverse events have been reported as related to the vaccination. We've seen a broad T-cell and humoral immune response after vaccination with MVA-BN RSV in older adults, so this is the data from the phase 2 study, and T-cell responses were above baseline at 12 months. And currently this vaccine is being investigated in an ongoing phase 3 study. Thank you all for your attention.
Well, thanks, Victoria. That was fascinating, and you certainly showed some pretty impressive T-cell responses. One could argue, of course, that it's a pity you didn't choose a prefusion form of the F, because it, we know, generates far-fold higher neutralizing antibodies, and you didn't share much in the way of neutralizing antibody with us. So I don't know if you see the sort of 10-fold rises in neutralizing antibody.
Well, that was presented in the phase 2 data with the PRNT assay, and there we see about a 1.5-fold increase.
Yeah,
but it's
that's
interesting,
what you'd expect.
And we see about the same fold increase in the human challenge model, but we saw efficacy, which tends to suggest either from the assay we're not measuring all the neutralizing antibody titers, or there's another mode of protection that we're stimulating, and perhaps there the T cells become more important.
Well, fabulous. One question. Good.
So I was wondering if you consider running the human challenge with the same vaccine only with your F protein, because, for example, for other respiratory viruses, there's clinical data showing on flu, for example, that T cells do not have any protection. So I was just wondering if you consider that.
We haven't considered it, just running it with the F protein. I mean, really, the idea of our vaccine was to develop a broad T-cell and humoral immune response. We do have, okay, it's animal data, and there is some data also in the published literature that actually T-cells could be important in the protection against RSV. And so really, it was that response we were looking for, and the reason we chose a multi-component vaccine and took this one through to the human challenge trial and eventually the phase 3 study.
Well, thank you.
Thank you.
And with that, we go on to our last presentation, which is Beata Kampmann, who's a true European. She's now working at Charité, but retains her affiliations to that island that used to be linked to Europe. And she's going to share with us, I think, some very exciting data on the Pfizer trial.
Thanks, Keith, for taking the mickey out of my rather strange CV. Right, thank you very much. So, hang on, slide would be good. Will it come up, or do I need to do it?
It's probably coming slowly. There we go.
All right. Yeah, my name is Beate Kampmann, and I'm not an employee of Pfizer, but I've been trusted with presenting the data from the large-scale study that was done assessing a pre-fusion RSV vaccine in pregnant women. Here's our disclosure slide. We have, oops, if I could use this. Okay. We have received funding at our site for conducting this trial, and there are many investigators in this room as well who were involved here, and I'm really here to represent the joint work, so thank you for trusting me with this task. So I don't think I need to dwell on the issue that only pre-fusion F can bind host cells for RSV to infect, and that by far the most specific and blocking virus infection antibodies come from the pre-fusion work. And that is the reason why this candidate went into the trial based on very promising phase 1 and phase 2 data. So the Matisse trial is a double-blind randomized controlled trial of a pre-fusion F vaccine in women who are pregnant between 24 and 36 weeks of the age of under 49 years. It enrolled 7,392 women in a total of 18 countries that are represented on the graph here. And that involved 45% of people in the US and 30% in low and middle income countries. The trial then resulted in 7,128 infants who were born to these women. And here is an outline of the trial design. There was pre-screening done with antenatal ultrasound, of course. The women were vaccinated and then had a 7-day diary, which led to adverse event being collected from consent to the study up to day 28 actively, and then adverse events of special interest and severe adverse events till the end of the study, which was in the women, a 6 months post-delivery follow-up. And you can see here a blood sample was also taken at the time of delivery to look at the maternal antibody. Respiratory tract infection surveillance was captured as an endpoint from the vaccination till the end of the study in women who presented with medically attended respiratory tract illnesses. In the infants, the trial started really when the infants were born with cord blood, again to ascertain the titers. And adverse events were then collected up to 28 days of age actively. And then very active RTI surveillance was carried out through e-diaries, where there was weekly contact with mothers. And if there was a respiratory tract illness, a site visit and a nasal swab was sent, which was then subjected to a centralized laboratory evaluation via PCR. Following 6 months, so that's after visit 3, there was monthly contact with the mothers, and only severe lower respiratory tract illnesses required a visit and nasal swabs. However, any adverse events of special interest, etc., were followed till the end of the study, which was 2 years follow-up in infants who enrolled in year 1 of the study, and 12 months follow-up for infants who enrolled in year 2. Oops, have I gone? Oh, sorry, I've gone the wrong way. Here we go. So here the brief look at the demographics. As you can see, really the placebo and the vaccinated RSV vaccinated group were very well matched. I don't want to dwell on the details of this, but there was also a considerable ethnic mix. The age at vaccination overall was 30 years of age, again between placebo and vaccination group, RSV vaccinated group, very well matched. What is also of interest that there was a good spread of vaccines being administered throughout the gestational age that was part of the inclusion criteria, with the majority being vaccinated between 32 and 36 weeks, but also a good spread of women who had been vaccinated during the other gestational windows. When it comes to the infants, again, the ethnicity is not really going to be very different from the one of their mums, and again, it shows a good match between the two populations. more interestingly, now reporting on the safety data, you can see that there were virtually no severe reactions. Apart the most frequent side effect, local side effect, was pain at injection site, but all of this was mild to moderate. When it comes to systemic events by maximum severity, you can see that pregnancy per se leads to a great deal of fatigue, and there was no significant difference really in the placebo versus the RSV vaccines, and the fevers that we observed were also very, very mild. So that's, again, was showing that there was very little systemic severity. Here you can see that other systemic events are relatively well matched. Muscle pain, of course, higher with the vaccine, and the rest, as you can see, everything very much mild to moderate. Now looking at the any AEs or any severe adverse events, again, pretty well matched between the placebo and the real vaccine recipients. And we can go into it if there are any further detailed questions afterwards. But there was no significant difference in any of the number of participants reporting adverse events by category 1 month after the vaccination. If we then look at the infants, infants or babies, newborn babies suffer a number of adverse events in the first month of life. Every pediatrician knows this. So the rate of adverse events in general is always higher, as it will be in older people. But again, a complete match between babies whose mothers were vaccinated with the RSV vaccine as opposed to placebo, and no signs here, no signals between any significant differences in the adverse events in the infants. Now to the efficacy endpoints. First of all, the definitions. What is really important is you remember that there's weekly active surveillance for acute respiratory infections, and any symptoms are triggering a nasal swab and a possible visit, and any of those swabs would have been evaluated by RT-PCR in a central laboratory. Medically attended RSV lower respiratory tract illnesses were defined as a physician visit and at least one of the following: tachypnea with respiratory rate above 60, or saturations below 95. Just well in drawing, you only needed at least one of those. The medically attended severe RSV lower respiratory tract illnesses involved saturations less than 93 and possibly respiratory support with oxygen and an increased tachypnea. So these endpoints had equal standing in the adjudication. If we look at the results, they are divided into intervals post-birth, and 90 days after birth, there were 6 cases in the group that received the maternal vaccine and 33 cases in the placebo group, which resulted in an overall vaccine efficacy of 81.8%, which certainly, as expected, decreases a bit as time goes on. In the ones that had medically attended lower respiratory tract infection, not necessarily classified as severe, there were 24 cases 90 days after birth, 56 cases in the placebo group, with a vaccine efficacy overall of 57.1. And this is quite a broad confidence interval, which didn't quite reach statistical significance, the endpoint specifications. However, if you look further down, these confidence intervals are smaller and the efficacy remained. So the question will come whether there were differences in the regions where this vaccine was given. Here's a comparison at, in this case, 180 days, where we reported the vaccine efficacy as being 69.4%. 6 cases in the low and middle income countries, 26 in the placebo group, versus 13 in high income and 36 in the placebo group, giving a vaccine efficacy of 76.9 for the low and middle income and 64 for the high income. And for the lower respiratory tract infections not classified as severe, you can see the data here. So in summary, The RSV prefusion vaccine has been found efficacious against severe infant medically attended lower respiratory tract illnesses in phase 3 with a favorable safety profile, as I've already said, in the first 90 days of life with a vaccine efficacy of 81%, 6 months follow-up 69.4%, and 57 and 51% for those who were not severe. Overall, with a very favorable benefit-risk profile for the maternal population and their newborns. I'm happy to take any questions. Thank you. Hang on, no, before I take any questions, I would like to, of course, acknowledge all the work of the enormous team that has been part of this trial, and in particular the participants and families who trusted us with their women, pregnant women, and newborn babies, and the Pfizer Essential colleagues and vendors. And I just would like to also acknowledge my colleagues from the Gambia, who unfortunately could not be here because the Portuguese embassy decided not to give them visas. And if I just make the point that we are nearing a situation where people from low-income countries are no longer finding it easy to come to conferences, despite of the conference organizers making the best efforts, and people, being set up with hybrid things when they need networks meetings like here. So we all need to call this out. Anyhow, let's talk about the data. Thank you.
Thank you, Beata. It's not usual for the chair to have to make a disclosure, but so excited were we at the Gates Foundation by these data that although we have no ownership of this vaccine in any way, shape, or form, we did make a major contribution to the company to make a multi-dose vial and make the vaccine available at an affordable price and volume to Gavi. So we are very excited by this, but having said all of that, the one bit of safety information you didn't share with us was prematurity. Can you share whatever you know about that?
I can. Okay, so there was no statistically significant difference in the levels of prematurity between the two arms. Overall, the levels of prematurity were around 5%, which is much lower than we would anticipate in the settings in which we are, which just means participation in clinical trials improves clinical care. There is, obviously, cases are still accruing, but there were early preterms were 0.6 versus 0.3, developmental delay 0.3 versus 0.3, exactly the same, and less in the group with 34 to 37 weeks. There were 5.6 versus 4.7, so there's no statistically significant difference there.
Okay. Well, I think with that then, we've come to the end of what Shajuti and I described as the most exciting session of the meeting. We hope you agreed with us, and thank you all very much for your attention. We're sorry we went over a little in time. Thank you. Good, so we were a bit over time, but that's okay. It's nearly past. Okay.
I think that was a very...
Yeah.
Please, leave the stage for the next session, please.
How do we even... Hello. Hello, everyone. We are going to jump straight to the next session.
I think the discussions probably can take place outside of the room, if you don't mind. And well, thank you, Keith, for saying that your session was very exciting. This is going to be the most exciting session of the conference. And well, thank you so much for everyone to attend. And I actually would like to personally welcome you to Portugal. That is the first time I'm taking the stage at the conference. And so this session is going to have two parts. So I'm going to chair the first part. I'm Marta Nunes, a professor at Claude Bernard University in Lyon, France. And my co-chair, Patrick, will introduce himself in the second part of the session. So I do think that this is a very important session due to many products coming into the market. I think Keith raised some important issues in the previous session, and we really need to prepare in advance to really enable equitable access to vaccines and to the products that are coming in the market. So hopefully the discussion we have in this session will be very important. We learned many lessons from COVID, and I think two important points are very relevant for this session. One was the inequitable access and the manufacturing of vaccines that we saw during COVID, and so we do need to have a solution for the new products. Another lesson was really how difficult it was to establish a lifelong course vaccination, so how we can reach adults that RSV products will also be targeting. We also need to have a discussion about the accessibility of these new products in low-middle income countries, so our session is going to address that. And really what happened then in low-middle income countries, what will be the ethical issues, what will be the regulatory issues. So some of our sessions today will address this type of issues. So without further ado, I would like to introduce Erin Sparrow, that I know Erin for a long time from our influenza days, and Erin is part of the WHO Department of Immunization. And he will be talking about enabling policy decision for RSV immunization products with a focus in lower and middle income countries. Welcome, Erin.
Thank you, Marta, and thank you to everybody who stayed in the room this late in the day for this, what we believe is a very important session. So as Marta mentioned, I'm going to be presenting on enabling global policy decisions with a focus on low and middle income countries around the introduction of RSV immunization products. Oh, not there yet. Just
Can we have the slides, please?
There we go. So as Keith already mentioned, it's been sort of something like 60 years that RSV vaccines have been in development, and we are finally on the verge of seeing products start to make it through to market authorization. Nirsevimab has been licensed by the European Medicines Agency. We've just learned today that the Pfizer maternal vaccine has received priority review by the FDA, and it looks like there'll be at least a couple of older adult vaccines licensed this year. Yet we are still a long way to go before we actually prevent RSV disease to those that need it most. Low and middle income countries account for the vast majority of births. Collectively, they account for over 90% of the global birth cohort each year. And they also account for the majority of burden in young children due to RSV, with 95% of RSV ALRI and 97% of associated deaths occurring in low and middle income countries. And while data on the burden of RSV in older adults is very limited, in fact, I think Ed presented that yesterday, I just wanted to add that grandparents play a very important role in low and middle income countries in the care of their grandchildren. And there is an increasing trend in what we call skip households, where adults or parents have moved away to urban settings to find work, or even in some cases to other countries leaving behind the grandparents to raise the grandchildren. And the data, of course, are limited. We don't know really anything about the burden of RSV in those populations. The demographics are different, but I do think that as we see products for older adults start to be licensed in high-income countries, we need to start gathering data around what that burden looks like in low and middle-income countries. But I'm going to be focusing this presentation on enabling policy decisions for RSV immunisation products that protect young children, where we do know that there is a very large burden of disease in low-income country settings. So as products start to get licensed, when will low and middle-income countries introduce them? And unfortunately, from a historical view, there has been a delay in the introduction of vaccines into low and middle-income countries after authorisation in high-income countries. And this graph shows HPV introductions, and it shows the number of countries that had introduced HPV vaccine by 2019. And what you'll see is that 21% of low-income countries had introduced HPV vaccines by 2019, 30% of lower middle income, 58% of upper middle income, and 79% of high-income countries. On a global scale, this translated to 52% of all countries having introduced HPV vaccines in 2019, which sounds actually pretty good, but when you look at that on a population level and you look at that on a coverage level, it only translated to 25% of girls receiving one dose of HPV vaccine. And unfortunately, because of the COVID-19 pandemic and a drop in vaccine coverage, that coverage actually dropped in 2021 to only 15% of girls having received a dose of HPV vaccine. And just to note that HPV vaccines were first licensed in 2006. So we're now talking about 15 years or more after their first licensure. So is this what we might expect for RSV? And I'm using a very extreme example. HPV obviously has its own story. It's got its own issues. The benefits take years to see. There's obviously controversial issues around immunising girls, which is perceived by many to be a sexually transmitted infection. And it also came with a lot of supply constraints. There was major supply shortages in the access of HPV vaccine. But RSV is not without its issues too. When we talk about maternal vaccines, an antenatal care delivery system is required, and it needs to be delivered during a very specific gestational age in pregnancy, which may be challenging for some countries. In addition, there are issues with the monoclonal antibodies. I think Ron mentioned this earlier, that even in Israel, trying to have some kind of seasonal dosing strategy is going to be difficult. So how would that work in a low and middle income country? Would they have a birth dose? Would they have the first dose given at the EPI visit? Or would they be trying to figure out when the RSV season is starting and then immunise a range of different children at the same time? There's also issues with the cost, especially for the monoclonal antibodies, which we expect to be priced much more expensive than the maternal vaccines. Did I do that?
I think just try.
Oh, yeah. And then, it's great that it's really, really encouraging that Pfizer has received this financing from Bill and Melinda Gates Foundation to have an affordable maternal vaccine for low and middle income countries. But what about the really sort of middle income countries, those countries that are not Gavi eligible? Where do they fall into this? And there's also issues with the awareness of RSV disease burden in low and middle income countries. And it's not just HPV vaccine that has issues. As I mentioned, there has been a slide in global immunisation coverage because of the COVID-19 pandemic. And what we saw that between 2019 and 2021, global coverage, and this is measured by DTP-containing vaccines, dropped from 86% to 81%. And that graph there on the right shows the overall sort of trend in coverage over time between 2000 and 2021. But if you look at that box at the bottom there that's sort of highlighted, that shows how coverage dropped between 2019 and 2021. And that's by Gavi income group. So high-income countries are at the top, tiny little decrease. Middle income countries and those never eligible for Gavi support, bit of a drop. And then when you look at those 17 former Gavi eligible countries, they've dropped from sort of 83% right down to 70% coverage. And also quite a big drop in the countries that are still Gavi eligible. Also in 2021, there were an estimated 25 million children that did not receive basic vaccines. This is the highest number since 2009. I already mentioned the slip in HPV vaccination coverage, but this equates to an additional 3.5 million girls not vaccinated against HPV when compared to 2019. And in 2021, the number of completely unvaccinated children, and these are the children that we refer to as zero-dose children, actually increased by an additional 5 million children that have never received a single dose of any vaccine. So in the context of all of these other immunisation priorities, and in the context of other competing health priorities and limited resources, how are policymakers in low and middle income countries going to decide on the introduction of RSV immunisation products? Is that me again? Keeps disappearing. So first of all, they're going to want to know what the burden of disease is. They're going to want to see evidence of RSV disease burden, and they're going to want to see that at the country level if it is available. If it's not available at the country level, then they'll look at the regional level, at neighbouring countries. The global modelling studies are great. They give sort of these big picture overviews, but it's not enough for decision makers in low and middle income countries to decide about whether or not they want to introduce RSV immunisation products. They'll also want to know about the impact. So not only what is the efficacy, but how does that translate in terms of impact in their countries? How many hospitalisations are they going to avoid? How many beds are they going to free up? Is there going to be an impact on the infant deaths in their country? And they'll want to know whether or not interventions are cost effective in their local context. They'll also look to global, regional and national immunisation advisory bodies. So this is SAGE, RITAGs and NITAGs, and to see what their recommendations are. And there'll be a range of programmatic considerations that they're going to need to look at, including the strength of their antenatal care system in case of maternal vaccines, whether or not they can actually absorb another vaccine into their crowded immunisation schedule. Do they have the cold chain capacity? Do they have the waste management capacity? And do they have the health workforce capacity in an already very, very crowded schedule? They'll also look at the financing and procurement opportunities. So for Gavi-eligible countries, that Gavi support is really important. And for other countries, having that bulk procurement through UNICEF Supply Division or through the PAHU Revolving Fund for Latin American countries is going to be really important. So just a little bit on SAGE. So SAGE is the WHO Strategic Advisory Group of Experts on Immunisation. They are our principal advisory group to WHO on vaccine policy. They comprise up to 20 independent experts representing all WHO regions. And they're tasked with providing WHO with recommendations around optimal vaccine use. The recommendations provided by SAGE become what we call WHO vaccine position papers. And these position papers may recommend the widespread use of vaccine. It may recommend the use of vaccine only in certain populations or in certain risk groups, or it may not recommend a vaccine at all, which I don't think is going to be the case for RSV. But in 2023, so this year, we are moving ahead with the formation of a SAGE working group to review RSV immunisation products. And we're hoping to have a policy recommendation around the use of these products out in 2024. And just a note to say that that SAGE policy recommendation is needed to sort of open up the tap on Gavi financing. The role of RITAGs, NITAGs and governments, this is essential to having RSV immunisation products introduced in low and middle income countries. There are 6 RITAGs that have been set up in all WHO regions, and they provide WHO regional directors and governments with advice on RSV immunisation, on immunisation issues at the regional level. There are also NITAGs, and NITAGs are national advisory bodies with national experts that provide advice to governments at the national level. Not all countries have NITAGs. There are 120 countries with NITAGs, but this has actually increased over time, and there is a trend that more and more countries are having their own NITAGs. But at the end of the day, the final decision is at the governmental level. So there might be a SAGE recommendation, there might be a RITAG recommendation, there might be a NITAG recommendation, but if a government simply doesn't have the resources or has other competing issues that they need to deal with, they may decide not to introduce RSV immunisation products. The role of Gavi is so fundamentally important to the future access of RSV immunisation products in the poorest countries in the world. I'm sure most of you in this room know that Gavi was founded in 2000. And since it was founded, it's received an investment of more than 21 billion from a range of philanthropic donors such as the Gates Foundation, but also governments and manufacturers. Vaccine manufacturers have made commitments to supply affordable vaccines to Gavi-eligible countries. And they've managed to immunise more than 981 million children since 2000. There were originally 74 Gavi-eligible countries, but over time, countries have graduated out of Gavi support, and there are now 57 countries that are the poorest countries in the world that are eligible for Gavi co-financing to support the introduction of new vaccines as well as other health system strengthening within their countries. Every 5 years, Gavi goes through a process that is known as the Vaccine Investment Strategy, or the Gavi VIS. And in the last vaccine investment strategy, which was 2018, they reviewed the current period, which was 2021 until 2025. And the Gavi board recommended that Gavi should support the introduction of both RSV maternal vaccines or monoclonal antibodies for Gavi-eligible countries, but contingent on there being a licensed product within that period, contingent on there being a WHO SAGE recommendation and pre-qualification. There were a lot of assumptions around pricing that they put into that model, so obviously contingent on there being an affordable product available to them, and of course on having access to the financing at the Gavi level to fund the introduction of vaccines into these countries. Unfortunately, due to COVID-19, the investments in the last Gavi VIS have been put on hold. This is for all vaccines, not just for RSV, and there is a new Gavi VIS project or program kicking off this year. We don't yet know how those vaccines that were approved in the last period will fall into this whole new VIS process, but we remain pretty confident that RSV will make it on the list. I mentioned that there is sort of a general lack of awareness about RSV in low and middle income countries, and this graph just shows something that Gavi did during the last vaccine investment strategy, where they did an analysis of in-country stakeholder perceptions, and they asked them to rank which vaccines were the most important. And you'll see RSV way down the bottom there, with only 11% of respondents actually saying that they thought that RSV was one of the most important vaccines to receive Gavi support. So in view of this lack of awareness, we've kicked off a project at WHO that we're calling the RSV Roadshow. And the purpose of the program is really to sort of start to sensitise regional level immunisation stakeholders and decision makers about RSV and what the burden is at the regional level and at the country level, so that they can make informed decisions about the future introduction of RSV immunisation products as they might become available to them in the future. The audience, as I mentioned, is regional level immunisation stakeholders, so RITAGs, NITAGs, EPI managers, but also ministries of health and the maternal and neonatal child health community, paediatricians and so forth. We are developing a package that will include presentations, fact sheets, recordings, and we've already sort of started to deliver some opportunistic presentations at regional technical advisory group meetings. We have a dedicated session on RSV coming up at the Global NITAG Network meeting in June. And then eventually what we want to move towards is actual regional workshops as we get closer to having products ready to introduce into low and middle income countries. The idea is that we would have this delivered through regional champions. So to conclude, we are on the verge of RSV prevention. It's taken 60 years to get here. But I think the reality is that we've still got a long way to go before we see these products actually make it to those that need them most. We can all play a role. Funders have a role to play. Manufacturers have a big role to play in ensuring global access and affordable pricing. Researchers have a role to play in better products, in more data, better data, and obviously the paediatricians, obstetricians, RITAGs, NITAGs, and governments. And I wanted to end with a quote from Cesar Milstein: "Science will only fulfill its promise when the benefits are equally shared by the really poor of the world." And I chose this quote by Cesar because he was one of the Nobel Prize winners for the discovery of the production of monoclonal antibodies. So thank you.
Thank you so much, Erin. This was really great. So we do have time for a couple of questions. So if anyone has questions and want to approach one of the microphones. And meanwhile, while people make their way to the microphones, Erin, so it was very interesting that you mentioned Gavi countries, and we all know how important Gavi is. But it's true what happens to the low middle income countries that are non-Gavi, that were never Gavi eligible countries. So actually, Gavi now is a program for never eligible Gavi countries and some support to those countries. But yeah, if you can just speculate, yeah, if for the countries that are low middle income but do not have the support of Gavi, how they could introduce a strategy for RSV support or any other.
So obviously those countries will not benefit from Gavi support. So tiered pricing from manufacturers. So where high-income countries pay more, and there's a sort of a pricing strategy where low and middle-income countries pay less, and maybe it's not the same price as the Gavi price, but that's going to be absolutely essential for these countries to introduce. And I showed that immunisation coverage, how it's declined, and you see that for those countries that were formerly Gavi eligible, the rates are going down.
Yeah. Any questions? Natalie's coming to.
Thanks for the nice talk. I just had a question about, I missed in your story, regulatory drug lag, and if there's something being done on the fact that usually it takes 4 to 7 years in places where there's minimal regulation to implement a vaccine. Can you say something about that?
Well, that's a great segue into the next presentation, which is from Thomas, who's not a regulator, but he's worked a lot on introduction of vaccines over many years.
Yeah, exactly. I was going to say that. Thank you. Erin already introduced Thomas. The next speaker is going to be Thomas Cherian, and he's from Global Health Consulting. Earlier, he worked on the immunization program also at the WHO in Geneva, and he was involved in the introduction of Haemophilus influenza B vaccination, pneumococcal conjugate vaccinations, and rotavirus vaccines in low and middle income countries. He will talk to us exactly about regulatory considerations to expedite the access of maternal RSV vaccination in low and middle income countries. Thank you, Thomas.
Thank you very much, Marta, and to the organizers for having me at this meeting. So in the next 15 minutes, I'm going to address the issues that are listed on this table of contents. And I have 15 minutes to go over 5 issues, so I'm going to very briefly and superficially touch on each of these. So as Erin already said in her closing statement, I'm not a regulator, so it's a hint, don't ask any regulatory questions. So I'm talking very much with the perspective that is said in the last part of this strategic goal in the RSV roadmap, which is to ensure that vaccines are available and affordable for global use, especially in low and middle income countries. So I joined WHO in 2000, and that was the year when Gavi was established. And countries were just, low and middle income countries were just beginning to introduce hepatitis B vaccine, and it took 2 decades between that was the lag period from when high-income countries started using the vaccine in their national programs to when Gavi-eligible countries actually got access to this vaccine. With Hib vaccine, we did slightly better. That lag period between when 50% of high-income countries had introduced Hib vaccine and 50% of low-income countries or Gavi-eligible countries had introduced the vaccine reduced to 9 years. And that was still not good enough. With pneumo and rota, we did even better. That time lag reduced to 4 years. And hopefully we can aim to have vaccines introduced almost simultaneously with the minimum of lag, especially for a vaccine as important and where the 97% of mortality occurs in low and middle income countries. And I'm going to focus only on vaccines, not on monoclonal antibodies, and I'm going to talk mainly about maternal vaccination and not infant vaccination at this point in time. So the focus of my talk is really on the regulatory considerations to make sure that you can expedite that access process. As I said, sometimes it can take a few years just to get over the regulatory hurdles, and what can you do to reduce those timelines? And because some of that also influences the prices that low and middle income countries may have to pay for the vaccines if the regulatory process is too cumbersome for the manufacturers. And what I'm not going to talk about is the usual regulatory process that is illustrated on the right side of the slide. Instead, I'm going to use the regulatory cascade of what happens after a vaccine receives market authorization in the first country. And so I'm assuming that this part will take place very soon. And so I'm going to focus on what happens next, which is the authorization of the vaccine in additional countries, some of which may happen in very short timelines, and some of which will take a longer period of time because they may be dependent on the WHO pre-qualification process. And I'll talk a little bit about what the WHO pre-qualification process is and how it can be used to actually expedite the market authorization of these vaccines in the low and middle income countries. So let me start with the first question, which is the assessment of the efficacy and safety for market authorization in LMICs. So in meetings like this, one of the questions that many people ask is, if there's a licensed vaccine, why do you need to do additional studies to get market authorization in other countries? Well, there may be scientifically valid reasons for conducting local assessments. For rotavirus vaccine, it was felt that the live oral vaccines behave differently in low middle income countries as opposed to higher income countries that necessitated efficacy trials in low and middle income countries before even WHO would issue a policy recommendation. And there may be reasons where people might say we need to see more data from low and middle income countries. We know that there are differences in the transfer of maternal antibodies from mothers to infants, with lower transfer rates in low and middle income country populations, and that might be a reason why people might ask for special studies. Sometimes countries will require local studies to fulfill either policy or legal requirements in the country itself, that they need to have that to give local market authorization. And of course, we also know that a single product is not going to meet global demands, and you will need multiple products, and we know many of those are in development. We heard about some of them during the course of this conference. So those new products will need to be authorized as well, assessed, and hopefully, if you can do this through immunobridging studies, rather than trying to do large efficacy trials, it may expedite the process of getting market authorization. So this is just a snapshot of a few countries, and I've picked a few low and middle income countries, and particularly the larger ones, and shown you which of those require local trials. So if you see, there are countries like South Africa, India, China, and Brazil that often require local data to provide market authorization. You will also see that some of these countries have a preference for using locally manufactured vaccines, especially when they are introducing them on a large scale in the national immunization program. So they have no problem importing a vaccine for the private market, but when it goes into the national immunization programs, there is a preference. It's not always the case. So a country like India, for example, may introduce a vaccine after importing it, but once they have to scale up and use it on a sustained basis, there is definitely a preference for a local product. And many of these countries do have adequate manufacturing in place. So these countries are helped by these these standards, which is the guidelines on the quality, safety, efficacy, and these have been published for RSV vaccines. So this provides guidance to regulators and to manufacturers and other relevant stakeholders on what are the requirements in terms of the development, manufacture, and control of the vaccines, the clinical evaluation of the vaccines, as well as some guidelines for the NRAs, or the national regulatory agencies. And I'm going to focus only on Part C, which is the clinical evaluation of these vaccines. So another step that WHO has already taken, in addition to having these, publishing these guidelines, is to try and standardize the antibody assays that will be required to evaluate some of these vaccines. And as one of these steps, WHO has established an international standard anti-serum, and this is based on pooled sera from adults with moderate or high levels of RSV antibodies. And an international collaborative study was done, which showed that between laboratory variability in neutralizing antibody titers are substantially reduced when the values were expressed as international units. And I think in one of the presentations today, you already saw the presentation of the results in international units. So this already exists. But there are additional steps that may be required. One is we need to have consensus on what are those serological criteria that have to be met to get market authorization. I remember that when the PCV vaccine was being, the Wyeth vaccine was registered, there were other vaccines that were in the pipeline. And when those manufacturers approached the regulatory authorities, they were told that they would have to show non-inferiority in the geometric mean titers against each of the serotypes in the vaccine. And that was going to be impossible for many of the manufacturers because you would never be able to show non-inferiority for every single serotype. And that required WHO to come in and convene all the regulators and come up with a consensus. And this may be an important step that may be required to have consensus on what are those, what is the correlate of protection, or what are the criteria that will be used for comparing different products or evaluating both this vaccine, the first vaccine in other countries that might want to evaluate it, and for evaluating additional vaccines. Even though there was a multi-laboratory study that was already done and the international standards published, there were laboratories that were outside the range, that didn't really, that had significant variability from the others. And with the pneumococcal vaccine, WHO had established 2 reference laboratories to support other labs in standardizing their assays and being able to do it in a way that is comparable to the others. And this may be another step that might be required. And finally, it will always be a good idea to have a repository of virus strains and cell lines if these are important for doing the neutralizing antibody assays. Then I go on to the next step, and that is about regulatory harmonization and reliance. So there was this study that was published a few years ago that looked at the challenges for registration of vaccines in emerging countries and the differences in the dossier requirements, the application process, and the evaluation processes. And this showed that there was a significant amount of divergence in the regulatory procedures that actually leads to a delay in market authorization. And that if there were steps taken to actually streamline the processes and remove the redundancies, it might expedite the access of these vaccines in the low and middle income countries. So there are 2 ways you can do this. One is through regulatory harmonization, and the second is through regulatory reliance. And what do we mean by regulatory harmonization? So harmonization is that the requirements are the same or very similar between the different regulatory agencies. So the same dossiers and the same CTD can be submitted to different regulatory authorities without having to do additional work. The second process is regulatory reliance, where countries rely on the assessments of another agency or a centralized authority. And again, there are different ways by which reliance happens currently, and there is always scope for improving on this. So that goes on to the process of the WHO pre-qualification. So WHO pre-qualification was initially established to enable UN agencies to procure vaccines for low and middle income countries. But this is now expanded in its scope so that it provides advice to NRAs, to immunization programs, national control laboratories, as well as vaccine manufacturers and this can facilitate the process for LMICs to have access to many of these vaccines. So there are 3 steps that need to happen for WHO pre-qualification. So firstly, the vaccine has to be licensed by a regulatory authority that meets all the WHO criteria for functionality. They don't have to be a stringent regulatory authority, but there are others that do meet all the functionality criteria. In addition, so once the vaccine is registered by one of these regulatory authorities, WHO will do an independent assessment of the product and its performance, and including all the production process, the quality control methods, and others to assess the product, and will periodically also assess the compliance with the good GMP. And WHO also makes available the WHO Collaborative Registration Process, or CRP, to countries who want to rely on WHO pre-qualification or market authorization by a stringent regulatory authority. And this is a process that countries can adopt and rely on WHO pre-qualification without going through the process themselves. And this was used quite a bit with the COVID-19 vaccines. You can also have regional authorities that play this role, and the European Medical Agency is a classical example, where there's a centralized review process conducted by 2 lead countries, a rapporteur and a co-rapporteur with input from the other countries. And this results in a legally binding, it's a centralized review process which is legally binding on all the other member authorities. And these things can significantly contribute to the efficiency of the authorization process. There are other regional bodies that are coming up now. So there is an African Medical Agency which aspires to follow the same structure and function and processes as the EMA. And this is a part of the African Medicines Regulatory Harmonization program of the African Union. There are also non-binding networks that will facilitate reliance. One example is the Pan American Network for Drug Regulatory Harmonization. And there are others that are listed here, the ICMRA and MAGP, and you can see the long forms of these. And you can see that some of the countries in the list that I showed before will use the WHO CRP or one of the other reliance processes to register their products. Next is about programmatic suitability for use. When rotavirus vaccines, and this was a hard lesson we learned with the introduction of pneumococcal and rotavirus vaccine. This was the first rotavirus vaccine that was made available. It came as a lyophilized powder in a syringe. It had to be reconstituted with a buffer in a vial and then administered orally to a child. The cold chain storage required for one course of rotavirus vaccine was 330 cubic centimeters. This would have increased the cold chain capacity as well as the transportation requirements for a vaccine tenfold. Now, this adds to the operational costs of vaccination. And remember, Gavi mainly supports the vaccine costs and not the operational costs. Now they do provide some support for cold chain, but a tenfold increase is really huge and would add to the operational costs of vaccination. So there was a second generation of vaccine which had a reduced cold chain storage and also had a vaccine vial monitor on it to reduce the closed vial wastage. And then finally, we came down to this presentation, which now has less than a tenfold decrease in the cold chain capacity required. But this process takes years to get from A to B, and it's much more useful to have this done up front. And that's what I think Gates Foundation, and as Keith mentioned, has already started investing in getting a multi-dose vial of the Pfizer vaccine. So once after this, the lessons that we learned with PCV and Rota, the pre-qualification process now includes what is called the programmatic suitability for pre-qualification. And it lists vaccine, has a list of different categories of mandatory, critical, unique, and preferred. So the mandatory, if you don't meet the vaccine, the presentation and packaging doesn't meet the mandatory criteria, the vaccine application for pre-qualification is automatically rejected. The preferred option, of course, is a multi-dose vial, which is less than 10 doses per vial. It's fully liquid, has an adequate preservative, and has a vaccine vial monitor on it. I've just given the mandatory characteristics, which is having appropriately preserved thermostability storage not less than -20, and a dose volume not more than 1 ml per dose for pediatric vaccines. And I have to say something about safety monitoring for maternal vaccines after the presentation that you heard in the previous session. So there was a project called the MIAXA project, which is Maternal Immunization and Antenatal Care Situation Analysis, which actually showed that while in many low-middle income countries, safety monitoring is improving, that mainly applies to childhood vaccination. The safety monitoring for maternal vaccinations or vaccination during pregnancy are not adequately developed. There is some work that can be leveraged upon. So there is this global alignment for safety assessment in pregnancy, or GAIA, which has established case definitions and guidelines and have a network of specialists to support LMICs in establishing and strengthening safety monitoring. We know that monitoring of stillbirths and preterm births is not, probably not even non-existent in many LMICs. But there are many of these countries do household surveys. There are these demographic surveillance sites, and some of these can be leveraged and strengthened, at least in a sample of countries, to be able to monitor preterm births, stillbirths, and other outcomes that are important for safety assessment. Similarly, many WHO regions have established birth defects monitoring. There are several regional networks that exist. Again, they can be leveraged to do the safety monitoring for maternal vaccines as and when they are introduced into the low middle income countries. I think that's my last slide. Thank you very much.
Thank you so much, Thomas. So we are just on time, but because we are going to poster session, so if there is any burning question, I think we can take it. Otherwise, I would suggest that who has questions can talk to the speakers outside during the poster session. And I just want to thank again both speakers, Thomas and Erin. Thank you so much. And so please be back at 6 sharp, because we'll have the visit of Barney Graham. And so he would like to see a full house when he's on video. So see you at 6. Thank you.
Maybe we would get sent into this.
Can I introduce you to Matthew?
Hi.
Matthew, June, just
Hi.
yeah,
Hi.
Matthew just
June
started.
Turner, I'm doing the pediatric maternal vaccine program at Moderna. And we're quite interested in RNA vaccines and we're interested in RSV vaccines for pregnancy. Yeah, exactly, yeah. Yeah, that's right, yeah. There's obviously potential for us to take populations, of course. So we're very, very, very interested in the data that we've just seen. So that's fascinating. Two presentations. Yeah. So you and what you're seeing, I mean, do we have any idea what extra vaccines have been given there? You've just done you gave the numbers and how's that what you look at
Of course, it's highly selective. Healthy pregnant women. It keeps switching back and forth is the problem.
So I don't think it's quite the same devastating infrastructure. But there were only two places.
I'm Sonia Stoshek. I met you online a couple of years ago. Actually, you were on GSK AdWork. So, yeah.
As long as it's safe and effective, I don't know. I haven't got cares until recently.
No.
We just do trials for products and we would like to see them.
Yeah.
But also, going from one person like this, it's going to make it slightly harder the next program. Well, that's it. If you were where we are now, we're thinking we've done so clearly it makes sense. If we were to be going into this population, this theoretically, then we'd be
Especially since there
Yeah.
What we were trying to put two and two together, so one theory would be the RSV was somehow interfering with COVID vaccine, so you're mitigating the benefits of COVID. Is this completely, I mean, in that ballpark?
Or, yeah.
Without going, but we've understood it correctly that basically getting the extra vaccine and getting an RSV vaccine less than the extra
And so like 24 countries, am I?
So it's mostly mRNA. Oh, actually. And is it mostly COVID vaccine? When we talk about the vaccine, is it mostly COVID? No, major three are COVID. Yeah. This one is, you can use,
Yeah.
Was the impact seen especially
the same thing. It's the same thing roughly. Okay, no, June, thank you. It's good to see you. Are you going to be around still tomorrow? At your dinner tonight? No, you're not joining the session. Probably is part of it.
Thank you. Sorry to put you on the spot. Don't mean to. You can understand we're very interested. Appreciate that. Thank you.
I know. I mean,
that's why I'm meeting with the guys here tomorrow because they're still keen.
There need to be more players.
Yeah.
More options.
So and we're going. Yeah, and we'll be doing this week we're dosing.
We'll find out soon enough. I mean, really.
I mean, the point is, one of the reasons why it's such a pain in the young ones is because the airways are by the time they're that's not going to be filled up. But do we know?
Those data.
Yeah, exactly. Yeah, and this year, I mean, I'm not doing they had kids.
So interesting that there's I probably should have
You've got an amazing surname. It's not quite wildebeest, but it's wildebeest.
And boy, she's a wild beast.
Yeah, it's very good.
That's good. Yeah.
So, yeah, very nice. So, are you based?
So I'm not in the US. No, that's Kingdom. Still in Oxford. Yeah, so living still in Oxford and Moderna is opened up a site at Science Centre in South. That's really quite a nice drive. And so yeah.
I will interview him separately from me.
Yeah, we need to run to a meeting, but
Actually, it's been really. I mean, what a program to land at this time with this program of technology. It's very exciting.
There's going to have to be a bit of groundwork on right?
yeah, that's what I hear.
Yeah,
That's what I hear. That they,
I mean, the whole thing that's also in our settings, but
study in the Gambia at the moment to look at pregnancy outcomes, and we were supposed to be comparing equal groups of women with and without vaccination. But you know, the zero prevalence is 96. Yeah, people would, yeah, when we started rolling out, they said, why have you
And he hears me? Hi, you hear me? How are you doing?
I'm fine. I hear a lot of music. Okay, now the music's going away. Oh, it's coming back.
We are not hearing your sounds. Good afternoon it is here. Good morning for you, I suppose. Yes, so I hear you, Jason. You hear music. We have background music. Oh, so you don't hear me? Okay. Yes, Bernie, that's perfect.
Let me just try to put it on the outside here.
How's your back feeling, Barney?
It's a little better. I can at least move around today with a cane.
Yeah.
So it should be out here. Just for a quick test, could you just say a word, please?
Oh, sorry. Yes, talk.
And Barney, could you say something?
Just say some words.
Yeah, I can barely hear you, but I can hear Jason very well.
Yeah, I hear. Yeah, Barney's good.
Oh, can you hear me?
Much better. Yeah.
Now I can.
Okay,
Yeah.
so I suppose it's Louis who will introduce the ceremony in a bit. And then we will have you on the screen. So I'm really, really happy that you were both able to join us today.
Same.
Thank you so much.
We're both disappointed, of course. We can't be in Portugal, but hopefully a future meeting.
Yeah, that's great. Could you put it on the computer again? Or is it better to leave it this?
No, we can put it here. We just can't forget.
Because now everybody is listening along with us.
Should be okay.
Yes? Perfect.
Should be able to hear him here on the computer.
Oh, I can also talk in the microphone if that's better.
Was a speaker.
Better. Okay. No, it's okay.
Microphone 1 and 2 speakers. Okay.
Yeah, I heard. Perfect.
I'm gonna.
Brittany, they were missing your slides.
They're not. I gave them to you.
Yeah.
Oh, that's okay. No worries.
I'm trying to be responsible.
So how are you both doing? Are you okay, Barney? Such a shame you couldn't make it. Not too good? Okay.
Queria perguntar era se eles vão estar os dois ao mesmo tempo no ecrã ou é por causa do
Okay. Yeah.
Não. Estou a mandar para o segundo ecrã porque dimensionei para não aparecer aqueles dizeres e não sei o quê. Mas podem querer os dois lá e se calhar até era melhor estarem lá os dois, não sei.
Two?
Can we ask them to use headphones? Do you think it's possible? If they use headphones?
Yeah.
Because otherwise we're going to have
Echo.
yeah.
Okay. Perfect. So I receive a request from the technical team here. Would it be possible for you to wear headphones with the computer? Because otherwise there may be a chance that we're having an echo here in the hall. Okay. I don't know if we want to risk that, Barney.
They're going to talk simultaneously or it's a order to they talk for the audience?
I can ask them what they want.
Because I can put
Yeah, so it's also an announcement of the winner. So in the beginning, the winner should not be visible, I would say. So then maybe better one by one.
One by one.
And is it possible to change during the session?
Yeah, but okay, no problem.
Yeah, just to check. So this is Barney. I am just explaining our ceremony to the team here. So this is Barney, and he will... oh, Barney, I could not hear you at this moment. Could you say something again, just to be sure? So now now I don't hear you anymore. Since the headphones, I can't hear
the
you.
headphones, because the headphones...
Yes.
Yeah.
Yeah.
Because the headphones, they change automatically the sound source.
Yeah, this is perfect. You hear us well? That's great. So this is Barney, and he will the award that we are rewarding is named after him. So he will hand it to Jason. And in the beginning, it will only be Barney.
Okay.
But I imagine Barney once Jason has been announced as winner, we want you both in the video, right? Or would you say just only the one who is speaking?
Não é isso. Não, estava a ver se estava para pôr os dois. Aquele...
Dá para pinar os dois?
Não. Só dá
Yes.
replace for first screen.
We hear you. So is it easier to have one in the screen? Because that's also fine.
One in the screen is easy. The two...
Okay, I think we're gonna have one of you in the screen. That's fine, we'll do one. We'll do one. Yeah.
Não, mas é ali no segundo ecrã. Olha o que eu digo. É no segundo ecrã. Esquece esse ecrã. É no segundo. O meu problema é
That's
no primeiro. Estou a dizer no segundo. Quero os dois no segundo. Essa ficção final no segundo.
So
Despino de baixo, só chegou. Second screen. Second screen. Ele vai alternando à medida que fala.
yeah, you can come here. Louis and Leila are here, so I'm just gonna... So you have to talk in this microphone for them to hear you.
Hi, Jason. Hi, good to see you.
Where are you? Where are you? Good, good.
Okay. Hi, Barney. Hi.
Hey, Barney. Barney, good to see you. Do we need to talk through the microphone? Okay, that's fine. Yep.
Yeah. Good to see you both.
We already tested the sound in the hall.
Okay. So I must tell you, I'm very nervous, and I'm rarely nervous, but the technical challenges in a very large, with a very large audience, to have both of you on screen, that you can hear each other and we can hear you, but Roxy, but it's working perfectly. But yeah, I wear a suit, and the awardee just wears shorts. Okay. Do you have ET behind you? Are you? Oh.
So you can hear each other? Yeah? Okay. Okay. Okay, so 5 minutes from now, I think we are going to start. Okay? Yeah?
Yeah. Yeah.
You will introduce Barney, and Barney will, yeah.
You summarized it correctly. I will start. The Barney Graham Award will be awarded by Barney, and then Barney will reveal, or at the same time people understand who is the awardee. I don't mind. And then Barney, I think you have prepared a few words, right? You have like 5 minutes to... No, no, no. We have an hour and a half for your lecture, Barney, for all your praise for Jason. But if you can manage to do it in 1 hour, it's also fine. Yeah.
Okay, 5 minutes. It's fine.
Right. So, yeah. Yeah. There is about 500 people audience. I don't know whether they, because it's quite late at the day, but there will be a lot of people. And I'm not going, so go ahead, Barney. I think a lot of people who know, so I think nobody knows, but the people who are here now, nobody. It's up to you. I just don't know technically, and I don't think it's really necessary to blind, or maybe you can close your your
There's one person in the screen.
yeah. Oh, there's
So
only
if Jason keeps himself muted until his name is called, then he won't.
okay, so it will be really a surprise. So Jason, I can tell you that Barney told me it is one of his best moments that he could think of, the Barney Graham Award for you. So, yeah, he told me that he thought this is so much fun. Right. It's the RSV community who is really grateful to you. But I leave those words to Barney. All right. I think I will start prepping a little bit because we're in the big room here. Can I give that microphone back to you? Okay, see you in a second.
So Barney and Jason, you won't be able to see the audience, right? So that's a pity. But we will make pictures and you will see it later, okay? And it's recorded, right? So you can watch the live stream on our website.
Yes.
Oh.
Yes.
But not.
You can watch it, but not with sound.
Oh, okay. Yeah, just one at a time. Yeah. Okay. Okay, great. So I'm going to the front, and then we'll see you. We will be live in a few minutes. Thanks very much, both, for making time for this. Okay, thank you. Okay, bye.
So Barney, could you show again how you're gonna give the molecule to Jason? He's gonna. If he does this. Yeah. Perfect. Yeah. So do you understand if the...
Can I make just one thing, because right now you're in Zoom, so it's the Zoom works as a follow me picture. So the person that is gonna catch the ball has to say something, so your image pops up. We got an alternative because we split the two images back, but in a usual term, as a follow situation, you would have to say a word so your image pops up. Okay. If you want, I'm gonna have the microphones. Perfect. We split it up the two images the same way, but you know this is an outside program, so this might happen. So if we do this way, it's gonna be flawless. Okay. Thank you.
So will someone be here for them to see?
No, I'll be here, and I'll inform. I won't be able to speak on the microphone because the room is gonna be happening. But I'll write a message, just saying you're gonna be up in 10 seconds or in 5 seconds or something like that, just to give you a heads up. Okay? Yes. Yes. You'll be listening to the microphones of the event. But I won't be able to speak to you directly because everybody would listen in the room. So I'll just send a text a message here on the chat saying you're live and so you know and you're not unprepared. Okay. Okay. I'll just leave the music on for now and I'll just turn off my camera. If you need to ask me something, just please use the chat and I'll try to answer the quick as I can. Thank you so much. I'll see you in a bit.
Okay. What's the time?
Welcome back, everybody. I noticed that somebody had turned up the light here. It's quite strong. Can you dim the light a little bit? So we are going to have a short session called the Barney Graham Award. Since the RSVVW meeting in Ghana, we have the Barney Graham Award, of course named after my personal hero in the field of RSV, Barney. Of course, we invited Barney today to be here and hand out the award that was named after him, but for personal reasons he could not be here physically. But fortunately, he has agreed to be here and announce the winner of the RSVVW Barney Graham Award of 2023. So we're now going to check whether we can actually see Barney. We did a rehearsal, so I think, hi Barney, can you hear me?
Yes, Louis, I can hear you.
Fantastic. So, as some of you know, those who have been in the field for quite a long time, many, many years ago, Barney showed up at meetings like this with a Hawaii-like shirt. I know Barney doesn't want to be reminded of this, but it was a shirt like this. It didn't say at the back, the RSVVW 2023 Barney Graham Award by Resvinet. So this is the shirt that is going to be awarded to somebody who has done a lot for the field of RSV, and I'm going to hand over the floor to you, Barney, to announce the winner. I think, go ahead.
All right, well, thank you, Louis. And can you see me?
Yes, we see you very clearly. Okay. A large screen. You're like a film star now.
Well, first of all, thank you. And I'm very honored to have something like this done for me. And usually I think of this happening posthumously, but I guess I'm going to accept the honor anyway, and because I care so much about all of you and all of the things that are being done for the RSV field. And so I wish I could be there today with you, and but I have something to do right now that is going to be a lot of fun for me, because I get to present this award to someone else. And Harish Nair got the award in 2021, which was a great thing to do as well. But that meeting was entirely virtual, so I'm not sure how many people actually got to witness that. And today, even though I can't to be there with you, I want to talk about the person who I'm handing this to. This is a young man who I met in 2008, who came down to our lab and actually said, you know, what do you think I can work on besides HIV? And the story really goes from there, but we have worked together for several years. Most of what we've been talking about the last 3 years is coronavirus. And so it's not only a great privilege for me to hand this to him, but it's also a great privilege to do it at an RSV meeting and have it be about RSV, because everything that happened in COVID really had a thread through the RSV literature and through the RSV field of study. And so I really attribute many of the COVID successes to all the work that had been done ahead of time in RSV. And so you can probably guess who I'm talking about now, but I'm just gonna show you this very important structure that you all know well. and now is becoming part of our vaccine armamentarium from all the press releases and phase 3 trial results that are being published. And so I'm going to hand this to Jason McClellan, the recipient of this Barney Graham Award in 2023.
Thank you, Barney. This is really a tremendous honor to receive the Barney Graham Award. It's been a pretty exciting year in the last couple of years with different awards for a lot of work on COVID, but my heart's always been with RSV. Got my start working on viruses and really structure-based vaccine design on respiratory syncytial virus. And to receive an award named after Barney, who's had more than anybody the most positive impact on my career is it's really special. And also as a friend, Barney, we've gone through a lot. I'm glad I'm able to receive this award while you're still alive and not posthumously. So that's even better. So I'd like to thank Louis, the organizers, the selection committee for this award, and I'm looking forward to receiving the Hawaiian shirt. It's an exciting year for RSV. I think we're going to have the first RSV vaccines approved. All the first ones are going to be based on this pre-fusion RSVF molecule. And just excited to see what comes next. So thank you, Barney. Thank you, Louis. Thanks, everybody. Sorry I can't be there, but I look forward to seeing you all at the next one.
Thank you. So I need to explain, Jason, that we had contact several weeks ago, but you had another award ceremony just yesterday, so he couldn't be here for that reason. Otherwise, he would have definitely... that doesn't look good. That looks pretty shitty. The shirt is much better, and the trophy that you just showed. So anyway, we fully understand that you couldn't be here. So at the moment we can't see Barney. We can only see either one of you. So, but I know, Barney, that we can that you can hear us. Yeah. So we're switching screens now here. Thank you both very much for everything you have done for babies, pregnant women, older adults. Without you, it would not have been possible. I don't know how long we would have been waiting. So I think only very few people know that it takes a lot of effort just to find out this little thing of the pre-fusion. And please share our gratitude with the team that discovered this. And this is really on behalf of the entire RSV community and the children that need this. Thank you very much. And feel free to do whatever you want after now, because you're off the hook. We continue with the program. Bye, Jason.
Thank
bye,
you.
Barney.
Thank you, Louis. Bye, everybody.
Bye.
Thank you all. See you next time.
See you next
Barney.
time.
Take care.
In person. All right. So I will now invite the chairs to continue the last bit of the session of today before we all go for dinner and a celebration.
Yes. Yeah, welcome. Sorry. Yeah, welcome back to session 4, where we are talking about vaccine delivery and uptake. We have 2 more presentations before we do our dinner. I'm Patrick Munyoki from CDC Kenya. I will go straight to invite my distant brother-in-law, Ruzani. He's a pediatrician from Children's Hospital in Cape Town, South Africa. He's a co-director of the Vaccine for Africa Initiative. He's a member of South African NITAG and has recently been appointed in the Regional Advisory Group for WHO Afro region, the regional ITAG. Ruzan would like to share with us and raise some questions on issues on vaccine equity. welcome.
Geez, I'm sure you can hear me. Thank you very much to the organizers, and thank you for the introduction, Patrick. Thank you for inviting me to this place, and I'm really glad that some of you are still here in this graveyard shift. And I hope you don't regret it too much, because I'll be asking questions as opposed to supplying any questions, any answers. So these are my disclaimers, but actually when I was thinking about this, which is what I was asked to send here when I was preparing for this talk, I realized that my real disclaimers are probably these as far as this talk is concerned. The truth is, the whole point of disclaimers is to try interpret what someone is saying and on what context they say what they say, and if they are maybe conflicted by having certain positions. So I value people, I'm committed to the poor, and I'm responsive. To value people means that I will put people before money, before my career, before anything else, because people matter. That's the first part. To be committed to the poor, I'm a pediatrician, so I fight for children all the time. But the ones that keep me awake at night are the children of the poor and marginalized, because they do all the dying, most of the dying. And so I see my job as to respond quite a lot to those whom Frank Fanon will call the wretched of the earth. And that's what I mean. And those are my disclaimers. So when I talk, you can assume that I'm biased, because I value people and I'm committed to the poor. And that are my real, true disclaimers. Now, you may wonder why I'm starting this way. You know, when I was preparing this, I was thinking about Bertolt Brecht, the German playwright and poet, because he asks in a poem, you know, to those who are still to be born, or to those who are later to be born, he says this, you know, what kind of times are these in which to speak about trees is almost a crime, because it implies silence about so many horrors. And so what I'm trying to do here is to move from the trees and put the horrors in context. So I hope, again, you don't regret it, because my job is to disturb you, because I think that's important. But even as I do that with an understanding that many of you share the same biases that I have, and I want you to awaken those biases because they matter. People should, during their awake hours, work on the things that keep them awake at night, because that is called integrity. Now, in my home language, Chivenda, they say things like, which my grandmother keeps on telling me, you know, it means to utter evil or to out evil is so that it may move and good may find a resting place. So that is the reason for disturbing people, so that good can find a place in our economy. And what does this matter? I remember this picture. I think it was used by Rino Rapoli in ESPID in Madrid in 2017. I remember that. And it came from Times magazine in 2015, where what was being said was this American child may actually have the chance to live to about 142 years. A child was born at that time. And the reason for that was because of the great developments that have happened in medicine. And a lot of that have got to do with the control that as humans we've finally managed to have over infectious agents. To contextualize that, he used this montage which shows the history of mankind, you know, before even Homo sapiens, that most of it had actually been spent with the life expectancy below 30 years of age. But over the last 150 years or so, it has grown exponentially, and in particular over the last 100 years. We don't realize that in 1900, for example, American life expectancy was sort of hovering in the mid-40s, and it's now almost doubled that life expectancy. A lot of that has had to do with vaccines and what vaccines have done to change our ability to be able to control infectious agents. But if you look very carefully, you'll realize that life expectancy is not the same all over the world. The reason why it remains lower is because there are people in this world who bring it down because they don't live as long. And a lot of that still has to do with infectious agents. And they're to do with agents for which there is a remedy, that there is a potential intervention that could buy and purchase those lives. And that's what I want to talk about. I hope I've got enough time. I'm probably going to go quickly through a number of slides. So, a lot of children still die from diseases for which an intervention is available. That is a fact. And that is what inequity is all about. The fact that they can't access that which will change their lives. Vaccines have been absolutely amazing. This picture comes from the work of the DARF project at Johns Hopkins, the decade of vaccine economics, which shows that vaccines have been some of the most amazing investment ever made in the last 100 years. In fact, if you listen to Suzanne and Stanley Plotkin in their preface to the textbook Vaccines, they point out that apart from clean water, there's been no other public intervention which has been so impactful as vaccines. And when you actually look closely on that investment, what you start realizing is that although they are so cost-effective, the greatest cost-effectiveness accrue mainly to the poor and marginalized. And that's for a very simple reason. Because when you are rich and you get sick, you can go and see a doctor or a nurse or something of the sort. And then they would probably have medications for treating you. And then if you things really go bad, you can end up in ICU. When you're poor, you just die. And so vaccines are much more of greater benefit to the poor and marginalized than to the rich. That is just a fact. I mean, I'm just showing you this picture, for example, of the distribution and the ratio of healthcare workers to the population. Look what happens with the poor countries. This is what you get compared to, this thing is quite funny, but don't worry about it. So this is quite important. And for vaccines, what I think matters is to realize that even when you look at them, that inequity shows it's no longer moving. Oh, okay, it's moving now. If you look carefully in this picture, for example, you realize the red areas shows where low vaccine coverage is taking place. And it's quite clear where that is taking place. These are children who don't receive the expected doses for vaccines. And if you actually go quite closer, and I'll show you the next picture, one of the reasons why this happens, and that's the first reason why inequity exists, is just the cost of vaccine doses. The more expensive the doses, the less likely children of the poor are likely to get it. It's as simple as that. It's a matter of economics, of money. That's what happens. You can see it's easy to give BCG and oral polio vaccine and so forth, but as you start looking at other newer vaccines like conjugate pneumococcal vaccines and so forth, there is less and less of them who receive those doses. And to just prove that it's about money, you can see this picture here where you can now see that in an area, I mean, these countries, of course, are high income, these are upper middle income, but these are actually low income that receive Gavi assistance, and they are higher than lower middle income that don't. The simple fact is, if you buy doses, more children get vaccine doses, they just don't get them because no one can pay for those doses for them to receive that. But maybe that simplifies things. Things are much more complicated than that when it comes to equity or inequity, because that's probably right. Is that the cost of vaccination is not necessarily, am I on the way? The cost of vaccination is not actually just the cost of the dose. It goes beyond that. The cost of the vaccination program is probably higher than that of the dose. Some of you will remember that once poor countries eventually got vaccines through the COVAX process, for example, for COVID, what happened is that a number of them couldn't even deliver those vaccine doses because they had no infrastructure for delivering those doses. And that's the second reason, apart from the cost of the antigens that are needed, it is just the cost of the program. A lot of it, which we call this, you know, the hidden costs of vaccines, is actually the program doses, the program of capacity for delivering those vaccine doses. And then we did this study with one of my master's students, where we actually realized something which is even interesting, is that a number of children, even when they get the doses, they get them much later than they should get those doses. And for every dose from birth, the vaccine coverage declines. And these are for vaccines that are actually given free of charge by the state. Why would that happen? Because there is another huge cost for poor people. Those are transaction costs. If you're a seasonal fruit picker, you have to sit there and ask yourself whether you're better off going to work where you'll get fired if you don't pitch up for that season and feed two other children, or whether you want to take this child to the clinic for that vaccine dose. The barrier for accessing vaccines, even when they're free, is much higher for poor people. What is worse is that in other communities, you may find that there's also a differential in whether the community values boys more than girls. And girls are then just screwed by not actually being presented for such interventions because it is just too costly for someone who is not appreciated within their society. That's just, again, what happens for the children of the poor. Thirdly, I think, which we know, and I was really glad to hear the companies talking about trials taking place in low and middle-income countries. When you look at where research is done, a lot of the research is not done in poor areas. And that may seem like it doesn't matter too much, but it does. First, it determines what is research and what is prioritized, because you only pay for that which matters to you as a general rule. And if you don't have the money, you can't invest into that research that is required. But secondly, and I'm just giving an example, we now know that the information, and that came up when we were talking about policy, that the information derived from that area is what informs policy and what informs what should happen. And now we even know that vaccines don't actually work the same way in every community in the world. I mean, I'm just giving the example of rotavirus. The vaccine efficacy of rotavirus is not the same in South Africa, in Malawi, and in Europe. So if you don't do trials where majority of children live, you don't actually know what works. You just extrapolate that it works the same way as it's done in a high-income country, and it may not be the case. For many reasons, we're starting to understand the effect of microbiome in how we respond to vaccines, et cetera, and there are many other conditions. And I'm just giving, as I continue with the same theme, the RSV. You remember the Novavax, how we were excited that it will come through and it will work, and then it didn't work. It was deemed not to work. And one of the reasons that it was deemed not to work is because it had didn't make the primary endpoint. That's important. And of course it has to if it's wanted to work. But when you actually delve deeper and you disaggregate the data, the vaccine worked very differently in what was high income and low income. And you must remember this, that a vaccine which may have a low efficacy in a high disease burden has got a huge impact, because the impact of vaccine is not so much multiplicative as much as the additive impact. You use an additive model to see the population attributable impact of that vaccine. We know this because we're going to probably accept a low vaccine efficacy in malaria because the burden is so large, and that vaccine can still make a difference. And that's why investigating things in certain populations, it makes a difference, because for that population, it may be a lifesaver and may change things, especially when it avoids death. So, I don't have a lot of time, so let me try to start move towards conclusion. Erin mentioned the issue about when a successful vaccine candidate may come into the scene. What will happen then? I mean, this is a story of pneumococcal conjugate vaccines. If you move down the ages and see more countries having an uptake of that vaccine, finally, by 2021, children of the poor and marginalized had to queue for about 2 decades to get their turn to that vaccine. Sorry, let me just... The rollout of vaccines follows money, not death. It is not those who need the vaccines the most that receive them. It is those who are rich. So maybe this child will live to 140, but not this one. Equity is not about equality. It's about prioritizing those who desperately need it. So, as I conclude, you may wonder why I'm telling you these things and why it matters. Because why should you bother about children in some backward countries that die because their countries are corrupt and probably they don't spend money very well? Maybe it's not that important. But here it is. You know, there's a Zulu saying where I come from that says, Umuntu muntu ngabantu. It means I'm human because you are, because your humanity affirms mine too. Or if you like, you can take it from John Donne, who says, no man is an island, you know. Each man's death diminishes me, for I'm involved in mankind. So send not to ask for whom the bell tolls, it tolls for thee. That's the first reason why it should matter for you. The second reason why it matters is because until everyone is free of vaccine-preventable infections, even the rich will not be free. You will vaccinate against polio and measles until it's eradicated, and it can't be eradicated until there's vaccine equity. That is how we managed to get rid of smallpox, because we managed to make it accessible to everyone. And thirdly, that adds to the cost burden, which is perpetual. As long as newborns are born with an immunity gap because they are not immune, you will have to vaccinate them perpetually into the future if you need to protect yourselves. No one is safe until the poor are also safe. And finally, which I think is an important thing for me, I mean, I've spent the last decade fighting for vaccines and supporting vaccination within the African continent. But it's really hard to preach and support vaccination when those that you preach them and you encourage to vaccinate cannot get those vaccines because they cannot access them. So I was actually thinking about Popula Nehuda when I was putting this, who says, you know, you may ask, why doesn't his poetry speak of dreams and leaves and the great volcanoes of his native land? Come and see the blood in the street. Come and see the blood in the street. Come and see the blood in the street. Thank you.
Yeah, thank you, Ruzan, for that excellent talk. Very touching and very deep. We have time for one comment or question from the audience. You can move to the microphone.
It's that, I can run away.
Can I ask a question? Can I ask a... So while he's going to the microphone, just, Ruzan, thank you, it was really, really inspirational, kind of. I want to go more, a bit outside of your talk, because I thought you were going to mention this, but the manufacturing power in Africa. So, you know, there is a lot of discussion now, should we move, and probably if we do that, if there is local manufacturing, that can provide some equity to the market. So I just would like to hear your thoughts, if you think it's possible, and what needs to be done to have a manufacturing in Africa.
So Martha, it's an important question. I'm involved in a working group of the Partnership for African Vaccine Manufacturing. partly because we believe that having local manufacturing is another way of reducing the inequity. First of all, how you deliver them, how far you travel to do that, which add the cost of logistics, but also whether you can initiate prioritizing what matters in that instance. The difficulty is that the entry barrier is quite high, because if you're making a vaccine that's already available and someone can make it at a fraction, which is the case when you enter the market, it becomes very, very difficult. So you need investment that will invest nonetheless, even if there is slightly higher cost to develop local manufacturing. We believe it's an important issue in terms of equity. Yeah. Thank you.
Thank you for your interesting preach, a scientific preach. I have a dilemma, and I thought you might want to respond to that. You said you were very happy that trials are done in poor resource settings. And I think what you meant is you want to see them done over there so that children get access at the end of the day in an effective way to those vaccines. But it is not always easy to see the vaccines that are trialed or tried in countries to actually get them there after licensure. And there is some tension also from society, companies, to commit to get the vaccines after the trial has been done. Can you explain how you see that? So you're enthusiastic that the trials are done there, but I think we can only be enthusiastic once the vaccines are in those countries.
I absolutely agree. I mean, look, it's been very exciting listening to the science here and the future, what the future could look like. But it ultimately matters if you can dose vaccines into people, right? So that is absolutely true. The issue is that when we have wanted to respond to a crisis and we accept it and own it as such, we've got amazing creativity in finding ways of overcoming barriers. You just have to look at how we responded to COVID-19 when it came up. And that's the reason why I was saying I'm not so much giving answers as much as creating enough disturbance to ask ourselves, these creative, amazing people that you are, of what we can do to do that. And there are ways where people have tried to do that, where we've changed things at local levels, including education, including getting governments behind us. I mean, I serve in South African NITEC, for example, and there have been a number of creativity. The way, for example, we introduced pneumococcal conjugate vaccine in the South African schedule was actually quite creative, given the times in which it was, to try to convince the government of the benefits of that vaccine at a different cost. I think we're one of the countries in 2009 to introduce the 2+1 schedule by interpreting science into our context and putting a different time as well with the booster at 9 months to cover the tail that will go into the second year. So I think when people, before COVID-19 vaccines were introduced, everyone thought, they need -70 degrees Celsius, there's no way of, but we knew that once a vaccine was there, and if there is a will to get it there, we've got enough creativity to do that. And for me, that is the will that I'm asking for.
Thank you.
Thank you, Ruzani, for that excellent talk. Our next presenter is Rupali Limaya. He's the Deputy Director of the International Vaccine Access Center at Johns Hopkins Bloomberg School of Public Health. Dr. Limaya will be presenting results from a study in Kenya that explored the demand of RSV vaccines among pregnant women, lactating mothers and their partners, as well as community leaders and policymakers. Welcome.
Yes. Thank you so much for having me. I think I am missing the clicker.
Ruzani took it. Ruzani, where are you?
Sorry. Okay. Well, thank you so much for having me. My name is Rupali Limaya. I'm at the Johns Hopkins Bloomberg School of Public Health, and it's great to be here today. And a hard act for me to follow. So today, what I'm going to talk about is a project that is called MIRI, which is the Maternal Immunization Readiness Initiative. And the goal behind this project is to conduct research to inform the future delivery of new maternal vaccines. So this includes COVID-19 vaccines, RSV vaccines, and GBS vaccines. There's essentially three sort of legs, if you will, or work streams of this project. There's an immunization readiness work stream, which focuses on developing tools to assess readiness of MNH facilities for delivery. There's a maternal immunization policy work stream, which assesses the policy environment, and I've put on there where you can actually look at this, that tracks policies related to vaccines given during pregnancy. And then there's the demand generation and communication work stream, and the goal for that work stream is to gather insight on knowledge, attitudes, and behaviors relevant to really help design communication strategies. And Ruth Karen, who's here in the room, is the PI of this overall project. So let me talk a little bit about some of the work that we did related to demand generation, focusing on RSV in Kenya. Our overall goal of this study was to explore factors that could really influence the decision-making process with regards to pregnant and lactating women related to their RSV vaccine intentions. In terms of how we did this, so I'm a behavioral scientist, and one of the things that we spend a lot of time on when we're thinking about vaccines is that we know vaccines don't save lives, but vaccination does. So it's really important for us to think about how do we narrow that gap. One way to think about that gap is that we know people make these decisions not alone, and it's not static. There's a number of influences that individuals have when they're making these vaccine decisions. So we took this lens, this socio-ecological lens, when we think about vaccine decision-making in any context, including maternal vaccines. So for example, at the individual level, what's very important is how individuals are perceiving their risk related to a particular infectious disease agent. That's severity as well as susceptibility, for example. At the interpersonal level, we know at the vaccine level, norms are very important, what you think your friends and social networks are doing. At the healthcare system level, one thing that has shown to be consistently associated with vaccine uptake is a strong provider recommendation. And finally, of course, at the policy level, vaccine mandates have an influence on vaccine behavior. So we took this model in terms of this study, and what we did is we developed a mixed method study. So from a qualitative perspective, we conducted in-depth interviews. From a quantitative perspective, we administered surveys. So a question might be, for those of you, most of you I think in the room are clinicians, I am not, why mixed methods, right? Why did we want to use this type of approach for our design? And the important thing for us is that we wanted to make sure that we could really conceptually and analytically integrate these two pieces of data so that we can really get a sense of how best to really develop and inform demand generation strategies so that when an RSV vaccine is ready, we'll be able to be persuasive in influencing pregnant and lactating women to take this vaccine. So this is our methodology. You can see our participants. We did a total of 60 interviews, and you can see we spoke to pregnant and lactating women. We spoke to community members that included gatekeepers, relatives, as well as male partners of pregnant and lactating women. We spoke to a number of healthcare providers, so midwives, nurses, doctors, immunizers. We also spoke with policymakers. So we did a total of 60 interviews. Then we did a total of 401 surveys, with 200 happening in a rural area and 201 happening in an urban area. So again, we sampled from 2 districts to do this study. So this is just a breakdown so you can get a sense across the different target groups that we interviewed or surveyed, how this all broke down. Again, Nakuru is a rural county and Mombasa is an urban county. So you can see how many from pregnant and lactating women, healthcare workers, et cetera, we interviewed in both. So with regards to the analysis process, one thing that we did with regards to the quantitative analysis, we started with cleaning. We did some preliminary data analysis, which I'm going to present today. This was all managed by Stata. And then from a qualitative perspective, we used open coding. We used something called grounded theory, which I'll talk about in just a moment, where you essentially code transcripts to really identify emerging themes. And we used the software Atlas TI to help manage our data. So with regards to grounded theory, it's an inductive approach. So it's very different than most of the quantitative approaches that you've probably seen. And really what you do is you use data to develop a theory. So it's not the other way around. You don't have a theory and then you test it, but you actually use that data to determine why someone is engaging in a particular behavior in this case. How does this look like in practice? Well, what happens is that you end up looking at transcripts of these interviews. You do something called open coding. You then develop concepts or themes that are emerging. And from there, you go through a bit of an iterative process to understand what themes are sort of comparative and are across the different target audiences, and what are the distinct differences. So let me tell you a little bit about what we found from our qualitative work first. So one of the things that we were very curious about is how pregnant and lactating women in Kenya were describing RSV. The interesting thing that we found is that there were more than 30 terms that were used to describe RSV and or wheezing that was associated with RSV. So the most common term that came up really was pneumonia, including acute and severe. Pregnant women and lactating women, as well as community members, also tended to use the flu, common cold, or asthma to describe RSV. And then finally, terms containing respiratory were only used by healthcare workers and policymakers, right? So a distinct difference with regards to how individuals are actually conceptualizing RSV. So another key point that I wanted to highlight here was that only 17 out of the 60 participants had ever heard of the term RSV when we started the interviews. All of them were either healthcare workers or policymakers. So when we developed the data collector training, we realized this was going to be an issue. And so what we decided to do during the data collector training is we found a clip of a baby wheezing. It was less than 5 seconds long. And so what we first did is in the interview, we first asked participants, have you ever heard of RSV? We got the 17 out of 60. Then we showed them this 5-second clip of this baby wheezing, and all of a sudden, 57 out of 60 of our participants said yes. They knew exactly what this was. And so again, there was 3 that did not know what it was, but an interesting point is that we need to think about how we're gonna market this vaccine when it's actually available, because most people aren't calling it RSV. So an important key finding here. In addition to that, we really wanted to know, particularly from pregnant and lactating women, what sort of questions they had about a potential RSV vaccine. And these were the top 5 questions that came out. So the first really had to be, of course, related to safety, which is not really surprising. What will be the potential side effect or risk of the vaccine for the mother or the baby? The second was really, how does the vaccine work? How does it protect the mother, and then how does it protect the baby? And then the question that came up that was related to this is that why will the mother be given the vaccine and not the baby? Really indicating that there is a need to educate and think about what does maternal vaccination mean. Another key question was really, when will the vaccination schedule be? Many women were concerned about what trimester this would be recommended, how many doses they would get, what were the benefits. And then the last one, which we thought was really quite fascinating, is when individuals asked about effectiveness of potential RSV vaccines, they really wanted to know, and I think this is very much informed by COVID, will it prevent infection or will it reduce severity of the disease? And I think this was literally because data collection happened after the COVID vaccines had been rolled out for about a year. And I think this was a key question that women had and they wanted to know. And the follow-on from this was, if it does not prevent infection, they weren't so interested in the vaccine because of what happened with COVID. So I'm gonna go through just some of the themes that came out in the interest of time. When we asked individuals what really causes RSV, we got very differing responses. So for example, from this lactating mother in urban Mombasa, we heard, I feel it is caused by a dirty environment. When you're using the same things, like someone is having a bad sweat and you're using the same clothes, or house utensils when you're touching them and using them together. Another lactating mother, this time from rural Nakuru, mentioned that I can say that it is caused by a virus, but mostly during the cold season. It is associated with coldness. First, it is caused by a virus, I would say. The virus during the cold season is when it is more active and when it grows more. Male partners had a little bit of a different perspective on what caused RSV. And here's an example of one of the male partners of a pregnant woman from urban Mombasa. He said, the baby sweats. The sweat makes the clothes they are wearing wet, and it affects the baby. That is what we feel is the biggest reason for this illness infecting babies. So again, just an illustrative example that there's very differing understandings of what's actually causing RSV depending on who you speak with. We also asked about their experiences with RSV. As I mentioned, we first asked point blank if they had heard of it, then we showed them this video, and all of a sudden, almost everyone had heard of RSV. So using that prompt, we then wanted to ask what sort of experiences they had had with RSV. One example is from this lactating mother in urban Mombasa, where she says, I have seen some children breathe like that, but they often dismiss it as a cold. They are given medicine and it eventually stops. I have seen some neighbor's child that was very young and was breathing with difficulty, but the child did not last. At night, the infant was taken to the hospital and the breathing even got worse. On the second day, the child passed away. I've seen this with my own eyes. And this came up again and again and again, that women delayed seeking care for their infants because they dismissed it as a cold. This healthcare provider from urban Mombasa mentioned, when RSV is setting in, the mother will say the baby has a common cold because that's what they call it. The baby will just stay at home and the mother will give it an antihistamine. And that won't help him. So in 3 or 4 days, when the condition has worsened, that's when they'll bring the baby to the hospital. Then the chest is already congested, you'll need to nebulize him, and for the first week, the mother has to stay with the child and monitor him at home. Sometimes they may not give that kid anything. So very different perspectives with regards to health care-seeking behavior, I would say, among mothers when they thought their child had been infected. One thing that we really wanted to get at was self-efficacy. In a lot of the countries that we work in, not just related to an RSV vaccine, but polio, for example, and pneumococcal, as well as rota, a lot of times the male partner is the one that's making the decision as to whether or not the child is able to get the vaccine. So we wanted to ask the pregnant and lactating women, when asked who's responsible for making health decisions, including vaccine decisions, 13 of our 18 lactating mothers reported themselves as the primary vaccine decision maker, and 5 out of 6 of pregnant women reported themselves as the primary vaccine decision maker. So a bit surprising, simply because we know that male partners have such a strong influence with regards to not only vaccination for children, but vaccination for the mother. And finally, when we asked if an RSV vaccine was recommended for pregnant and lactating women by their primary healthcare provider, and it was essentially endorsed by the government, by the Ministry of Health, what were people's reactions to this? Well, this healthcare provider from urban Mombasa says, pregnant women will be hesitant. The perception is that when a mother is pregnant, she should not take any drugs or any vaccines. They believe that in case they get vaccinated, it will affect the baby. Then, when you break it down and you look at pregnant women's perceptions, this pregnant woman from urban Mombasa said, it might take a lot of convincing, because getting a disease that affects 1 in 10, I still don't think that is a reason for me to get the RSV vaccine. We have to be 9 over 10, and we know that the disease is really, really, really bad, you know? Similarly, this lactating mother from urban Mombasa says, I will ask questions, but I will not refuse to receive those vaccines. But they will have to explain to me before being jabbed, because also nowadays, many vaccines are coming, but we do not know what they protect us from. So some really interesting perceptions with regards to the different kinds of experiences that pregnant women and lactating women have had that would help inform their future vaccine decision-making experiences related to RSV. Let me switch over and now talk very briefly about our results from our survey. As I mentioned, we administered a survey to 401 women. You can see that of those, we had about 101 that were currently pregnant, and we had about 300 that were currently lactating. So you can see that our sample essentially, it weighed closer to a younger population, so almost 67% were between the ages of 18 to 29. I should note that we did not include, we excluded people in their first trimester in this study, but you can see here that in the trimesters, we had more women in the 3rd trimester. The majority of women had at least a child. You can see 1, 2, 3. And in terms of education level, most mothers had at least completed primary school. So in terms of some of the items, as I mentioned earlier, I'm a behavioral scientist, so we wanted to think about what are the different constructs that go into whether or not a woman decides to accept a vaccine. So these are just some of the items that we measured in our survey. So we measured, for example, perceived prevalence, i.e. we asked their level of agreement related to the majority of babies less than 2 years of age get RSV. We asked about perceived risk, so we focused on susceptibility of the baby as well as susceptibility of the mother, severity of the baby, and severity to the mother. We then asked 2 questions related to social norms, so what they think others around them are doing, and what they think others around them think they ought to be doing, what they should be doing, which is called a subjective norm. We then also asked about self-efficacy, whether they had control over whether or not they could get a vaccine. We asked about barriers. We had several safety questions, as you can imagine. And then we also included and adapted the VHS scale, which is the vaccine hesitancy scale, to get a sense of whether or not these pregnant and lactating women might be vaccine hesitant. And for that, essentially, there were 4 questions. One really focuses on immunity. One focuses on whether or not they've delayed a vaccine in the past. One focuses on whether or not they delayed a vaccine while they were pregnant. And then the last one really focuses on whether or not they delayed or did not get a vaccine for their last born child. So in terms of what we found with regards to the knowledge, attitudes, and behavioral constructs, the only thing where there was a difference between currently pregnant women and not pregnant, i.e. lactating women, was really perceived risk. Everything else was not significant. There was no differences between those that were currently pregnant and those that were lactating amongst these different types of constructs that we measured. Now, in terms of moderate to high vaccine hesitancy, so we wanted to get a sense of which constructs were related to higher vaccine hesitancy. And what we found here, which I think is really interesting, is that essentially age played a huge difference. So if you are younger, you're much more likely to be vaccine hesitant, the 18 to 29 group. Similarly, if you're in the 3rd trimester, you're much more likely to be vaccine hesitant than if you were not currently pregnant. And the number of children also played a role. You can see here, the more children you had, it was a protective effect, meaning you were less likely to be vaccine hesitant the more children that you had. Finally, education also played a role. If you had a primary school, if you had completed primary school, or you had a college, university, or degree, you were much more likely to be vaccine hesitant. So with regards to other factors that came out, one was if you had previous vaccination during pregnancy, this had a protective effect, meaning you were more likely to have lower hesitancy if you had been previously vaccinated during your pregnancy. The 2 other constructs that came out as significant in this regression also focused on low supportive norms, meaning that if your family didn't encourage you, if your friends didn't encourage you, you were more likely to be vaccine hesitant. And similarly related to low self-efficacy, if you felt like you didn't really have perceived control over whether or not you got a vaccine, you were also more vaccine hesitant. Finally, what we wanted to do is we asked about a number of different concerns, because we had heard a number of different concerns during the qualitative interviews, so we wanted to get a sense of a rank order of what was most concerning to them about a potential RSV vaccine. And in this case, you would look at the columns, so going down, and essentially the biggest sort of concern mothers had was really side effects of the vaccine, which is no surprise. The second had to do with ingredients. The third had to do with availability of the vaccine at their facilities, so just their ability to be able to access a vaccine, and so on. So just in terms of a quick summary, because I know I'm almost out of time here, I think from the qualitative part, what was so fascinating, as I mentioned earlier, many terms were used to describe RSV, but no one used the term RSV, except healthcare providers. In addition to that, participants immediately understood RSV when we showed them that 5-second video of a baby wheezing. It immediately clicked, and you could see it in their eyes, actually, when we did the interviews with them. RSV vaccine questions, i.e. the types of questions these women would want answered before a vaccine came out, really focused on safety, who the vaccine will protect, and again, the effectiveness, what I talked about, whether or not it will prevent infection or if it will reduce severity of infection. Women reported high levels of decision-making power, and one thing that I think is very clear is that vaccine acceptance, for people to accept this vaccine, it's going to be important to have adequate risk perception and compelling benefits. Finally, in terms of the quantitative results, moderate to high hesitancy, as I mentioned, was associated with older age, those in their 3rd trimester, those who had no children, and those who had higher levels of education, as well as lower supportive norms, as well as low self-efficacy. So I just want to give some acknowledgments here of the team that did this, as well as ethics approval and the data collection teams, as well as funding. And I think that is my last slide. So thank you so much.
Thank you. We have time for 1 or 2 questions. Yes?
Hi, thank you very much for your presentation. This is Ting Shi from University of Edinburgh. I'm wondering, I'm not sure if maternal vaccination will be efficacious in preterm infants, as there might not be sufficient antibody transfer. So I'm wondering whether your study has considered that. Thank you.
It's a great question. We haven't asked about preterm birth specifically. What we found out is many mothers were concerned much more, they were prioritizing the side effects that the vaccine would have on the baby versus the side effects they would have on the mother. So I'm assuming preterm would fall under that. But we didn't ask specifically about preterm birth. But again, the biggest concern was safety related to the unborn child.
Thank you very much.
Sure.
Hi, thank you very much for your talk. Farina Shaban from the UMC in Utrecht. I have a speculative question. You mentioned that you also measured the number of children that the women had already had, as well as whether they had delayed or denied vaccines previously. I wonder whether you have maybe explored the explanation behind why more children before this pregnancy or child currently lactating, whether the push for less hesitancy rather comes from experience of an ill child, i.e. those who had refused or delayed vaccine previously had experienced potential sickness with a child and therefore were less hesitant with this child, or whether they had accepted vaccines before, not experienced any issues, and therefore also were less hesitant now.
It's a really good question, and these are our preliminary results, and so we haven't gone through and looked at all of the data in that way. We did ask a question about their vaccination behavior with regards to their last-born child, because we know that that's a predictor of how you will act with your next-born child. And so I think what we would want to do is try to see if there's a mediating or a moderating effect, actually, with regards to whether or not you did delay with your last-born child, and or if you delayed during your pregnancy, i.e. you didn't get tetanus toxoid, right? And so actually that's going to be the next step that we want to start to take a look at with regards to some of these vaccine behaviors as well as the hesitancy. So yeah, thank you for raising that.
Thank you very much.
Yeah. The last one.
Thank you. It's a wonderful study and a nice presentation as well. I was wondering when you were telling about the focus group and RSV, I was wondering how did you manage to explain what RSV is to pregnant women? Not many of us who are healthcare practitioners might have even heard of RSV.
Yeah.
And then you explain that with a 5 seconds clip. The question is, I think that it is really risky, don't you think, that you show a 5 seconds clip and then you make a focus group discussion on how acceptable it will be for pregnant women to get a vaccine for this condition. The question, so it's not specific for RSV. I think your research can really have broad implications where pregnant women, how likely are you to be accepting a vaccine for a condition that causes similar symptoms? So do you think the implications of this study go beyond RSV, like for influenza vaccine in pregnancy or others?
It's a really great question, and one of the reasons that we decided to show the video is that when we were in Kenya for data collector training, the data collectors told us no one is going to know what RSV is, right? So the problem is, how do we think about vaccine intentions and ascertain how people are going through that decision-making process if they don't know what RSV is, right? And that's why we started with, do you know what RSV was? And when people essentially all said no, that's when we realized we had to show that video. I think in terms of when you're doing this kind of work and you're thinking about hypothetical vaccines, you have to think about attributes that people are using to make that decision as to whether or not to accept to get a vaccine, right? And one way that we've done this, and in other studies, we've used something called discrete choice experiments, which I'm sure people have heard of, where you essentially look at two different factors and you weigh them against one another. I think that this work is really hard because it's hypothetical. And so part of it is thinking about how do you frame it in a context that a pregnant or lactating woman will be able to understand, right? And then hopefully then, therefore, give us some level of accuracy with regards to her vaccine intentions. It's not a perfect science, right? We're not gonna really know about uptake until we actually have a product. But I think for this, it's still important for us to go through this process so that as we're working with ministries and we need to think about how to create demand before a vaccine product is available, this gives us at least a snapshot and an insight of how we would develop communication strategies. And so I think it is applicable with regards to influenza. I think most women know what influenza is, though. So this was very interesting and a little bit difficult for us. The other part of the study that I didn't present on today was also GBS. And we also had a very similar issue, that even the data collectors and the healthcare providers that we spoke with didn't really know what GBS was. So I didn't present on those results today, but we had an even harder time trying to explain to women, this is what GBS is, this is the types of effects that this will have, and we really want to ask you, how would you think if there was a vaccine, what kind of behavior you would engage in?
Thank you.
Sure.
Thank you. Thank you for that fantastic presentation, and I'll follow you up to know whether to get your recommendation, not now, during dinner, how best we can create awareness actually on RSV during the, especially for the rural population. So thank you all for turning up for this last session of today. I will now hand it over to the organizers for.
So just a very short householding announcement. So there are buses for the dinner, the ones who have registered for the dinner. The buses will come between 7:30 and 7:45. So be there at the entrance of the hotel, and then you can join us for the dinner. Hope to see you there. Okay, thank you.
Regarding this presentation, how many languages do they speak in Kenya? And how, yeah, to translate, they need to translate in many languages.